Hey, what's up guys? Welcome back to another video in the Spigot series. Yes, you just clicked on a 30-hour video of me showing you how to make a replay plugin. But yeah, over the past month or two, I've been on stream making a plugin where you can record every single player action within a certain region, along with other entities and block changes, and all of that saved to a database, and then you could replay it back, and then you could see exactly what happened as if you were there. It's really cool to see, so let me give you a little demo here. So yeah, hopefully you found that demo to be interesting. That's just a small taste of what you're going to be able to make in this episode. You may be curious why I just dropped an entire video on this instead of breaking it up into different episodes. The first reason is because I like to start stuff like new series and then don't finish them. And then also I think it's more digestible for you guys if you have one single video with timestamps where you can basically, see the whole entire process from start to finish. So that's exactly what this video is. It's me showing you how to make a replay plugin from start to finish. You get to see my entire thought process on how I do something like this. You get to also see me fix really challenging bugs in real time, and yeah, you're going to learn a lot of different things in this video, I hope. One of the things that you're going to learn is packets. You're going to be really proficient with packets after watching this, I hope, because we're going to have to send many different packets. The way that this replay plugin works is we record stuff into a database, but the way in which you replay stuff to a user is completely with packets, because packets is how you can send fake data to make someone's Minecraft client think that something's happening when it's really not. So there's a lot of different packets that we have to learn how to send. We have to read the packet documentation a lot. We have to send some tricky packets that you've probably never seen before, and it's a lot of packets. So I hope that when you're done watching this, if you actually go through the entire thing, you should know how to do packets at a very high level. And then also NMS. So the reason I have NMS in this is because I was going to do everything using packets, and that's true except for one thing. I could not figure out how to spawn a player using packets. I just could not figure it out, even though it should be possible. So I'm using NMS for spawning players only, but for any other entity that we record, it'll be spawned using packets. Another thing that you'll learn a lot about is MongoDB. We're going to be using this to store all of our data from our plugin into a database persistently. I'll go into more detail on this later, but the reason I chose MongoDB is just because it's way easier to store the stuff that we need to store in a MongoDB database versus a SQL database, because SQL databases have, very strict requirements, and yeah, it was just way easier with MongoDB. As you'll see, it's pretty awesome what you can achieve. And the last thing that I think you'll learn is a little bit about concurrency, which is something that I didn't think would be even a thing when I started coding this, but as I started coding this, I learned that you'll get a lot of issues if you don't think about concurrency. Basically, we have all these tasks and these threads that are doing stuff asynchronously and synchronously, and they're modifying the same data structures at different parts of the application. And we need a way to make sure that our data structures don't get concurrency modification exceptions and other really annoying issues that will make our plugin not function correctly. So you're going to learn a little bit, like I did, how to manage concurrency in an application like this. So hopefully that's a little exciting. That's all advanced stuff that I think everyone should learn. Before I get started, I want to specifically thank Mark. Mark has been someone who has been part of this channel for a couple years now. He's been one of my top donators in my streams and off stream as well. I just want to thank you so much for all your support, Mark, over the past few years, honestly, and you're awesome. Thank you so much. I also want to thank everyone else who's a member currently on this channel, or even if you're not a member, thank you for even watching my videos, subscribing, liking, all of that. So I really appreciate all of you guys. I just graduated from college, and this is I feel like this video is my master's thesis. It was a huge amount of work put into this, so Thank you guys for the support over the years, and I love you guys. I don't expect a lot of people to watch the entire video, to be honest. I know people will skip through it, but my goal is that you learn a lot from this. That's my primary goal here. So the final thing that I want to say, guys, before I continue is that number one, we have a Discord server, so make sure you join that, link in the description below. Number two is that in the description below, you'll see timestamps for every single part of this video. It's all been documented so that you can skip to specific parts of me showing you how to do something specific. So like, if you want to skip to the part where I show you how to do MongoDB, you can do that. If you want to skip to the part where I meow the national anthem, you can do that, okay? So anyways, that was a lot of talking, but I had to give an introduction for this insane video. Let's get started here. Let's go! Alright, so I've just created a new project here, so what we're going to do first is install all the dependencies that we're going to need for this entire project, so we can just get that out of the way. And so, first I'm just going to rename this main class here to security cam. That's the name of our plugin, so I think the name here looks more proper that way anyway. So yeah, we're going to go to our pom.xml, and this is where we can install all of our dependencies, just as we always do. If you want to use Gradle, you can. I've never actually used much of Gradle except when I do mod development. But yeah, it's really up to you. So the first dependency that I'm going to use is called Lombok. You may have heard of it before. This is just a simple utility library that adds annotations to Java, so you can make Java classes have getters and setters automatically, have constructors with all the arguments, have no argument constructors. It just creates all those things automatically for you, and it makes it a lot easier. It makes your classes look a lot better just because it has less stuff in it. So we're going to install that, and I'll just show you guys how to use it as we're making the plugin. It's very, very easy, so you don't have to worry about that if you've never touched it. So just as easy as that, we've installed Lombok, and I'll have a link for all the dependencies that we're using in the description below, so don't worry about that as well. You'll have everything that I have, okay? So the next thing that I'm going to be using is called Simp API. You may have heard of this as well. This is a library that I created specifically for this series that allows me to make Minecraft plugins way easier. So it has a bunch of utilities like color translator for hexadecimal colors, skull creator, this is for creating player heads with skins, menu manager for inventory menus, GUIs and stuff like that, and then command manager. So what we're going to be using from this is called menu manager, and also something that's not listed here is the item util, so we can create items really easily. So yeah, if you've never seen Simp API before, I have videos on how to use it and how to work with it and all that fun stuff. So go check it out if you want to. But yeah, it's pretty simple. So we're going to just go here to Maven, and then we can see all the dependency information. So we need to first copy this repository thing here. And then we'll go back up here to our code, paste that, and then we're going to take the latest dependency on Simp API and just paste it. So at the time of recording, it's going to be 4.5.6, okay? Alright, so the next dependency that we're going to be using is Adventure Library. This is, again, something that I already have a few videos on, so make sure to check that out as well. It should appear at the top right here. But yeah, this is it has a lot of utilities for sending messages to players really easily, setting boss bars, titles, stuff like that. What we're going to be using it for specifically is boss bars. So whenever you're replaying a recording, it's going to show a boss bar at the top that shows the part of the recording that you're looking at. So just like YouTube, it shows where you're at in the video. We're going to have the same thing using a boss bar. And we're going to use Adventure Library for that because they make it really, really easy, okay? So to do that, we're going to go to Platforms, then go to Bucket, and here you just have to copy this. So we're going to go back to our code and just copy that and paste it. Alright, so the next thing that we're going to be using is the packet events library. So this is something that this is the last video that I just made before this one. This is a library that allows you to work with packets really easily. So listening to packets, sending packets, all that fun stuff. So this is a big part of what we're going to be doing in this video, making this plugin here, because what we have to do is listen to different packets and then also send a lot of different packets to simulate a replay of a recording, okay? So if you don't know what packets are, you probably need to stop this video and go watch my other videos on packets, and also watch my packet events video. It shows you in detail how to work with it. So I'm just going to go ahead and copy this now and then install it just as we did with the other ones. So there we go. And we're going to copy the dependency and put it right down here. And we just have to change platform to Spigot since that's the platform that we're using. Then we're going to go ahead and reload that. So you kind of have two options here. You can either shade it in directly into your plugin, so whenever you build it using Maven, it'll just include packet events so that server owners don't have to download this plugin here and install it, if they're using your plugin. But yeah, that's the more difficult approach. It's not too hard, but it's the more difficult approach. I'd rather I honestly prefer to just download Packet Events API directly and just throw this into your server plugins folder, okay? So make sure you do that. I'll have a link for this, of course. So just download this, throw it into your plugins folder, and then you'll be good to go. And just make sure that the version matches with whatever you just installed on Maven, okay? All right, so the last thing that we're going to be using is MongoDB for Java. So MongoDB is just a type of database, as we'll talk about more later, just how to set it up and everything. But this is the dependency that we're going to be installing here, so we're just going to copy that and throw it into our pom.xml. This is the latest version at the time of recording here. So this will enable us to use MongoDB within our Java application here, which is sweet. All right, so that's all the dependencies that we're going to need for this plugin here. Of course, there's still a little bit of setup that we have to do, so that's going to happen as we code this. The first thing that we want to do is change our Java version here to 17. We always want to do that. So we also want to install 2 plugins here for our Maven pom.xml that will make it so that, first of all, it's going to compile this plugin directly into our plugins folder, which is going to make it a lot easier for testing. So I'm just going to copy this from my previous project here. Boom. So now whenever I compile this plugin and click the run button here, it's going to output it automatically into this directory here, which is awesome. It makes it a lot easier. I've already shown how to do that a million times, and I have a video on that if you haven't seen it already, okay? The next plugin that we're going to be using is a little more tricky, okay? This is going to be the plugin that enables us to use NMS in our project. Now, the goal of this when I was making it was to not rely on NMS at all, and I've pretty much accomplished that goal except for one thing. I could not figure out how to spawn players using just packets. So everything else is using packets, but besides that, I could not spawn players, using packets. So hopefully one of you guys can figure it out for me. But yeah, you just want to paste this chunk of code here. This is a plugin that you can use. And I showed you guys how to do this also in the NMS video. Please check out the NMS video if you haven't seen it already. But this is a plugin that essentially takes NMS and remaps it so that you can use it on your servers, to put it simply. So yeah, so what we want to do is just, after pasting this here, is change the version to match whatever version you're developing on, okay? So at the time recording here, the latest version of Minecraft is like 1.20.6, I believe, but I'm lazy and I don't want to, change my server version, so I'm using 1.20.1. So just change this here to whatever version you're using, okay? It's really that simple. So here, 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 just wherever you see the version, okay? And it should work from there. So just make sure you click Maven Reload as well. All right, so what we could do is also refactor this so it looks better. There we go. All right, so that should be all we need to do for our pom.xml, just to install all the dependencies and get everything set up. Now we just want to do a few other things to make sure everything is set up. So the first thing that we want to do is go to our plugin.yml, and we want to tell it that we're depending on packet events. So packet, depend, packet, events. So this is just telling the plugin that essentially it's going to need packet events to work, which is true because we have this external plugin that we are going to be installing that will hook up to our library that we're using in the actual code. So that's just very important that you include that, okay? So let's go ahead and also set up our packet events in our main plugin class so that we can make sure it works. So this is all available on their website and also in my previous tutorials. So this part's really just going to be a lot of copying and pasting, okay? So what we're going to do first is override the onLoad method. So code override methods, and we're going to find onLoad. There we go. And inside of here, we want to call a bunch of methods. So packet events.set API, and we're just telling it that we're using Spigot because packet events works with different types of, whatever you call it. So we're going to disable bstats. We don't really care about that. Check for updates, sure. And then whatever this does, I don't know. But yeah, then we're going to go ahead and load the API. So this should be all you need to do to set up that part of the thing. And then after this, in the onEnable method, you want to do a few other things. So you just want to copy this part. And so this is just where you register your packet listeners that we're going to be setting up in the future. So actually, we'll just comment this line out. But we're going to need this line. This is the most important line for this method here, is just to initialize the library, okay? And then in the onDisable, as you can imagine, we're going to call something similar, which is packet events.getAPI.terminate. So this will just, of course, terminate it. So that's for packet events, but the next one that we should set up is for adventure library. This one's also, just a lot of copying and pasting. So I'm going to go ahead and copy this. So I'll go ahead and copy some of this up here. This is all available on their website in my tutorials as well. And then down here in the onEnable, we can go ahead and do this dot adventure is equal to bucket audiences dot create this. So this will create the adventure thingy that you could use. So this is how you essentially use adventure throughout your plugin. Okay, you just go ahead and grab this method here. And then in the onDisable, we can go if this dot adventure is not equal to null, then we can go ahead and do this dot adventure dot close, and then this dot adventure is equal to null. All right, so that's the basic setup that I want to start with. Now let's jump into actually coding some stuff. So since the whole idea of this plugin is to make a security camera so that you can record specific, zones or areas, we need to actually make it so that you can create cameras. So we're going to start by making a new commands package. And then we're going to also make a new services package. So the commands is obviously for commands, but services is going to be like a camera service that can manage all the cameras, get cameras, anything that you want to do with a camera will be through the service essentially. And then you'll have other layers like the database layer, which is how you interact with the database. And so I'm not too big on, design patterns. I need to learn a lot more about it, but we're going to try our best to separate our stuff into different layers so that we can give our project a lot more structure. And yeah, so anyway, we're going to make a new command here. We're going to call it the create camera command. So this will be our normal command executor from bucket. Return true. All right. So what we need to do here is, first of all, if sender instance of player, same as always. If they're not, then go ahead and say you are not a player. Go away. Okay. So if they are a player, then what we want to do is make sure they have permission. So if player dot has permission, security cam dot create camera. So if they don't have the permission to create a camera through security cam, then we're going to player.send message, you do not have permission to use this command. All right, and then return true. And ideally we want to do this in like red or something. So we could do like color translator, which is given by simp API, and we can do @c, paste that like that. There. Oop. Oh, we don't need the quotes. There we go. And we'll put the @c in the front. So also do the classic red color that you usually see with plugins. Okay. So we want each camera to have a name. So we're going to get the name of the camera. So let's make sure that they provide a name. So we'll do args.length. If it's equal to 0, this means that they did not provide a name. So we want to say player.sendMessage, please provide a name for the camera. Okay, and then return true so that it returns out of this and it doesn't go further. So otherwise, if they do provide a name, then we could do camera name is equal to args 0. Just grab the first argument, the first word. So camera name, and then here we could actually create the cam using the service. But we don't have a service yet, so that's the next part that we're going to do. So we're going to make a new Java class camera service inside of the services package. So again, the responsibility of the camera service is to manage all the cameras, facilitate access to cameras, from other parts of the plugin, like the camera command, stuff like that. So this is the part where you sit and you think about how you want to implement this, because there's a bunch of different ways, right? And we don't have MongoDB to set up yet, right? So we're going to be storing stuff in memory just to start with. And then in a little bit, we're going to, sort of transform this so that it stores it in database, right? So to store cameras, we can use a simple array list, for example, right? So we could do private final array list, or we could just say list camera. We can call that cameras is equal to new array list. Array list, there we go. And just make sure you import camera. Oh, we don't have a camera yet, obviously, so we need to make a camera. So what I'm going to do is just right click and do new package. We're going to make a data package. So the data package will just hold all of our data classes and stuff like that. So we're going to make a new class called camera. And so this camera class is going to store everything that you would expect a camera to store. So again, the plugin is called security camera. So ideally you set up a zone that is recorded, right? And an easy way to do that is just to have two corner blocks. So you have corner block 1 and corner block 2. And then everything that's in between those two corner blocks is part of the zone, right? Because if you have two corner blocks, that creates a cube, because you just have two corners of a cube, and then you could automatically get all the stuff that's in between that using, math and whatnot, right? If you want to be a little more precise, I guess, you could use, 4 corner blocks, but 2 is really fine. You could define a cube using 2 corner blocks just fine. So what we're going to do here is put whatever we think a camera should store. So we're going to start by putting private location camera or corner 1, and then private location corner 2. These are bucket locations, right? So import that from bucket. So that makes sense, right? We could form a region, which is a camera, out of these two corner blocks, right? And then we also want to associate that with an owner, so we know who created the camera and also who sort of owns it. So the best way to do that is usually through the UUID, so UUID owner. And the reason we're using a UUID, of course, is because the player could always go offline at some point. And so if you try grabbing a player object when they're offline or any situation like that, you could run into issues. So it's always just safe to store their identifier, which is a universal value for every single Minecraft account, okay? So every camera is going to have an owner, a corner one, and a corner two. What else would it need? We would also need a name, right? Because we're grabbing that when they run /create cam. So private string name. And then ideally, eventually, when we have a database, we want to also store the ID of the camera to uniquely identify it within the database, right? But we're not worried about that right now. So this should be everything that we need. So this is where we create, getters and setters and constructors and stuff like that. Now, since we're using something called Lombok, which we installed earlier in the video, we can make this really easy for ourselves and do @data. So what this will do is, this is from Lombok, it's just an annotation. This will automatically take this class and give it getters and setters for all of these methods that we have here automatically. So it's making it a plain old Java object. That's just what you call a Java class that has getters and setters, has private members and all that fun stuff. Just a very basic Java class, just using this one annotation here, okay? Now something that you could also do whenever you need it is you can add another annotation for no args constructor or even all args constructor, and these names are self-explanatory. It will make it so that your classes here have a constructor that has no arguments and also all arguments. And this is just useful for situations where you're using a database library, for example, MongoDB for Java, and it's automatically going to be creating instances of your camera class, right? So it needs a way to do that. And sometimes you don't have a no args constructor because maybe you create your own custom constructor, and this will just make sure that you have it. Of course, you can just create it yourself by doing, public camera and just, something like this. Just have nothing. That's just a no args constructor there. But just having this annotation makes it a little more concise, okay? So again, just to reiterate, usually you want to have a no args constructor when you're working with databases, just because that's how it uses, just because it's going to be instantiating your classes for you. And sometimes you'll also want a all args constructor, but for now we don't really need it, so I'll just go ahead and remove it. What we do want to do is actually create our own constructor here, public camera, and we're just going to pass in a string and name and a UUID owner. So the reason that we're doing this is because whenever we create a new camera for the first time using our create camera command here, the only information that we have at this point is just the name of the camera and also who created it. So I think it makes sense to have a constructor that only accepts those two pieces of data, because at this point we don't even have the corners yet. So then we could do this.name is equal to name, and then this.owner is equal to owner. Okay, so now we have this camera class that is able to be instantiated using this constructor here. And then it's also, made with getters and setters using this data thing from Lombok. So now we can go back to our camera service and import camera. So now this list here will be storing temporarily, at least until we set up the database, all of the cameras that we have for our plugin. Now what we're doing now is making the system for setting up new cameras. So we have to think about how we're going to track that. How do we know the difference between a camera that's currently being set up and a camera that's already set up? And how do we make the cameras that are already set up only available rather than just all of them? There's different ways you could do that. You could add like a bit to this camera class here saying like is being set up or something like that. But that wouldn't really make sense in my opinion to go on this camera class, here, because this is what's going to be stored into the database eventually, right? So storing whether it's being set up currently doesn't make sense, because if something's currently being set up, it's not going to be in the database. So I think what we should do is just have a separate collection here that will store only cameras that are being set up. And they won't be stored into this array list here until they're done being set up, okay? So essentially, whenever you create a new camera using the create camera command, it will be added to whatever collection we're about to create. And then whenever they finally finish setting up the camera, it will be finally removed from that collection and then added to this list here, okay? So that's just how I think through that sort of situation. So we're going to do private final. And for this, we're going to use a hash map. So the hash map key is going to be the player who is setting up a camera, and the camera is going to be the camera that's being set up by the player. So we could say camera is being created. And we can say it's a new hash map. There we go. And then from here, we can just make some methods that will help us work with these data structures that we just created. So we could say something like public camera get camera being created. So this will take in a player. And so this will return null if this player is not creating any cameras, and then if they are creating a camera, it will return that camera that they are creating. So we could say return camera being created get player. So it's simply using the player as the key to see if there's any cameras being set up for that player from the hash map. Another one that we can create here is public void start creating camera. So this is just going to initiate the camera creating process for a player, and then the name that they provide into the command. So the command will be calling this service method here. So first we want to double check, just to validate this, that they're not already currently creating a camera. So we could say if cameras being created contains key player. So if that's true, they're already creating a camera, right? So we'll say player.sendMessage, you are already creating a camera. There we go. And then we can also return so it does not continue, to be safe here. And then otherwise we can go ahead and do camera is equal to new camera. And then we can pass in the name, the name, and then the player. There we go. What's the problem? Oh, it's asking for the UID, so we'll do player.getUniqueID. There we go. Then now we could add to the cameras being created. So cameras being created dot put player and then name, or not name, camera, the camera that we just created, right? So now we're like starting the process of setting up a new camera. So this is going to involve giving them items so that they can choose different options like the corner blocks and then like finish and stuff like that, right? So what we can do is, first of all, let's just go ahead and clear their inventory. So player.getInventory.clear, and then we could do player.sendMessage, you are now creating a new camera named this, or we'll say name. You are now creating a new camera called name's name. Go ahead and place the corner blocks using the items in your hotbar. All right, so now we'll give them some items that they can use to do that. So we're going to say item stack, cancel. So this will be if they want to stop doing that. So, and here's where we can use the simp API item utils to make our job a little easier. So item utils from simp API, we can do .make item. And so we just provide the material. So the material for cancel is going to be a barrier block, barrier. And then we could say, we can give it a name. And so for this, we can give it color as well. It'll automatically translate it. We'll say cancel. Yeah, we'll just say cancel. There we go. So now we have all of the items that will be placed into their hotbar so that they can, finish the process of creating a camera and select the blocks. Let's go ahead and just add it to their inventory in the specific slots. So player.getInventory.setItem. So we can say specific slots. So slot number 1, cancel. And then we'll do slot 2. So the last slot will be slot number 8 or index number 8. So we'll say finish. There we go. All right, so now the items are added to their inventory. Now, ideally, what you would want to do is make it so that before you clear their inventory, you go ahead and save that inventory somewhere. We're not really going to focus on that, but that's something that you can definitely implement pretty easily. Then after they're done creating a camera, you can go ahead and give their items back. Okay. All right, so this will start the process of creating a camera, and then we're also obviously we're going to need a finish method. So public void finish creating camera. And for this, we're going to pass in a player. So we're going to go ahead and make sure that they are creating a camera before we continue. So if cameras being created does not contain player. So if there are no cameras being created by this player, we're going to go ahead and say player.sendMessage. You are not currently creating a camera. There we go. We can go to return. So after that, we're going to do camera. Camera is equal to cameras being created, get player. So get the camera that is being created by the player. Then we're going to go ahead and move it from the cameras being created collection into the actual active cameras collection. So we're going to go ahead and do cameras dot add camera, and then we want to remove it from the hash map. So we're going to go ahead and do cameras being created dot remove player. There we go. And we can go ahead and do stuff like clear their inventory again. So it'll remove those items that we just added above. And then we can send them a message saying, all right. Okay, we're going to add one more though. This is going to be for if you want to cancel the process. That's the first item that we added, remember. So we're going to go ahead and do public void cancel creating camera. and this is going to be player. And so first we're going to check the same thing as up here. So make sure they're actually creating a camera. And so if they are, we're going to do cameras being created, remove player, and then player.getInventory.clear, and then player.sendMessage. You have canceled the camera creation process. All right, cool. So this is a very basic service here so that we can go ahead and facilitate the camera creation process. So now what we want to do is make it so that they can actually use these items whenever they start creating a camera. So we're going to go ahead and make a new listeners package. Listeners. There we go. And we're going to call it new Java class camera creation listener. There we go. This is going to implement a bucket listener. Easy peasy lemon squeezy. So this is all going to be handled through interaction, right? So we're going to be handling whenever they right click these different items that we put into their hotbar. So we need to just make a listener for that. So event handler, event handler, public, void on right click. This is the player interact event. So whenever a player interacts by right clicking or left clicking, this will be activated. Yeah. So anyway, the first thing that we want to do is get the player involved in the event. So e.getPlayer. Okay, and then we're going to say, well, first of all, we'll check to see if they're creating a camera, right? So for this, we're going to need an instance of the camera service. There's different ways we can do this, but an easy way is just to make it available from the main, the main class here. So what I like to do sometimes is just do something like private, static, security cam, and then we can go ahead and make a getter for that. So we can go down here and do code, generate, getter, security cam. So now this will enable us to get an instance of the main plugin class from any point in our plugin. And then also we're going to need a private camera service. So then when we load our plugin, we can go ahead and create that. So services, and we can say this dot camera service is equal to new camera service. And then we'll just create a getter for that as well. So we can do code, generate, getter, camera service. And there's actually a way you can simplify this is by using Lombok. So you can get rid of that, and now you can see that it's just adding an annotation above these fields here so that if you put a getter annotation above a field, it's just going to make a getter for that automatically. So it makes it a little more concise and easier to read. So now that we've done this, we can go back to our camera listener here, and we can go ahead and do something like this. We can say private, final, camera service, and then we're going to make a constructor here. So public camera creation listener, just like that. And we could say this dot camera service is equal to security cam dot get camera service. So now we want to see if they're actually creating a camera before we do any of this interact handling here. So we could say camera being created is equal to camera service dot get camera being created passing the player. So this will just check the camera's being created hash map to see if the player is creating a camera. If there is one, that will return it. Otherwise, if it's null, they're not creating anything. So we'll say if camera being created is equal to null, then we're going to go ahead and just return because we don't really need to do anything after that. So now we want to handle all the situations like where they interact with an item, right? So we could do switch e.getItem.getType. And so now we can do case barrier. This is for the cancel option. So for barrier, we want to do camera service dot cancel creating camera player. It's as simple as that. So if we go back here, this is going to call this method, it'll cancel the whole process, right? But if you're a little lost in what we're doing here, we're simply creating a listener that will listen for whenever we interact with these different items that we added to their inventory, okay? So we did barrier, now we need blaze powder, red wool, and green wool, all right? So we could do case. This is a switch expression, by the way. It's a little bit different than a switch statement. The syntax is a little cleaner. Anyway, so we can do blaze powder. This is for when you finish the process. So first of all, we want to make sure that they set both corners. So we could say if camera being created dot get corner 1 is equal to null. We could say player dot send message, you must set corner 1 first. We got another if. We could say cameras being created dot get corner 2. If that's equal to null, we want to also tell them that you must set corner 2 first. And we just want to add returns in here so it does not continue from those points. So those two if statements here will make sure that they always have a corner set for both corner 1 and corner 2 before we do this thing here where we do camera service dot finish creating camera player. This is actually not needed, but this is just going to add an extra validation that the player is actually creating a camera. If they are, it's going to get it, add it to the official active cameras list, and then remove it from the creating cameras being created hash map, and then finish the process. Easy peasy lemon squeezy. Okay, that's pretty much all we need for now. And then now we can handle whenever they click on the red wool or the green wool. So we could do case red wool, and then we could add a comma here to handle both red wool and green wool. So now we could do if e.getAction, where is it? There we go, is equal to, we could do action. These are the different actions that are triggered. So we have left clicked air, we have left click block, right click air, and right click block. So we only really care about the right click, right? So whenever they right click the item as they're holding it, we want something to happen, okay? So for example, if we do this one here, right click block, if they right click the block with the red wool or the green wool, we're going to set the location of that corner equal to the block's location. So we could do location is equal to null, import location from bucket. So we could say location is equal to e.getClickedBlock.getLocation. There we go. So otherwise, if they did a different action like action right click air, this means that they did not directly look at a block whenever they did the interaction. So in this case, we can just set their set the location equal to the player's location. So location is equal to player.getLocation. There we go. So now that we have the location of the corner that we're trying to set, we can actually set it to the corner. So there's two different corners, right? So we just need to determine which one we're trying to set. So we can say if e.getItem.getType is equal to red wool, and we know that red wool is for which one? So red wool is for the corner 1. So if it's for red wool, then what we want to do is set corner 1. So camera being created dot set corner 1 location, and then otherwise camera being created set corner 2 location. Now technically I'm rechecking a condition that I'm already checked above. But I would have to do this part multiple times, and it's just, I think it's fine. Anyway, so now that we've set the location for the corners, we can also just verify that with a message so that they know it was actually saved. So player.send message, you have set corner 1, player.send message, you have set corner 2. There we go. All right, so that's all I'm going to do for now, just before we test it out to make sure it actually works. After that, we're going to make it so that it actually does something really cool, which is making it glow, as you saw in the demo. But yeah, we want to go back to now our main plugin class and actually register this listener here. So we'll go down here. We'll say listeners. So there we go. Now it's registered. And then if we go back to our create camera command, we never finished this part. So here we're going to need a instance of the camera service as well. So do private final camera service, add a constructor for that. We can take this and do securitycam.getSecurityCam.getCameraService. Then down here we can do camera service.getCamera being create, or no, camera service.create, start creating camera, player, camera name. Awesome. We could also validate in here to make sure they're not already creating a camera, but we are doing this in here as well. So I think I'll just leave it how it is like that. So looks good to me. So now we want to go ahead and register this as well. So we go back here and we'll do commands, get command. We'll call this one create cam, new, set executor, new, create camera command. There we go, easy. All right, so that should be all we need. Oh, plug into YML as well. So we'll do, all right, there we go. Looks good to me. All right, so that should be all we need. So now we just go ahead and run this, and it should automatically compile the plugin into our service plugins folder. Again, you just need to make sure that you already have the packet events Spigot jar in here if you did not shade it directly into your plugin. If you don't have that, it won't work, okay? So just make sure you have that. And as we can see here, it did compile it directly into our plugins folder, so that's working as well. So let's go ahead and boot up the server and test it out. Okay, so we got an exception here. This is just because I made a change. I changed the name of the main plugin class to SecurityCam to make it look nicer, but we have to also update it in our plugin.yml so it knows where to find the main plugin class. So we just have to change it here to match. There we go. Okay, so we got another exception here. I just like to leave these in the video just because you can see my process in an honest way of how I do things. I do make mistakes. So this is just saying that security camera is null. And this is because right here, when we created this security cam variable that represents the instance of our main plugin class, we never actually set it. So at the very top here of the unenable, we could do this dot security cam is equal to this. So this will set the instance for that. Yeah, there we go. Okay, yeah, that makes sense. So don't use this because it's a static field. Anyway, so if we rerun this now, it should, I think, work. No exceptions now. All right, I'm on the server now. So to test this out, we can go ahead and run our only command that we have, which is create cam. And it says, please provide a name for the camera. So we'll say test. It says you are now creating a new camera called test. Go ahead and place the corner blocks using the items in your hotbar. Awesome. So, oh, it did not translate the color codes like I thought it would. So that's easily fixable. But yeah, we can go ahead and cancel it. And yeah, it says you have canceled the camera creation process. So if we rerun this, it comes back. Awesome. So we can go ahead and set corner 1. And okay, it looks like it's set corner 1 according to the message here. But we need to cancel the event. We need to make sure we do that. And then if we set corner 2, it works as well. And then if we finish, boom, it says the camera name test has been created. Awesome. So let's make another camera. And if we do corner 1, but then try finishing, it says you must set corner 2 first. So if I set corner 2, boom, there we go. Awesome. So yeah, obviously it's not perfect. I need to fix a few things, but this is how you can very easily create a very basic like manager for when you create like an arena or a camera, anything like that. This is how you could do that, okay? So let's go back to our listener here. So we want to go ahead and cancel all of these. So right here we could do e.setCancel to true to make sure that the block is never placed because the interact event will never continue from there. And then also we want to prevent them from moving the items in their inventory if they are currently setting up a camera. So we'll add another event handler for that. So add event handler, public void on inventory move or inventory click. How about that? So inventory click event. So we can do event.getWhoClicked, instance of player. So if the person who clicked is a player, then we want to go ahead and do, we want to get the camera that they're creating potentially. So same code as here. So get the camera that they're creating if they are creating one, otherwise just return after that. And then after that, we want to go ahead and cancel all of the click events because canceling the click event, the inventory click event, will prevent them from also doing anything with their inventory like moving items and stuff like that, okay? So let's go ahead and rerun this and see if it works. And now if I do /create cam test 6 or whatever it's called, and I do corner 1, as you can see it's not actually placing the block anymore. So I can just set it however many times I want and it will change the corner 1 to whatever one I'm clicking on. Also, if I'm not putting it against a block and I just stand here and right click, it'll set it to my location. So there we go, you can see that there. Same thing for corner 2. So we could set it wherever we want. It's not going to place the block, which is nice. And then also if we open our inventory here, we cannot move any of the blocks, so, or the items rather. So that's working as well. So we've made it look a little better. And ideally we want to move these as well. These look terrible sitting here. So I think we'll put like this one here and then the green one right here. We'll do 3 and then 5. And then also we want to go back here and make sure that these colors are translated by doing color translator .translate color codes and just pass that in. So that's a simp API utility. There we go. So now those names will look way better. I want to show you something pretty cool, which is how to set up the glowing regions thing. So we're going to make a new package called utils. And we're going to create a utils class called region utils. All right. And then we're going to replace this with this code here and just make sure that we import all this stuff here. And then for region, you can import this from Simp API because I'm in the middle of actually adding this to Simp API so that you can use this with any of your plugins really easily without having to copy and paste everything. But yeah, this was made by someone named Milo who used to be on the channel a lot. He was in the streams a lot. He gave me this code that will essentially use scoreboards and slime tags and all kinds of crazy stuff to make it so that blocks can glow, or you can make regions glow. And it's just really cool, and you can set custom colors as well. So I'm not going to pretend I really understand how it works. I haven't really stared at it too much, but it does work, and that's all I know. So yeah, we're going to go ahead and utilize this to make it so that the regions that we select for our camera setup process actually glow, so that whenever you're setting up a camera region, you can see the region that you have selected. So let me show you guys how you can select a region and make it glow using region utils. So back here in our camera creation listener, we can do if camera being created dot get corner 1. If that is not equal to null, meaning that it's set, and corner 2 is also set, then what we can do is define a region based on those two corner points. So region is equal to new region. So we could do region.set corner 1 is equal to camera being created dot get corner 1, and then region.set corner 2, camera being created why is it so stupid? Camera being created dot get corner 2. There we go. So now to actually make it glow, you can do region utils dot draw selector, pass in the region, also pass in the world. So the world will be location dot get world. So this idea is how you uniquely identify different regions that you can make glow. So you just want to make sure that it's different from other ones. So in this case, we could just simply use the name of the camera. That's fine. So we'll do camera being created get name, and then finally you can provide a color. So we can do, let's go ahead and do green. There we go. And one other thing that you should do, since this is going to be called every single time you select the wool to set the corner blocks, you should also make sure that you delete any currently selected regions, because it's going to be using the same name so that it can redraw it. So you could just simply do region utils dot kill selectors with tag, and then just provide the name, the ID that you specified before, which is the name. There we go. So let's go ahead and test this out now. So if I did this correctly, it will make it so that every time we select a complete region, so corner 1 and corner 2, it will draw a region selection to make it glow. So let's try it out. All right, we're back on the server now, so let's do /create cam. We'll call it test again, and then now we have, as you can see, the colors are working, which makes it look way better. But we can go into corner 1, we'll set it to this block here, and then corner 2 will be this block here, and boom, look at that. So now we have a region that is glowing, which just tells you what the region that you selected is. So it looks really cool, but you can also even change it. So if we right click this block, now the region has been redrawn and you can see the new region. So we can keep doing that as much as we want, really. I just love that so much. It looks so good. So I'm going to try and get this added to Simp API soon, so you should be able to use it just out of the box without having to copy and paste. So now if we go and finish it, it says the camera name test has been created. Now obviously the region is still here, so that's something that we need to make sure that we do. We need to delete the region, the glowing region, when we finish creating the camera, okay? So let's go back here, and in the place where we kill it here, we can also kill it when they do the barrier, and also for the blaze powder. So yeah, there we go. So that will make sure that whenever you finish creating the camera, it will delete the glowing region as well. Something else that would be nice is that if we select one block, like let's say that we only selected corner 1, it would still be nice to make that glow so that we can see, we don't lose track of that block that we selected, right? And also it's a good confirmation. So what we can do is just make a 1 block region out of that, so that we'll make just that 1 block glow, okay? So all we have to do for that is just add some more conditions here. So we'll say else if, and we'll just go ahead and take this. So if corner 1 is not equal to null, but corner 2 is null, then what we'll do is just make corner 1 glow instead. So I'll just steal all of this here and paste it, and then now we'll just change this to 1, and we'll change the color to something like yellow. How about that? So yellow, and then we'll do the same thing for the corner 2. So maybe they select corner 2 before they select corner 1. So I think it makes sense to add that possibility as well. There we go. So now we'll change these to corner 2. So let's check it out, see how it looks. Okay, we're back on the server now. So if we select just this 1 block, boom, we get the 1 block region. Looks really cool, right? And then boom. And then if we cancel this and go ahead and redo it, boom, 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 boom. Awesome. Okay, now we've finished the system for creating new cameras for our plugin. So now we have regions that we can actually record. So now we move on to the harder stuff, which is actually figuring out how to record player actions and entity actions and all that fun stuff within a specific region or camera. So this is something that I'm going to show you guys. This is a dev blog by the Hypixel development team. This is actually them giving an overview of how they implemented their replay system. So it's actually very insightful, and I used this at the beginning when I started figuring out how I want to do certain things. So I recommend reading this whole thing yourself just to, learn how they did it. It's very informative. So it has some pretty good information about how to like start recording stuff. The main thing is that everything is a recordable. So a recordable is just something that happens that can be recorded and replayed. So they mention like arm swings, entity names, entity health, particles, everything's a recordable. So how do we actually get the data? So this is a big part of like what I used here is this explanation is dispatchers. So there's different types of dispatchers. There's event dispatchers for like bucket events. There's packet dispatchers for listening to packets, going both ways from the server and to the server. There's a tick dispatcher, checking for player locations. So yeah, this is very insightful because there's different ways that you can record player actions, right? You may think, oh, well, I'll just use packets for everything. Since everything in Minecraft is packets, I could just make a packet listener and I'll just listen to everything. But that's not always the best solution, First of all, Bucket already has a lot of this stuff built in. So it's just automatically better if you just use a Bucket listener for some of these things because, it's already built in. It's more it's just easier to use, all kinds of stuff like that. I really love this part here. So it says when adding support for a new feature, so entity names, block changes, something that you would actually want to record, right? The first question is, which dispatcher is best for this feature? Maybe we need more than one dispatcher working together to achieve an accurate recording. So for example, for entity location support, if we want to store player locations, we have the player move event. As you know, we just have a bucket listener for that. And it's not called for player standing still, which is nice, I guess, right? Because you don't want to record the same data over and over. But it says, but that can be called multiple times per tick, and that does not include non-player entities. So this wouldn't really work because we want to record the location of all entities, and also multiple times per tick doesn't sound very good. So it says the same thing if you listen to the packets. And if you really did test this, if you made a packet listener for the entity like location or teleport packet, you would see that it's just spamming it like insane amount. It's just an insane amount of data. And so you could listen to that and filter it out and try and deduplicate it and make it so that it works. But a more efficient approach, as it says here, is just to use a dispatcher called the tick dispatcher that would every single tick or every so often or every X ticks just get the player's location or the entity's location and store it. So that's a much more efficient approach. And so these are the types of things that you have to think about. There's many different ways to get data, but some ways are better than others. I really love this diagram here. Something else that's pretty interesting is some of this stuff down here for like entity locations. A location consists of coordinates X, Y, Z, pitch, and yaw. It should be clear that recording every entity's location every tick is a lot of data to store, right? Because the players are moving a lot, and every single tick is only 1/20th of a second because 20 ticks is a second. So that's a lot, right? That's a lot of data. So what they do, for example, is they cache the location of every entity. So if they don't change, we don't record it again. That makes sense. Just small things like this that they already sort of figured out for themselves is very insightful, okay? But anyways, with that said, I'll have a link for this in the description below, so make sure you go check it out and read it, okay? So we're going to start by creating a start recording command that opens up a menu that allows you to select the camera that you want to record. And then once you do that, you can go ahead and start recording the camera, and that whole process will be, a lot to figure out, but we're going to do it together. No homo. Okay, so let's create our command here. We're going to do new Java class start recording command. All right, and now just like before with the camera service, we're now going to need a recording service so that we can manage everything related to recording. So we're going to make a new Java class in the services package called recording service. So we're going to have a private final list of recordings. This is going to be recording from, we don't have a recording class. Okay, so we're going to go to data. We're going to create a new Java class recording. So every recording is going to have a camera, so a private camera. And this is because every recording is going to be recording a camera, right? So every single recording will be tied to a specific camera. And then we'll have also a private player owner. This is the person who started the recording. And in the database, this is going to be stored as a UUID and also an ID. But we're not going to do the database part for now. So just bear with me here. This is just going to be a player. We're doing things in a particular order so you can see the actual process in a way that makes sense. So every recording is also going to have a private long start time. That's how I like to record time, is just using long. That's just the epoch time. It's also going to have a stop time or an end time. We should also store the private long start tick. And this is very important because the unit of time in Minecraft is ticks. Like I said before, there's 20 ticks in 1 second. So everything's happening really fast, and the smallest way that you can keep track of time is using a tick. So when we start a recording, we want to start tracking what exact tick we started at, and that will allow us to sort of keep track of things, how, like, when things happen and stuff like that, as we'll see. So it's a little confusing if you've never worked with ticks before, but it'll make sense as we do it, of course. So now we need to focus on what's actually going to be stored in the recording, which is something called recordables. So these are all the different actions that a recording will record or can record, such as player movements, player interaction, sneaking, everything that you can imagine, like block break, block place, dropping items, all that stuff. That's a recordable. So we need a way to store recordables in a recording. So let's go ahead and define first what a recordable is at a high level. So we're going to make a new Java class called recordable. This is going to be actually an abstract class because we're going to have different types of recordables, and it's going to extend this parent class. So at a high level, every single recordable that we have will have one thing in common. That's going to be the tick. So private long tick, because we want to keep track of what tick this recordable was recorded in our recording. So we're going to go ahead and do @data, and then every recordable is going to have a method, public abstract void replay. This is going to take in a replay. We don't even have a replay yet, so I guess we'll just leave that empty. But every single recordable will use this, will implement this in their own way to be able to replay itself. So even though we're not doing anything with this currently, this will make a lot of sense in the future. But for now, we just need to know that every recordable is something that can be recorded, and it's also associated with a specific tick. So if we go back to our recording here, we want to figure out now how to store recordables, right? And the way that we're going to do this initially is by doing a map. So we're going to do private hash map, and the key of our hash map is going to be a long, like this. And then the value of the hash map is going to be a list of values. So list of recordables. Okay, and I'll explain this in a second. So now we want to do recordables map is equal to new hash map. Okay, so the way that this works is essentially we want to keep track of every single recording that happened in a specific tick. So when we're replaying this in the future, we want to say, okay, give us this recording. We're currently on tick 1 of the recording. Give us every single recordable that happened in tick 1. Now, if we just store this in just a regular list, number 1, they could be out of order unless we specifically order it. And then number 2, we need an easy way to group these recordables into a list of its own. We need to group them into other lists, sublists, right? Because if we were playing tick 1, we only want to get the recordables of tick 1. And one of the easiest ways to do that with like a sublist structure is to use a hash map, because the hash map has all of the recordables in it. We can associate every single recordable of a specific tick into that key, okay? So hopefully that makes sense. I know it's probably a little confusing until we put it into practice, but long story short, this will enable us to get a specific list of recordables for a specific tick. So what we want to do is make this data, because we want this to automatically have getters and setters for all of these fields here. And this is how we'll leave it just for now. We'll actually add more stuff to this very soon. But if we go back to our recording service, now we can import recording. So this is going to be our recordings, new array list. There we go. And then, so we're also going to have final list of recordings, active recordings. So these are recordings that are currently being recorded. I know this is a little confusing, but these are the recordings that have already been recorded. And then these are the recordings currently being recorded. And it's important to have these in two different lists just for organization, because in the future, these are all going to be stored into the database, right? It's just the same way we're doing with the camera service. We have these two lists and then a hash map. So same concept. This will be in the database in the future. So just separating it will be better for setting it up in the future, okay? Anyway, so now that we have this, we can go ahead and create a bunch of methods like we did with the camera service that will enable us to do stuff with recordings. So the one that we're going to need right away is the public recording get player active recording. So this will return a recording if a player is recording one right now. Otherwise it will return null. So we're going to do return active recordings dot stream, and we can do filter, and we can filter recordings by the owner. So recording dot get owner, and we can say equals player. So to only get recordings by that player. And then we're going to find the first one, find first, or else null. So this will say get the first result of this filter here for the stream. Otherwise, if there's nothing, then just return null. Okay, easy peasy lemon squeezy. So now we can go back to our start recording command here, and we can utilize that. So first we're going to need an instance of private final recording service, and then we could do the same exact thing we did with the camera service. So we need to go to our security cam main plugin class here. We need to go up here, and we could do a getter, private recording service, and then down here we can instantiate it. So this dot recording service is equal to new recording service, and then now here we could do security camera dot get security cam recording service. So now if it makes it past this point, we can go ahead and do recording, or we could say active recording is equal to recording service dot get player active recording, pass in player. So if active recording is not equal to null, this means they're already recording. So we want to tell them that you are already recording a camera. You cannot record two at once. Okay, so return true, so they cannot continue. And then at the very end here, now we want to open the menu so they can select a camera to record. All right, so now we have to do our menu stuff. So that's going to be using the Simp API menu manager. So for that, we're going to make a new package called menus, and then we're going to make a new Java class called record cameras menu. And so this part's going to sort of depend on your knowledge of the menu manager, but I have a lot of videos on this and it's pretty self-explanatory. This part is, I'm not going to really explain all of it. So extends paginated menu. So the point of this method here is to take some data and then convert it to a list of items. And the menu, the paginated menu, will enable you to cycle through all those items, just like you would on like a website, for example, a list on a website. So the list of items that we want to show is just a list of cameras that the player has access to. So we'll go back to our recording service here, and we're going to make a method called getCameras4Player. So public list of, actually this would be in the camera service. So we'll go to the camera service, and let's make sure we don't already have one for that already. We do not. So we'll go up here, we'll do public list of cameras, and we'll say get cameras for player, pass in player. And I want to do something like if player.has permission security cam.admin. If they're an admin on security cam, I kind of would just give them access to all of the cameras on the server. So that would be just return cameras like that. Otherwise, if they're not an admin, then we would just give them access to the cameras, like the specific cameras that they have. Return this or cameras.stream.filter, and we would just filter by the owner of the camera. So that would be if camera.get owner, which is a UUID. If it's equal to player.get UUID, then we know that's good, so we'll return true, otherwise return false. So we're filtering out all the non-owners of the cameras, and then once that is done, we can collect that into a list. There we go, to list. And now we can also simplify this. So boom, and then boom, and then we could make this a little more readable by making it multiple lines, like so. I mean, whatever, that's good enough. Okay, so now we can go back to our menu. So here we need to take all of the cameras. So we'll do return security cam dot get security cam dot get camera service dot get cameras for player, and then now we need a player. So this is going to be the player who opened the menu. So we could do that by doing player. And so now this will return a list of cameras or nothing. And so for each of the cameras, we want to go ahead and map that. We're going to map that into some items. So we'll say camera, we'll say item stack, item is equal to make item. So item utils dot make item material dot ender I. And then now this is going to ask for the display name of the camera. So we're just going to go ahead and use the name of the camera like that. And then now it's going to ask for the lore of the item. And I'm just going to go ahead and copy and paste what I have already, just because it looks pretty good. There we go. So this is just a var args list, so you can just give it a bunch of comma separated parameters and it will convert it to a list internally essentially. But yeah, what this will do is make it so that there's an empty line and then it will say on 2 different lines, left click to record and then right click to teleport. Okay, I struggled getting that out, but hopefully that makes sense. But now we have an item here, so we can go ahead and return it. So return item, and then we can go ahead and do toList like that. So we're taking all of the cameras that the player has access to, making an item out of them, and then providing it to the paginated menu so that it can be displayed to the player and paginated with and stuff. Okay. What we do need though is a way to uniquely identify each of the cameras. So right now, if you were to like in the menu click one of the camera items, there's no way to exactly get the camera that you clicked on besides like by the name, right? So we need some sort of unique identifier for each camera and also for each item so that we can tie an item that you click on, like get the item meta, get the persistent data container, get the ID of the camera from that container, and then tie it to a specific camera. So hopefully that makes sense, but let me go ahead and show you what I mean. So we're going to go back to camera, and then inside of here, what we're going to do is make a private UUID ID. In the future, this will be populated by the database, but for now, we can just go ahead and do new UUID like that, or I think it's UUID.random UUID. There we go. So every camera that is created will have that unique ID. So now we can go down here and do item meta. A meta is equal to item.get item meta. Oops, item.get item meta. And then we could do meta dot get persistent data container dot set new namespace key. Now we need an instance of the plugin, so security camera dot get security cam, and then now we need a key. So this will be just camera ID. And then after this, we need the data type. So the persistent data type in this case would be a UUID, which can be converted to a string. And then the value, so this would be camera.getID.toString. There we go. So what that is doing is getting the persistent data container of the item, and then setting a value inside of it, which is the camera ID. And then after that, we can do item.set item meta like that. So that will get all of the cameras that the player has access to and add the items for it. So here's where we handle what happens when you click the inventory. So I'm going to go ahead and rename this to event. And then we could do switch e, oops, not super though. Switch e.get current item, get current item dot get type. So if it's a barrier, then this means they want to close the inventory. So we'll do player dot close inventory. Then if it's a ender I, this is one of the cameras that they just clicked on. So what we want to do is access the persistent data container of the thing. So we'll do string camera ID is equal to e.getCurrentItem.get item meta dot get persistent data container dot get new namespace key. Ideally, what we should really be doing is saving this key somewhere. So let's try doing that just to make it a little better. So we'll do like private final namespace key, camera ID key, something like that. And then here we could set that so the camera ID key is equal to this. And then now we could use that camera ID key, and then we could use it here as well, camera ID key. And then we just specify the type that we're trying to grab using that key. So that should give us the camera ID now. And then with that ID, we can go ahead and grab the camera. So camera is equal to, and then here we would use the camera service to grab a camera by its ID. But we do not have a method in the camera service that could do that for us. So let's go back to our camera service. Let's go to the very top here, and we'll do public camera find camera by ID, or we'll just call it find by ID because it's implied that it's a camera. And so the ID is going to be a string, and then we'll do return cameras dot stream dot filter, say camera dot get ID equals ID, or this is actually supposed to be a string, or UUID dot from string, boom, and then first find first or else null. That's kind of a lot to type, but you get used to it. So this should give us the camera that matches the ID, otherwise null. Okay, easy peasy. So now we can come back here and we can go ahead and do camera is equal to security camera dot get security cam dot get camera service dot find by ID camera ID. There we go. And now we could say if camera is not equal to null. So let me change this real quick. So if it is null, then what we want to do is do player.sendMessage error unable to grab camera. So if it's a left click, if we just go back up here, we see that left clicks is how you record, and then right click is how you teleport. So if it's a left click, we want to go ahead and use the recording service to start a new recording. SecurityCam.getCam.getRecordingService.start recording, but we don't have a method for that yet. So let's go back to our recording service and create one. So public void start recording. So for this, we'll pass in a player, so the person that's actually doing the recording, and then the camera that they are recording currently. Right, there we go. So we're going to create a new recording, and then we don't have a constructor for this, so let's go back here, and let's go ahead and just create one. So we'll do code, generate, constructor. So the owner and the camera should be sufficient. There we go. So now if we go back, and then inside of here we could do this dot start time is equal to system dot current time milliseconds, and then this dot start tick should be, well, we haven't done that part yet, so we'll say like 1, and we'll add a to do here, fix. Okay. Anyway, so we'll go back now, and so here we can pass in the player and then the camera, and we're just going to send these messages here. So it's going to say you have started recording camera, and then the camera name. You can stop recording by typing /stop recording, which we don't have yet, of course. And then we can't forget we need to do active recordings dot add recording. There we go. Okay, so this is where it gets a little more complicated. So now we have to think about how we're actually going to do the recording, because right now we're just creating objects and it's not really doing anything. So the most basic thing that we could do just to start is to track player movements or entity movements in general, okay? And even there, it's like, how do you even start doing that? Now, remember the Hypixel dev blog said that the best way to do that is to just use a task, and then every tick or every so often just get the location of the entity. So that's what we're going to do. We're going to make an asynchronous task that tracks the location of all the entities that are in our region, okay? So let me actually write out what we're going to need. So we're going to need 2 tasks, with the first one being a way to identify entities that are in the camera region and keep track of them. And then number 2 would be a way to get all the entities that we are currently tracking and record their updated locations. Now, even though these are kind of similar, they're both like taking entities and tracking them and stuff like that. The reason we're going to separate these is because this one is a lot simpler than the other one. And this one is also a little more complicated because we have to scan like the world and scan the chunks to find entities and also determine if they're in like the region or not. So these 2 tasks here in a way will be working together using a list of entities that we are currently tracking. So what I want to do in the recording class is add a new list that will keep track of all the entities that we want to keep track of for this recording. So we're going to do private final list of recordable entities. This is a class that we're going to be creating in a moment. And this will be called recordable entities. And we just want to instantiate this whenever we create a new recording. So this dot recordable entities is equal to new array list. Array list. There we go. So let's go ahead and create this class now, recordable entity. So if we go to data, we'll do new Java class recordable entity. So this will be a POJO, or plain old Java object. So we'll have private UUID bucket entity ID. And then we'll have private entity type. So every time we come across a new entity in our recording, we create a new instance of this. We store the ID, we store the entity type, and that way we know how to create the entity whenever we need to spawn it, and also how to reference it using the bucket entity ID. So you'll see how we can use this in the future. So we're going to need a all args constructor for this. to be able to instantiate that. So now back in recording, we can make sure that recordable entity is imported. Okie dokie, so now that we have a way to store the entities that we're tracking, let's go ahead and make our task that will actually add stuff to that list. So we're going to make a new package called tasks, and we're going to create a new task within it called the camera entity tracker. And this is going to go ahead and implement runnable, there we go. And then we could do this. So we're just going to implement the run method. So all the code inside of here is the code that will be run every time that this is run. So if it's a repeating task, this will be run every single time. Like each repetition of this task here will run this method, okay? So this task here will be created for every single recording that we're doing. So every single recording will have its own camera entity tracker. That way each recording is independently keeping track of the entities that the recording is tracking. So for this, we want to store private final recording, and then we could make a constructor for that. So whenever you create an instance of this this class here, we can go ahead and pass in the recording, and that way we can grab information about the recording it's tied to. So the first thing that we want to do is figure out how to get all of the entities within the region of the camera, right? And in Bucket, there's no way to just get two locations and get every entity between. What we have to do instead is a little bit tricky. So a region can be, two corner blocks, and that could be made up of multiple chunks, and that region itself may be halfway inside of one chunk and halfway outside of another. So the way we have to do it is get the world that the region is inside of, get the chunks, and then figure out what chunks are overlapping our region, our camera region. And then once we have the chunks that are overlapping our camera region, we can then scan those chunks to get all of the entities. And then one by one, we need to double check to make sure those entities that are in those chunks are also within the camera region, because again, it could overlap. So one part of a chunk could be in the region, one part could be out. So even though an entity is in a chunk, that doesn't necessarily mean it's part of the camera region. So let me just start coding, and I'll try to explain it my best as we go along. So corner 1 is equal to recording.getCamera.getCorner1. Import that. So location corner 2 is equal to recording.getCamera.getCorner2. So now we want to do var loaded chunks is equal to corner1.getWorld.getLoadedChunks. The loaded chunks are going to be the chunks in the world that are already loaded, of course. And the reason we're getting the loaded one specifically is because the whole point of this plugin here is to track what happens in chunks, right? Like entity movements and stuff like that. And if a chunk is not even loaded, then there's nothing really to track, because like there's nothing going on, right? So whenever a chunk is loaded, that means something is going on. So it only makes sense to get the loaded chunks because that's where the stuff is happening. Hopefully that makes sense. So we're going to make a new list now called loaded chunks, or chunks in region. How about that? Chunks in region. All right, so let's loop through each of those loaded chunks. So do var chunk out of chunks, or loaded chunks. And then for each of the chunks that we have, we want to basically determine if the chunk is overlapping with our corners. So if it's in our region, right? So if we do chunk dot, we have these different methods here we can use, and you may see that you have get x and get z. But something you have to remember and not be fooled by is that these are the chunk coordinates, not the block coordinates. So just like we have a block coordinate system, so one unit of the coordinate system is just one block, we also have a chunk coordinate system where one unit is one chunk. So this x here is not a regular coordinate that we use just when playing in Minecraft. This is a chunk coordinate specifically. So what we're going to do is actually convert our corner blocks into the chunk coordinate system coordinates, okay? So we're going to do int chunk x1 is equal to corner1.getBlockX, and then this little shift operator here, and then 4. So this is called the right shift bitwise operator, and this has the effect of dividing this number here by 4. So it takes this number here and shifts the bits by 4 places, and that just has the same effect of divided by 16 essentially. It's a weird operation that you don't see very often, but that's what it does. Oh yeah, and by the way, the reason that we're dividing by 16 is because chunks are 16 by 16, so that's why we have to do that. So then we'll do chunk x2 is equal to corner2.getBlockX shift by 4, chunk z2 is equal to corner2.getBlockZ shift by 4. There we go. So now that we have those corner blocks converted into chunk coordinate blocks, what we can do is check to see if they're overlapping now. And I'll just copy and paste this part because it's pretty verbose or whatever you want to call it. So all this is doing now is just checking to see if these new coordinates that we have here converted to chunk coordinates is overlapping with or within our actual chunk coordinates, okay? So if it is, it will add that chunk to our chunks and region list that we have here. So at this point in the process, we should have a list of all the chunks that overlap with our region. So what we need to do now is get all the entities in the chunks and see if we are tracking them. Okay, so we're going to do for chunk, or we're going to do var chunk again out of, instead of loaded chunks, we're going to do chunks in region. And then for each of the chunks in the region, we can do var entities is equal to chunk.get entities. And then for each of the entities, now we just want to go through each of those entities out of entities. And we want to do something first. We want to check to see if the entity is in the region. So again, the reason that we're doing this is because even though the chunks and region list will be every chunk that is overlapping with our two corner blocks for our camera, parts of that chunk still may be outside of the camera region, okay? So we have to get the entity's precise location and check to see if it's in between these corner blocks or not, okay? So it's a little inefficient because we're doing a double for loop here, you know, but this is kind of just what we have to do. The other alternative that I'm aware of is that you would just have to get every single chunk and get every single entity in every chunk, and that would be less efficient for sure. So we just have to do it like this, okay? And so we're going to be checking to see if entities are part of our camera region kind of often, not too often, but we're going to be doing it in multiple places. So I think it's useful to go back to our camera class here and just add a method here that we can utilize for that purpose. So I'm actually just going to copy and paste it because it's another bunch of math. So it's just public boolean is in region, so you pass in a location and it just tells you if that location is inside of the corner region, okay? The two corner region. Anyway, so now we can go back to our camera entity tracker task and we could do if recording dot get camera dot is in region, and then we pass in the entity's location, so entity dot get location. So if the entity is in the region, this means that we need to track them because every entity that's in our region, we should be recording all of their actions, right? Including their location, everything. So this is the part where we add them to our recordable entities list that we made before. So this is the list here. So we need to make it so that if the entity is not currently in this list, we add it because we need to start tracking it. But if it's already in the list, then we'll just ignore it and not do anything, okay? And I'm going to start by implementing this with a sort of naive approach because there's going to be a problem that we come across and I want to show you how you can solve it, the process for how you think through that, because it's definitely a little tricky. So we're just going to come back to recording here and make two methods that we can utilize. We're going to do public boolean is entity being tracked. So this will return true if an entity is being tracked, and we're going to pass in the bucket entity ID because that's what we're storing inside of our recordable entity, if you remember. So this would be as simple as doing return recordable entities dot stream dot any match, and then recordable entity dot get bucket entity ID equals the one that we passed in. So if there's any values in this list that have the same ID as the one that we passed in here, it will return true. Okay, and that's actually all I want to add for now. So we'll come back to our task now, and we're going to go here and we're going to do if recording dot is entity being tracked. If that's not true, then we want to start tracking them. So we're going to pass in the bucket entity ID, so entity.get unique ID. So if they're not being tracked, then we want to go ahead and do recordable entity is equal to new recordable entity. And for this, we need to do entity.get unique ID and then entity.get type. The type is going to be useful later on when we start spawning entities. I think I told you that already. But yeah, so now we could do recording.get recordable entities.add recordable entity, just like that. And then we can go and output a debugging message because this is pretty useful when you're at this point. So added entity to tracking so that we know it's working. And then after this, later on, we're going to spawn the entity. So we can structure this a little better. So we can take this and then we can negate this. And then if that's the case, then we can just continue. So it goes to the next iteration. And then we could put that there just to make it a little more readable. So just as a recap here, what this is doing, this task here, it's this is a task that will exist for every single recording, right? It's going to have the 2 corner blocks of the camera. It's going to get all of the chunks that overlap with the camera region, and then it's going to get all the entities in those chunks, and it's going to verify that those entities are actually in the camera region as well. And then once it does that, we're going to start tracking those entities if they're not being tracked already, because then now we can make another task, the track location task, that will track the location of entities that we are tracking. And so now these are going to work together, right? So this is going to pick up entities that we need to track. This is going to run less often because this is kind of a hefty operation going through all of the chunks like this. And then this one is going to, every single tick, get the location of all the entities that we're tracking and then record them and save them and all that fun stuff, okay? So just like the other one, this is going to have a recording and a camera that we can reference. And then now we're going to start by using the other information that the other one is picking up. So we're going to get our recordable entities, and then for each of the recordable entities, so we're going to do recording.get recordable entities for each of them. So for each of these recordable entities that we have picked up by the camera entity tracker task, we want to first of all get their bucket entity to make sure that they actually exist on the server. If they don't, if for some reason let me just show you. So if we do entity is equal to bucket.get entity. So this is asking for the bucket ID that we're actually storing. So this is recordable entity.get bucket entity ID. That's what that's for. And if we import this, so if this is ever null, this means that, for some reason we're storing the wrong ID, which is kind of unlikely, or the entity was despawned at some point. Because if you can't get an entity by its ID, this means the entity does not exist anymore. Sorry, that was a struggle. But if we do entity is equal to null, then this means that the entity was despawned, right? So let's actually negate that, and then we'll add an else, and we'll say system.out.println, removing the despawned entity from tracking. So we'll just go here and make another method, public void remove entity from tracking. We'll pass in the UID of the one that we want to remove, so bucket entity ID, and then we'll return, we don't need to return anything, we'll do recordable entities, and then we'll do remove if, and we'll say recordable entity dot get bucket entity ID equals the one that we passed in, same as above. So this will simply remove it if it matches the ID. So now we can go back to our task here and say recording dot remove entity from tracking, recordable entity dot get bucket entity ID. And then after this, we would put another to do, so despawn the entity, which we'll do in the future. So here now, if the entity is not equal to null, this means that we're able to actually get the bucket entity. It does exist. What we need to do is again verify that it's in the region, because this task only has the purpose of tracking entities that go into the region, but it doesn't remove entities from the region at any point. That's the purpose of this one here. So either when they despawn or move out of the region, we want to, remove them from tracking, okay? So that's why we need to do if camera.isInRegion, and we'll do entity.getLocation, because we have to verify again that it's actually still in the region now that they're moving around and stuff like that. Log the location change. So that's when we actually start recording stuff, and then else. If it's else, obviously they're not in the region, so we want to remove them again, removing the entity from tracking. It's just for a different reason this time, and then we'll call this same method here, and then we'll add another to do for despawn the entity, okay? All right, so even though this is kind of a shell right now, which it's like missing a bunch of stuff, this has a lot of important stuff. It's already doing the important part, which is picking up entities and then passing it off to this task essentially to make sure the entities as they move around are still in the region. If they're not, it's going to remove them, okay? So we're kind of done with these. So now we'll go back to recording, and this is where we're going to actually store these tasks and start them and all that stuff, okay? So as we can see in this constructor here, we have it so that it starts recording immediately as soon as we instantiate the recording object. Because, we're doing start time is equal to system.currentTime milliseconds. That's just kind of how we designed it. So this means that we need to also start our tasks here as well. So we're going to do that by going up here first of all, and we're going to do private bucket task, and we're going to call this the track location task. Track location task, and then we'll do private bucket task scan entities task, like that. And then now down here we could start these tasks. So we'll just do the scan one first. Is going to be equal to bucket dot get scheduler, and then we can do run task timer. This is a repeating synchronous task. So this is going to ask for an instance of the plugin. So boom. Now it's going to ask for the runnable. So we're going to do new camera entity tracker task. This is going to ask for a recording, which is this. I am the recording. And then now it's asking for the delay, which is how long to wait before starting this, which is 0. Now the period here is how long to wait before repeating again. So this is, again, a little bit of a heftier task because it's scanning chunks and all that stuff. So we're going to set this one to just every second, which is 20 ticks, so 20L. All right, so then we'll do the track location task, and then we're going to do track location task, this, and then it's also asking for camera, which is not right. We don't need to pass that in. We could just do recording.getCamera like that. All right. And then now we need the delay, which is 0, and then the period, which is actually going to be 1. So we want the track location task to be as precise as possible. So the smallest unit of time in bucket in a Minecraft server is a tick. So whenever you record something and replay it back and it's not recording every single tick, it's going to look very choppy. So we want to repeat this track location task every single tick so that every single tick we get a snapshot of what location these entities are at, okay? So that's what that does. And you may be wondering now at this point, why am I doing run tasks timer rather than run tasks timer asynchronously? Why are we not making these bucket tasks here asynchronous so that we can have better performance? And this is because we are working with entities. And this is the downside to working with bucket, which is you cannot do entity stuff and other types of things off of the main server thread, which is asynchronous. So you have to do it using run task timer instead. And there's ways around it, like within a synchronous task, you can spawn synchronous tasks and like all that stuff. But with this one, we're pretty much exclusively doing stuff with world chunks and entities, which is pretty much everything. Like all of this has to be synchronous. So I could be wrong, but I'm pretty sure there's no way around making this synchronous. Yeah, it's kind of a bummer. Now for the track location task, you're still working with entities. I mean, right here, we're kind of cycling through the database, but right after that, for each iteration, we're getting entity, which is definitely something that has to be synchronous. And then, yeah, so I think we could make this a little more efficient in some ways, like maybe this part here where we get the entity is itself just synchronous, but even that might not work. So it would take some more experimentation, okay? But yeah, that's sort of the reasoning behind that at the moment, okay? So anyways, we're going to go ahead and compile this now and throw it on the server and see if it's actually picking up entities in our regions, okay? We want to make sure that these tasks are working before we can start recording stuff on the server. All right, we're back on the server now, so let me open the console here so we know if anything goes wrong. So what we're going to do is create a camera. So create cam test, and we're going to do like this here, and then this here. So this is our region. Boom, and now we can start recording it. So create, or start recording. Start recording. Look at that, that's freaking beautiful. Now we can select the camera, and okay, boom. So in our console, we immediately got added entity to tracking player. So that's how we know it's working. And then if we move around, it seems to still be working. That's great. Let's come out of the region now, and we immediately got an exception. So this is something that I expected and I wanted to show you. So we got a concurrent modification exception null. So it's saying that the array list, which is the recordable entities array list, is giving this concurrent modification exception. So this is just an exception that occurs when you try modifying a data structure concurrently, which means like at the same time. This deals with concurrency, which is like threads and stuff like that. And this could get very complicated. So this is where things get a little tricky. And this actually kind of stumped me, because if we go back to our code here, we are not using asynchronous tasks. These are, like I just explained 2 seconds ago, synchronous, meaning that they're run on the same server, main server thread. And I learned that even though we are running these tasks here on the main server thread, they can essentially be interleaved with one another. Now this is hard to explain, but technically they're not going to be run at the same time on your computer, on your CPU, but their execution, like the instructions within these tasks, can be interleaved with one another, meaning that if we go back to our camera entity tracker task, this one is interacting with the recordable entities list right here. So it's just calling this method, which in turn calls this. So it's just, doing that, right? And then it's also adding something here, right? So that's how it's interacting with it here. But also in our track location task, we're using it a lot more. We're iterating through the contents of that list. So the issue here could happen multiple ways. Basically, while this one is looping, this one could try adding a new recordable entity, and that could, create this concurrent modification exception. But we know that's not the case because what we did to trigger this was walk out of the region. So another option, which I don't know if that's exactly correct, is that while this one is executing, another another loop of this task is happening, because this is happening every single tick. That's really fast. That's 1/20th of a second. So while this one is running, the next one could have already started. So that creates another level of complications. It's just so tricky. So with all that said, even though we are not dealing with asynchronous tasks here, we still have to concern ourselves with tasks and how they work with collections and data structures and variables and all that stuff, because it can get pretty complicated. So the solution here would be to synchronize access to recordable entities so that only one, I guess you can call it a person, it's not really a person, only one part of your code can work with this at a time, okay? So you can lock it down so other parts have to wait before they can start working with it, okay? So I'm still learning all the time about stuff, right? And concurrency is definitely something that I need to learn more about. But I found a way to do this that works, and the first step here would be to, oh, it's up here. I was looking at the wrong thing. It's this one here. But yeah, what you would do is essentially convert this here from a list, which is not something that is quote-unquote thread safe, even though we're using the same thread technically, to something that is thread safe. So it's meant for concurrency. So we would convert this list here to a queue. It's a specific type of queue, and then we would go down here, and then we're going to make a new concurrent linked queue. So concurrent linked queue. So a concurrent linked queue is a unbounded thread safe queue based on linked nodes. This queue orders elements first in, first out. So it's a queue. If you don't know how a queue works, then it's pretty simple. You'll hopefully you know what that is. Blah, blah, blah. New elements are inserted at the tail. It's pretty basic. A concurrent linked queue is a appropriate choice when many threads will share access to a common collection. Like most other concurrent collection implementations, this class does not permit the use of null. We don't care about that, really. Iterators are weakly consistent, returning elements reflecting the state of the queue at some point at or since the creation of the iterator. They do not throw a concurrent modification exception and may proceed concurrently with other operations. So the high level of this is that this is a thread-safe collection that will make it better when you're doing stuff in a concurrent manner, okay? And some of the operations that you use on this queue here are atomic, meaning that only one thing or one thread can access it at a time. So you won't have any concurrent modification exceptions. So for example, if I go down here and I do this .recordable entities .poll, this will retrieve and remove you can't see this, but it retrieves and removes the head of the queue. So it just gives you the next value, or null if it's empty. This is atomic, so you can call this without worrying about if it conflicts with something else. You also have add, so any of the basic operations will be atomic. But we also still have to manually synchronize when we do stuff like this. So whenever we loop through this queue here, this is taking a snapshot of what the data is at this current point in time. So as we're looping through it, the data could change. So this creates a little bit of complication. So if this is the case where as we're looping through the data, it could change, we want to make it so that other threads and other parts of this application cannot modify it while we're doing this job here. So Java actually has a tool for that. It's a built-in mechanism for that. This is called synchronized. So synchronized, and then inside of here you would put what you're trying to synchronize. In this case, we're going to put our concurrent, our list here. So we're going to do var recordable entities is equal to recording.get recordable entities. And then now when we pass this in here, what this will do is synchronize everything inside of it, meaning that it's going to lock it down. So as this code is running, this cannot be touched by something else. So we're going to take this, cut it, and then replace it here, and then take this and just replace it here. So I don't know what the technical explanation of this would be, but I just like to think of this as making it so that only one thing, in this case it could be a thread or whatever, can touch this collection at a time. So when it comes to this point in time, whenever your application goes boom, 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 whenever it gets to here, it's saying, okay, we are now synchronizing access to recordable entities. Nothing else can touch this. If it wants to touch it, it will block, meaning that the other thread or other whatever wants to deal with this has to wait. So this has to finish before anything can access this, okay? So that is the best explanation I can give for this. It's very, very tricky stuff. I'm still new to it myself, but hopefully that made some sense for you guys. Yeah, so now this will synchronize access here, but we still have to do it here as well. So here we're also dealing with the same collection, the recordable entities collection. So we need to make sure that it cannot generate a concurrent modification exception. We need to also synchronize it here as well. So one way we could do this is by going into this isEntityBeingTracked method and just kind of wrap this with the synchronized thing I just showed you. So synchronized recordable entities, and then boom, like that. So whenever you call this method, it will always make sure that this will not be interrupted by something else, okay? But we also have add, so we need to make sure that this is also synchronized because we're touching the same collection. So we can have a few options here. We can make another method that is, using synchronized, or we could wrap this entire part here and make it synchronized. I kind of like the latter option, but instead of wrapping it, we're going to combine these two parts into one method. So we'll come back to recording here and we'll say public boolean add entity if not already being tracked. I know that name is absolutely crazy. Add entity if not already being tracked. UUID bucket entity ID. Okay. And then we're going to synchronize it. So recordable entities. Actually, we want to pass in the recordable entity. So recordable entity. I don't know why it's so hard to say that. And then now we could do if, and we could just borrow this up here. And boom. And then now we could do recordable entity dot get bucket entity ID. So boom, boom. Okay, there we go. And we can, looks like we can simplify this. So we're saying, okay, so this is saying that if there's no match for this, meaning that there's no recordable entity in the queue that has this ID, then this will return true. So we can go ahead and now add it. So we can do recordable entities dot add recordable entity. There we go. And then we can return true since this is true. Otherwise, we can return false. There we go. But now we can come back here and we can replace this whole part here. So we can say if recording dot add entity if not already being tracked, and we can pass in this. We'll just instantiate it right before recordable entity. So if this returns true, this means that it was added, right? So then we could go ahead and just output our message and then add our to-do. Boom. And then we could get rid of this. We don't need that anymore. Okay, so hopefully that makes sense. All we did here was make it so that any part of our code that touches the recordable entities list, or it's a queue now, is locked down in the sense that it's synchronized, meaning that no concurrent modifications can happen because that's naughty. So we don't want multiple parts of our application modifying the same data at once. Because again, let me just give you an example so you can visualize it. If one part of our application is trying to loop through a list, and then as that's going on, another part of the application tries modifying that list, then the first task has incorrect data. That doesn't make any sense. So then you get the concurrent modification exception. So this is why we had to make this change, even though it's really annoying. But we also have remove entity from tracking. This is being called here. Now, this is kind of a design choice, I guess. Since it's already inside of synchronized, we don't need to technically add it to here. And I don't know what happens if you do a synchronized within a synchronized, to be honest with you. So I'm going to kind of just leave it how it is, even though that's technically kind of weird. But yeah. Anyway, so let's go ahead and throw this on the server again to make sure that it's working and everything is synchronizing. And if it is working, we should now, instead of getting a concurrent modification exception, we should be getting removing the entity from tracking because it moves out of the zone. So, whew, that was a lot of talking, but let's try it out. Hopefully this works. All right, everybody, I'm back on the server. Let's go ahead and try this out. So we have to create our camera again because it's saved in memory, so it gets removed every time, right? So boom, boom, Boom. Now we're going to start recording. All right, so it says added entity to tracking, so that's working so far, and then we get out of it. There we go. It says removing the entity from tracking. So it was able to successfully modify that that collection now without any issues. So if we go back into the zone, it said it added me back. So it's working perfectly. That's freaking awesome. And that's what you want to see when you deal with something as complicated as this, especially when you have to do concurrency synchronization. That's just the scariest thing in the entire world. At this point, if you followed me to this point, I mean, thank you for even watching. This is a crazy long video. I love you. Yeah, so this is a pretty awesome point because now we can move on to the part where we actually start recording player actions. Not just player actions, but everything that happens in the zone. All right, so what we have now is the groundwork, the foundation for being able to record player movement, right? So that's why we have the track location task in part. Besides removing entities, we can also track their location. So that's the first thing that we're going to start recording, okay? So the way that we're going to do this is we need to think about how we're going to store this data, how we're going to structure this data. And this is something that you have to sit there and you have to think about for a little bit, okay? Luckily, the Hypixel dev blog did give you a little bit of like a hint for what to do. You want to make everything a recordable. And when you say something like, when you hear something like that, you should think, oh, this must mean I'm using an interface or an abstract class so that there's some, polymorphism where they all inherit from the same thing. That's exactly what we have to do. So we're going to go into data and we're going to make a new package called recordables. So we're going to have a bunch of recordables, which is every single action that happens within a recording, okay? So we have our tick. This is the tick of like when it happened. And then we have our replay. So this is how it's going to replay later on. So now we could go to recordables and make a new Java class. We're going to call it the location change recordable. So this is going to inherit from the parent recordable. So we're going to do extends recordable like that. And then now we can do implement methods. And now we have to implement replay, so we'll do that later. But here the important part is we need to figure out what data this is going to be storing, okay? Obviously this is a location change recordable, so what we need to do is store the new location that they moved to. That's pretty simple, right? So we'll do private location. Okay, there we go. And then what else? We need to also identify the entity that moved, right? So let's think about how we're going to do that. So remember that in a recording, we have our recordable entities, right? And then for each recordable entity, we have our bucket entity ID. This is a unique identifier for every entity on the server. So we could also use this to identify what did something. So we could do private UUID bucket entity ID like that. It's pretty self-explanatory because we have a location, so that's implying the new location, and then we have what moved, which is the bucket entity ID. That's the entity that moved to that location. So in the replay later on, we're going to make it so that using packets, we move this entity to that new location. And let's go ahead and add our Lombok annotation, so data, and then we also want this to be an all-args constructor because we're going to pass in all these arguments here. And then we'll also do a no-args constructor because this is, again, going to be later on used for a database. And then it's saying that we should add a call to super, which makes sense, so we'll do that. I'll just pretend I understand it, but I just know we need this, okay? Okay, so that's perfect, actually. So now we can go back to our track location task. And then here we can do var recordable is equal to new location change recordable. And then in the constructor, it's asking for the location. So it's entity.getLocation. And then it's also asking for the bucket entity ID. So entity.get unique ID. So now we need to add this to our recording, which is going to be stored in the recordables map, right? This is how we're doing this at the moment. So this is a map that stores the recordables in a list for every single tick. So we could directly access this map if we want to inside of our task here and then add it, just put it in there. But the way we're going to do is we're going to go to our service. We're going to make a new method here for the purpose of adding new recordables to a recording. So we're going to do public void add recordable. This is going to take in a recording, and then a recordable, recordable. There we go. So remember, we associate every recordable with a long, right? Which is the tick that this happened at, right? So how the heck do we figure out what tick something happened at? This is like the next point where I was like, what the heck do I do here? Now, just like everything, there's different ways you could do this, but one of the most simple ways that you could do this that I found out, and it's really cool, it's genius, it's simple but cool, is you just make another task that runs as your plugin is running, and it just counts up. It just counts up, and that way your plugin has a universal way of tracking a tick. So ideally what would happen here, right, is that your plugin starts, so the task starts counting up in ticks, right, every single tick, and then at some point you start a recording. So this is going to record start tick at tick number 24, for example, right? And then eventually you're going to stop the recording. So you're going to say record stop tick at number 78. So now with this basic mechanism that we have here, we have a really simple way of tracking when something started and when it finished. We also now have a way of storing when this recordable happened at. So if it happened at tick 24, we know it happened at the very beginning, for example. And we also know how to get the duration of our recording, which is just the difference in these two values, right? In ticks, at least. We also store the long epoch time. This is just so we can track time. So we're going to make a new task here, and we're going to call it the tick tracker. And I'm going to write this one a little differently. I'm just going to do private static long current tick is equal to 0. And then we'll make this a getter. So this will give you a public static method that you can access anywhere at any time that will give you the current tick number. Pretty cool. And so now we're going to make the task inside of here. So public static void start tracking. And then we're going to do public, or rather bucket.getScheduler schedule sync delayed task. And we're going to do a security cam.getSecurityCam. And then we're going to do a lambda for the runnable. So this is the code that will run inside of this task. And we're going to do a current tick ++. And then now we want to do our delay. So start immediately. And then the period will be 1L. So it's very simple, right? As soon as you start, it's just going to count up. Just count up until you stop it. So now we can access this value anywhere. So we need to call it somewhere. So we're going to do that in our on enable. So if we go back here, we can, we can just go down here and we'll just do it right here. We'll say start ticking. And we'll do tick tracker dot start tracking. Boom. So now that we have our tick tracker, let's go ahead and record as soon as we call add recordable the current tick. This is the tick at which we can say this recordable was recorded. So we could do tick tracker dot get current tick. And then now this will be the current tick, for example, tick number 45, right? Sorry, I can't talk right now. But this is not very useful to us, like if we store it that way. So if we store the start tick and the end tick as like 45 and 98, and then we store the tick of this recordable, sometime in between those times, we could figure out how to replay that. But I think it's more useful if we do something called normalization, which means to convert this tick number here to the tick number relative to when we started recording. So let me show you what I mean. So if we do normalize using start tick, right? So we could say current tick is equal to current tick minus the recording dot start tick. So what this means is that if you started recording at 45, and let's just say that this was recorded at 45, then the new value of current tick will be 0. This means that, and that kind of makes sense, right? If something happened at the very beginning, the index should be 0. And I think it makes more sense to start at 0, because then we could just, increment from there. So if we were to grab something from this from 0, this means that we should get a list of all the recordables that happened like right away, and then we can increment from there. So we could get the next tick, which is 1. That would give us everything that happened in the next tick, and so on. So that's why I'm doing that, okay? Hopefully that makes sense, but you could, store it as just the current tick if you want to, but I just think that makes it a lot more easier to understand and work with. So we're going to go ahead and do recordable.setTick to current tick. And this is from our recordable abstract class, right? So now that we have this, we can add it to our recordable map. And so this is how you do that. So you're going to get the map, and then you're going to see if it contains the key, which is the current tick. If this returns true, this means that there's something that already happened in that tick. So you just get that list and then add it to that list. And then otherwise, if the tick isn't already in the map, then we'll just go ahead and add it to the map. So we'll make a new list of recordables, we'll add it to that list, and then we're going to do put. So put the current tick, which is the key, and then the value, which is the recordables. So now we can go back to our track location task and do recording, or not recording, we want to do recording service. We don't even have it here, do we? Yeah, so we need to pass in the recording service, or we could just grab it like this. So security camera dot get security cam dot get recording service dot add recordable recording recordable. There we go. So that should add it and record it. Easy peasy lemon squeezy. What we could also do is start recording the despawn and the spawn recordables as well. So every time, remember these recordables are for every single action that happens in the region, right? So that includes when entities move, which is for this one, when entities are spawned, despawn, when blocks are broken, placed, all that stuff. So every time we want to record something new, we just add a new recordable for it. So we'll call this one the spawn entity recordable. And we'll do the same exact thing as before. We're going to go ahead and extends recordable, and then now we decide what data we should store in this recordable. So this is going to be something that we replay later, right? So what information would we need to simulate this actually happening in the future? So we're going to need to fake spawn an entity using packets or NMS. So we need to know what type of entity. So this would be private entity type, entity type. We would need to know where to spawn it, so the initial location perhaps, so private location, that's the spawn location. We also need to know who we are referencing, so just how we identify them between recordables, which we already know is the bucket entity ID. And then if it's a player that we're trying to spawn like an NPC for, we also maybe want to store their name, so private string player name, like that. There we go. And then now later on in the replay, fake spawn entity. Okay, so that's for spawn entity recordable. We also need to add our stuff that we had here, like that. Then we'll do the same thing for despawn. So despawn entity recordable, and then we're going to do extends recordable, like that. Implement that method. And then now what data do we need for this? So since we're only despawning something, all we need is to store what we're despawning. So the bucket entity ID. All right, so now that we have those, we can go back to the places where we want to add those. So this would be in our camera entity tracker task. This is where we add stuff to tracking. So since we're adding something to tracking, this means we also want to give them a entity that appears, because it's in the region, so we want to make it so that it appears. So this would be spawn entity. So spawn entity recordable. Spawn entity recordable is equal to new spawn entity recordable. We're going to pass in the entity type, so entity.get type, the location, so entity.get location, the bucket ID, so entity.get unique ID. Actually, I want to make a little bit of a change here. We're going to go back to the spawn entity recordable, and we're just going to add a constructor here so that it can just do all of that automatically, so we don't have to pass all that data in every single time. I think it's a little bit more clean if we do it in this way. So yeah, we're going to do code generate constructor, and we're not going to accept any of these types. We're just going to accept a entity. There we go. Come on, entity. This is going to be a bucket entity. No, not that. Come on. There we go. So this dot entity type is equal to entity.get entity type, entity.get location, and then we could do if this dot entity type is equal to entity type dot player. Oop, what's the problem here? We imported the wrong entity type. We want to import it from bucket. There we go. Just make sure it's from bucket. And if it's a player, then we're going to store their player name. So this is going to be entity dot get name. There we go. So now we can go back here. Instead of passing all this every single time, we just pass an entity. I kind of like that. I don't know why. So now we could do security camera dot get security cam dot get recording service dot add a recordable recording recordable spawn entity recordable. There we go. Awesome. And then we're going to go to our track location task, and now we want to handle the despawns as well. So despawn entity recordable, despawn entity recordable is equal to new despawn entity recordable. This one we just do entity.get unique ID. There we go. And then same thing for here. We want to take it, do it like that, except that we have to be careful here because entity is null, right? That's the whole reason we're doing this. So instead of doing that, actually, we can just do recordable entity dot get bucket entity ID like that. We'll just take this and replace it here so they're consistent. And then now we can do security cam dot get security cam dot get a recording service dot add a recordable recording despawn entity recordable. There we go. There we go. Now we should be tracking 3 different types of recordables when we start recording something: spawning of entities, despawning of entities, and then location changes. So with all that information, whenever we implement the replay stuff, we will be able to show an NPC spawn and then actually have him move around, only with those 3 things. So before we start implementing the replay system, so we can actually see stuff replaying, let's just start by verifying that this data can be recorded, that there's no exceptions that occur. Because yeah, we don't want to continue if this isn't even working so far. So yeah, let's go ahead and compile this and throw it on the server, and I'll be right back. Okie dokie, I'm back on the server now. So we're going to do create cam test. Let's define our region here. Boom. Save that. We're going to start recording it now. So start recording. Boom. So now we're added to tracking as it says in the console. And then I'm going to leave the zone now. Remove from tracking. Okay, looks good to me. Now, there's no way we can know it's working exactly. I mean, I could print stuff out, but I think it's safe to assume that it's probably working if there's no exceptions. So let's go ahead and start making it so that we can replay these recordings so that we can visually verify that it actually is working, okay? This is where things get even trickier. So let's go back to here. And okay, so we have a camera service, we have a recording service. Now we're going to need something called a replay service. And as you can probably assume, this is going to facilitate everything that has to do with the replay. So let's go ahead and define first what a replay is. So we're going to make a new Java class called replay. So this is going to be data. Boom. And so, okay, what is a replay going to consist of? So a replay is going to be, it's going to have a viewer. So who's like starting the replay so they can view what happened. So private player viewer, like that. And a replay is something that is replaying what? A recording. So we want to associate that with a specific recording. And then let's just make a constructor for that. So we'll do public replay, and we'll call it, and then we'll pass in a recording, and then a player viewer, like that. And then this dot recording is equal to recording, and then this dot viewer is equal to viewer. And then now we can initialize what happens whenever like the setup of the replay is going on. So let's go ahead and clear the player's inventory. Again, you would probably want to like save that in a real plugin. And then we're going to make a to-do here. So give them some items to control the playback of the recording. And then we could say viewer.sendMessage, the recording is being loaded. Use the controls in your hotbar to control the replay. We're just not going to add those items yet because we're not going to do anything with it at this point. We just want to have it replay successfully. That's the main goal here. And then yeah, that's pretty much it. There's some other stuff that we're going to add, but for now that's good. So now let's go ahead and work on this replay service here. So we're going to need to store replays, right? So private final, and we're going to actually do a set. I think that just makes sense here. So a set of replays, because every replay is unique. You could also use a list. It doesn't actually really matter. What the hell? I can't type. There we go. So the reason that we have this one in particular is because replays are not something that we're going to be storing in the database. This is purely in memory, because a replay, again, is just a recording being replayed back to someone. So it doesn't make sense to store that persistently. You would just get the recording, wrap it in a replay object, and then, play it to someone. That's like the high level gist of it. So let's go ahead and write some methods here that will help us out, just like always. So we're going to do public replay, get replay for player. So just like the other ones, this will get a replay for a player if they are currently replaying something. If not, it will be null. Replays dot stream, and then filter, and we're just going to go ahead and filter by replay dot get viewer, and if the viewer is equal to this one here, the one that's passed in, then we'll just find the first one. Otherwise, no. So pretty simple. We're just using a stream here to filter out only replays that have the same viewer that we passed in, and then we're just going to find the first one. Otherwise, it's null. Okay, so that's going to be very helpful. So now we can make some other methods like replay recording. So we could do public void replay recording. So this is going to be a recording. So this is the thing that you're actually replaying. And then who is actually going to be viewing the recording, which is a player. Okay, so first of all, let's verify that the player is not already playing a recording, because we don't want them to be doing two things at once. So we can do if get replay for player, pass in player. If this is the case, then we want to go ahead and player.send message. You are already watching a replay. And we also forgot to add this here, so not null, because this will return a player. So if it actually finds a replay, this means that the player is replaying something. So this will return true, and then it'll run this code here. So after this, now that we know that they are not replaying something, we can go ahead and make a new replay. So replay is equal to new replay. And for this, we can pass in the recording and the player, which is the viewer. Easy peasy, lemon squeezy. And then after that, we could do replays.add replay. So if we just go back to the constructor of replay, this is where we sort of set up the replay. And this is also where we can make a new task or start a new task that will facilitate the replay here. So what I'm thinking here is that every single replay that we have, it has an independent task that runs. And the whole purpose of this task will be to take a recording, get all of the recordables from that recording, and then play it for every single tick. So what I'm going to do is we're going to make a new task in the tasks package. It's going to be called the replay task, right? So replay task. We're going to be wanting to store the actual replay that it's replaying. So private final replay. I just cannot type right now. I have no idea why. So replay, and then we're going to go ahead and initialize that in the constructor. So it's going to be passed in. And then we also want to get a instance of the replay service, because we're going to be needing that. So private final replay service. And for this one, we could just initialize it inside of here. So replay service is equal to securitycam.getSecurityCam.get. And we don't have the method yet. So we'll go back to our main class here. We'll scroll up, and then we'll just add it. So at getter, private replay service. There we go. And then we can come down here to this part and do replay service is equal to new replay service. So now we have one single instance of all these services here that we can pass around. So now we'll come back to our replay task and do get replay service. There we go. So like I said a couple times already, the unit of time in Minecraft is going to be ticks. And so we're going to be replaying everything tick by tick. That's how it's going to work. So this task here is going to be run asynchronously, and it's going to repeat every single tick, because every single tick is just going to get all the recordables of that tick from the recording and then replay that to simulate it actually happening. So in this replay task, we need a way to keep track of the current tick, which is like where we are in the replay. So we're going to do private long current tick is equal to 0, because it's going to start at the beginning. What we need to do is basically get all of the recordables for the current tick. Okay, so one way to do that is just to do replay, and then from replay we can get the recording. So now we have this hash map here, and the key is a long, which is the current tick. So we could just simply do dot get, and then we just pass in the key, which is going to be the current tick. So current tick, and now this should give us a list of recordables. But it could also be null, meaning that for that key, for that specific tick, there were no recordables, which can sometimes happen. So we want to do something like var recordables. We'll call it tick recordables is equal to that. And then if tick recordables is equal to null, then we don't really want to do anything. We're just going to go ahead and skip all of this. So we'll do current tick plus plus and then return. And the reason I'm doing current tick plus plus is because every single iteration of this task here, it's going to run this method, this run method. So every single iteration represents the running of one tick, the replaying of one tick. So every time it finishes or returns, it needs to increment that tick to properly go through the process, okay? So otherwise, if tick recordables is not equal to null, this means that there is stuff that we need to replay. So we're just going to loop through that. So we're going to do for recordable out of tick recordables. And then now we need to figure out how to replay a recordable. which we have not done yet. So what we're going to do just for now is just print out which recordable that we're replaying for this tick. So .get class .get name. So this should give you, I think, the name of the recordable, which is the like despawn entity recordable, for example, stuff like that. So this will help us test it out just to make sure that's working. And then to improve this, what we can actually do is just take all of this here, wrap it in a try, and put that inside of it. And then we could catch any exceptions that might happen, because it will definitely happen at some point. So exception EX, and then we could, print out some stuff like tick. We're just going to print out the tick at which this exception happened. So it's going to be current tick. And then of course, remember that we need to always increment the current tick. So we could do this here, right? Current tick plus plus, but this would be an oversight, because if an exception does happen, we still want the replay to continue, right? We still want it to go to the next iteration of this, task here. So it would make more sense to just take this, cut it, and then go to the bottom here and add a finally clause to this, so that if an exception happens, or if it runs successfully, no matter what happens, it will always call this piece of code here, which is increment the current tick. One thing that we should probably add to this is a way for it to cancel itself when it reaches the end of the replay, because if it doesn't, current tick is going to be incremented forever, and it's going to start messing up some stuff, because we're going to run out of data, right? So we just need a way to figure out when to stop, okay? So we could go to the very top here, and we could say something like if current tick is greater than or equal to, and then we need a way to get essentially the duration of the recording. So like how many ticks did the recording take? So to do that, you're going to go back to recording, and we just need to add a method here that will use the information of the recordable to give you that amount. Long get tick duration. It's a long because it's going to be a tick amount. So get tick duration, and then we could do return end tick minus start tick. And of course, we don't have end tick. We just never added that. But now we have a use for it. So we're going to go back to the top here, and we're going to add a new field. So private long end tick. So as I'm doing this, I remember that we're never actually setting these values here. And the reason is because we never actually added a command that can stop recording. So we need to make sure that we do that before we can even think about replaying stuff. So let's go ahead and finish that logic now. So what we're going to do for that is add a method here. So public void stop recording, and this will just set any like final information about this recording. So we could do this dot end time, that's going to be equal to system dot current time milliseconds. This dot end tick is equal to tick tracker dot get current tick. And then we could also go ahead and just stop these tasks here. So we could do this dot scan entities task dot cancel, and then this dot track location task dot cancel. So, and then now we could go back to our recording service here, and then we don't have a stop recording method, so we'll just add one now. So we'll do public void stop recording. So this will be run by a player, so I think we can just pass in a player for this, and we'll just have it automatically figure out if they have a recording, and if they do, we'll just stop it. So we'll do recording is equal to get player active recording, pass in player. So if recording is not equal to null, or if it actually is equal to null, we'll just go ahead and return. So now we just want to remove it from the active recordings because we're done recording. So active recordings.remove recording, set all that final data and stop the task. So we'll do recording.stop recording, and that's pretty much it for now. We'll add some stuff to this in the future, but that's good enough for now. So now we could go to our commands package and make a new command. We'll call it the stop recording command. Alright, so I added the basics here. So check to see if they're a player, make sure they have permission, and then after that we could simply call the recording service, recording service dot stop recording, pass in the player, and then it will check to see if they're recording and then stop it if they do. And we'll just go back to this, and I just want to add some messages here. So we'll say player dot send message, you are not recording. And then otherwise down here, once they finish recording, we're going to do player dot send message, recording stopped and saved. You can replay it with /replay. Something also I overlooked is, because we're not storing stuff in the database yet, before we remove it from active recordings, we need to make sure that we put it into the recordings list. So let's go ahead and do that. So recordings.add recording. There we go. Cannot forget that. So now we'll go back to the main plugin class. We'll scroll down here and add this new command. So get command. So now we can go back to the replay task and use that other method that we just created before. So we could go ahead and do recording, or replay rather, dot get recording get tick duration. So if the current tick of this replay here is greater than or equal to the actual length of the recording in ticks, then this means that they definitely finished the replay. So what we want to do is do this.replay.getViewer.send message. So we just want to tell them that it's over. So replay has ended. And then we need to cancel it somehow. So what we're going to do is go ahead and add a method to our replay service. This is just going to be the other side of this, which is going to be stop replay. Stop replay. You're going to pass in the replay that you're trying to stop. And there's a lot that's going to happen in here. One of the most basic things that we need to do is stop the replay task. So cancel it somehow, but we also need to go ahead and after we do everything, replays.remove replay. So it's no longer going to be stored in memory and it's no longer going to be replaying anything. Yeah, we need a way to stop the replay task from the replay. So in the replay, this is where we're creating this task, right? Or we're not doing it yet, but this is where we're going to do it. So let's set that up and then we'll also figure out how to cancel it. So we'll just add a private bucket task, replay task. And then down here in the constructor, we can go ahead and do this dot replay task is equal to dot run task timer asynchronously. So it's asynchronous, meaning that it runs on a whole nother thread, so it doesn't, block anything else. And then we're going to pass in a plugin instance, so get security cam. And now we need an instance of the runnable, so that's going to be new replay task. For this, we're going to pass in the replay, which is itself. And then now we need the delay, which is 0, so start immediately, and then it's going to run every single tick, like I said before, because we need it to be very precise. So that's it. So now we're storing the replay task, meaning that we have a reference to it, so we can cancel it whenever we need to. So we can just add a method like public void end replay. So this will be called by the service to essentially cancel itself. So we'll do if replay task is not equal to null, then we'll just go ahead and cancel it. So this.replayTask.cancel. And that's really all we need for this one for now. So now we can go back to our replay service. And then here where we do stop replay, under this we could just do replay.endReplay. So this will stop the replay task as we wrote here. So now in the replay task, we can come back here. And whenever we determine that the replay task has reached the end of the replay, we can go ahead and call out to the replay service. And we could do stop replay and then pass in replay. And that should stop it. All right, so we're almost to the point where we can actually test this out. What we need now is a new command that will allow us to do replays. So what we're going to do is make a command /replay that will pop up a menu of all the cameras that you have recordings for. And then when you click a camera, it'll show all the recordings for that specific camera. And then you could choose what recording that you want to replay. Okay, so let's go ahead and add that now. So new Java class, and we'll call this the replay command. So we've got all the basics here, and we just want to open the replay menu. So now we need a menu, right? So we're going to go into menus package and just make a new package, and we're going to call it replay, and we'll make another one. We'll call it recording, and we're going to separate our menus into different packages just to organize it better, because what we're going to need to do is make another paginated menu that shows cameras, which is very similar to this one with only a little bit of difference. So we're just going to take this and move it into recording, because that's the recording cameras menu, and then we're going to make a new Java class within replay. We're going to call it the replay cameras menu. So this will just allow you to choose a camera that you want to view the recordings for. So what I did is I just copied over pretty much what we had for the other menu, because it's all pretty much the exact same except for this part here when we handled the right click, or sorry, the left click. So whenever they left click, we want to make it so that it opens up another menu that shows all of the recordings. And then we just take this out. We don't need this here. So we're going to go under replay and make another menu, new Java class Reocrdings menu. There we go. And this is going to extend paginated menu. Import all of that. Now we're going to need a few things in here, so I'm just going to go ahead and add them to the top. So this camera here is going to be the one that we just clicked on in the last menu. So we need a way to transfer the camera that we clicked on from this menu to this menu. And with my SIMP API menu manager, you can do that using the player menu utility. This recording service is security camera .get recording service. This.replay service is equal to security cam .get security cam replay service. And then this.camera is going to be equal to, and then we need to find out how to access it from here. So the player menu utility, so you have these methods here. You have get data, and then you have set data. So it's pretty easy to use. All you have to do is provide a enum, which is the identifier of what you're trying to get and set. That way you know what you're grabbing and setting from two different menus is the same thing. So we need to go to our menus package and create a new Java class, make it an enum, and we're just going to call it PMU data. There we go. And now we just want to put the enum that will represent whatever we're trying to transfer, which is just, in our case, a camera, or you can call it camera ID. So now we can go to this menu, and whenever they left click, we want to send that over with the opening of this new menu here. So we're going to do player menu utility, which is something that is just given to you by the paginated menu, dot set data, and then we can do PMU data dot camera ID, camera, and then after that we could do menu manager dot open, and then now we could do the recordings menu that we just created and then pass in the player that we're trying to open it for. So what this will do is access the player menu utility, which every single player has, set the camera ID to camera. Oh yeah, so this is a camera, not a camera ID. So let me actually change this back like that. There we go, because I forgot we can just pass over the entire object. So yeah, we're passing over the camera, and so we're setting it in the player menu utility, and then after that we're going to open the menu for the player. So in that menu we're going to go to here and do player menu utility dot get data, and then we're going to do PMU data dot camera, and then you can tell it what class you want it to give you. So this would be camera dot class. So now this will give you the data stored under this enum for the player, and then also automatically cast it to a camera for you. So now we can use this camera anywhere in this recordings menu. We've successfully passed it over from the previous menu, which is really cool. So let's do some basics here. So we're going to set the menu name. So this is going to say recordings from, and then the camera.getName, and then for the slots we can do 54 slots since it's a paginated menu. And then we could do true to cancel all the clicks so they cannot move any items. And now we want to set up the data that's going to be displayed in the menu, which should just be all of the recordings that the player has. So we're going to need a method here from one of our services that will give us all of the recordings for a specific camera. So for that, we're going to go to our recording service, and we don't already have a method for that, it looks like. So we're going to go down here, and we're going to do public list of recordings. And this is going to be called get recordings for camera. We're just going to pass in the camera that we want to get the recordings for. And so now we can do return this dot recordings dot filter, stream dot filter, and then recording dot get camera, and we'll just match it by its ID. So get camera dot ID is equal to camera dot get ID, the one that was passed in, and then after the filtering we want to just do to list. So what this should do is just get all of our recordings, filter it by cameras that match the one that we passed in, and then produce that as a list. So now we'll go back to our recordings menu, and we're going to go ahead and do this dot recording service dot get recordings for camera, pass in camera, and then we're going to map it. So stream dot map. So we're going to take each recording and convert it to an item, right? So we're going to do item stack is equal to make item material dot paper. That's just the item that we'll use to represent a single recording as an item. Import that. And then now for the name, we don't really have a way of naming recordings. We haven't really set that up. So I'm just going to set it to the ID. I know that's not very useful for the end user, but whatever. So recording.get ID. We don't even have that yet, I forgot. So that's going to be something that we add when we set up the database. I'm just going to give it a random ID just at this moment. I know that's a little silly, but that's what I'll do. So random uuid.toString, and we'll just add a to, so fix the name. We'll do that after we set up the database. So now we can add some more information to the lore of the item that we're creating. So we could say like the start date, the end date, how long it lasted, so like the duration, and then add like another message that says you can click to replay this recording. So yeah, so let me just copy what I have here, because this will make it easier rather than just typing it out one by one. So what we're going to do is have a start date, an end date. We need to figure out how to format these in a nice way, and then duration. Boom. So we're using a simple date formatter. So this is how you can specify the exact format of the date that you want to show. So just month, day, year, that's the American format. You can rearrange it if you want to, if you're a silly European. You could do hour, minute, seconds, and then this is for AM or PM, and then Z is going to be the time zone. So yeah, so what this will do is take the long that we used for representing the start time and the end time for a recording in terms of the epoch time, convert it to a Java date, and then it'll automatically format that Java date into a string that we could use inside of our lore here for our item. So now we need a way to also represent the duration. So I'll add another piece of code for that one. So this will output the duration as hours, minutes, and seconds. I think that's probably the most useful format. So it's just going to do some math to get all that information, and then it's going to format that into a string for you. Another thing that we need to do is, just like we do with the camera, is store in the persistent data container of this item the recording ID, so that when it's clicked, we can figure out instantly what recording this is referencing, okay? Oh, but I just realized we don't have a recording ID. We're doing this right here. So what we need, so let's go ahead and just solve this right now. Let's go back to our recording class, and we're just going to add an ID field. So private UUID ID. And then whenever we instantiate a new recording, we could just do this.id is equal to uuid.randomID. So let's just stop being silly and do that. So now we can just go here. Let's get rid of this. We can just go here and then now do recording.getID.toString. And then now we could do the same thing for this. So we could do item meta is equal to item.get item meta dot get persistent data container dot set new namespace key security cam dot get security cam, and then recording ID is the key for this. And then now we could do the data type of what we're storing. So this is going to be a string since it's a UUID, and then recording dot get ID dot toString. There we go. So with all that, let's fix the formatting here. There we go. So now we can do item dot set item meta, and then return item. All right, so all this code here, I think it's pretty self-explanatory for you guys. We're just taking all of our recordings for a specific camera and then mapping it into items that the player can choose in the menu, okay? So now let's just add two lists to the end of this. So all of the things that we mapped in the stream will be converted to a list that will be returned to this method here. And we're forgetting one thing, which is a return statement. So we just got to do return like that. All right, so now we can scroll down to the bottom part here in the handle menu method, and this is how we handle when stuff is clicked. So we'll just change this first event, and then we could do if event dot get current item dot get type is equal to material dot paper, because that's the material for the item that we just set above. And so if it's a paper, we want to get the recording ID. Recording ID is equal to event dot get current item dot get item meta dot get persistent data container dot get new namespace key, security cam dot get security cam, recording ID, and then the type persistent data type string. Whew, okay, and then now that we have the recording ID, let's try grabbing the recording by that ID. So we're going to definitely need a method for that. So let's go back to our recording service, and let's add another method called get by ID. So public recording get recording by ID, pass in string ID. I think we called the other one find, so we'll call this find recording by ID to make it consistent. So we'll do public recording find by ID. We're going to pass in the string ID. And then now we could do return this dot recordings dot stream dot filter recording. And then for each recording, we want to get the ID of the recording, and then make sure that it equals, well, we'll do toString dot equals, and then the passed in one like that. And then we could do any match, or find first, or else no. So this will go through all of the recordings that we have, and if it finds one that matches the ID, then it will return it, otherwise null. So in this recording menu, now we could do recording is equal to recording service dot find by ID, pass in the recording ID. We say if recording is equal to null, player dot send message, an error, and then now we could finally replay the recording for the player. So for that, we could use the replay service, and we could do replay recording. Now we want to pass in the recording that we want to replay, and then for who, which is just player. So let's also do player dot close inventory. Let's also add this to our other menu. So the record cameras menu, we forgot to add this earlier. So you notice that whenever I start recording, it doesn't close the menu automatically, which is really annoying. So we'll add that. All right, so that should be pretty much all the things that we need. I don't think we're missing anything. So we just created the replay cameras menu. So we'll pull up all the cameras that you have access to, and then you can click a specific camera to view all of the recordings for that camera. And then ideally, when you click one of those recordings, it should start replaying it. Let's verify that this command works. So we have the replay command, and yeah, we need to add it here. So we'll do menu manager dot open menu. We want to say replay cameras menu, and then now we want to add player as well. And then we just need to handle any possible exceptions. Awesome. So now let's go ahead and register the replay command. All right, so now I think it's time that we actually test this out. We've added a lot since our last test. So let's just go ahead and make sure this all works, that we're able to start a recording, stop a recording without any exceptions, and then that we can also pull up the recording in the replay menu. And then if we click it, it should start doing something. And let's just verify that there's no exceptions, okay? Even though we haven't made it so that the replay does anything. So in our replay task, it's just printing out some messages still. So let's just see what happens. Let's see how far we get, okay? So let's go ahead and run this, and I'll see you in a second. Alright, I'm on the server now, so let's go ahead and test it out. So we're going to have to start by creating a new camera again. So create cam test. Throw that up there. Do this down here. Finish the region. Now we can start recording. Alright, the recording has started. Let me verify the console. As you can see, no exceptions so far. Let's run around a little bit. Let's just get some data. Beautiful, beautiful data. Now we have left the region according to the console. Now we're back in the region. And then let's go ahead and stop the recording. Stopped. No exceptions yet. And then now we could do /replay. And boom, we get our camera menu. That's working so far. So we click this. And there we go. Look, we have our recording. So it's working as expected up to this point. So now let's click the recording. Okay. So now it's loading it, and it should be starting the replay. Nothing in the console yet. This is a little strange. Oh, there we go. So now we finally got some data coming through. Interesting. So now it's replaying everything sequentially, it looks like. Despawned. That's when I left the region, so that makes sense. And then it's over. Okay, so it looks like it actually is working, except that for some reason it's starting it late. So there's a really weird delay on there. So let me take a quick look at the code to see if I can figure out why. So this is really weird. It looks like not only is it storing the data really late, and it's not grabbing it till later on in the replay, but it's counting up by twos. So that's really interesting behavior so far. So I found the culprit for why it's starting so late. This is because whenever we create a recording, the start tick is hard-coded to 1, and I already had it to do to fix that. I just totally forgot about it. So what we need to do here is just change this to the current tick, which is just using ticktracker.getCurrentTick. So that will fix that issue. And so because we had it like that in the recording service, when we set the current tick, normalize it and all that stuff, it wasn't being normalized. It's just doing -1 every time. So it's not getting the actual value of whenever this recordable was recorded. So it was storing it in the recordables map in the wrong index. So that's why it started so late. As for why it's counting by twos, I'm not really sure. This looks good to me so far. We will figure it out. We'll see. Okay, now we're going to replay it again. So let me pull up the console here. I wish I could easily show both. So as soon as I click this, it should start replaying stuff, or like printing out the recordables of the replay. And yep, there we go. So it's immediately printing out the recordables, so we know it's working. And then right here, there's an empty spot because that's when I left the region. So yeah, this is actually really great news so far. It's working as we would expect it to. So now we have to do the harder part, which is actually taking these recordables and replaying them back to the user using packets and NMS. So let's start doing that. Now, the first thing that we're going to need is a way to replay the spawn entity recordable, because to be able to actually show entities doing something, we need to actually have entities in the first place. So that's the first one that we need to do. So we need to go to data, go to recordables, and go to spawn entity recordable. And we need to add some code inside of this replay method so that it actually spawns the entities, right? So, like I said before, I did the entire plugin using packets except for spawning players, because I could not figure out for the life of me how to respawn players or to spawn fake players using just packets. It just wouldn't work no matter what I tried for some reason. So what I'm going to do is, first of all, we are already storing the entity type. So what I'll do is just do if entity type is equal to entity type dot player. Then we're going to do it using NMS. Otherwise, we're going to do it using packets. So I already have some videos on how to spawn NPCs using NMS. If you want to watch those videos, they're pretty good. So in the beginning of the video, we set up the dependencies in our prom.xml for everything that we would need for this project, and we also added this plugin here that would do the mapping for us for NMS. One thing that we also need to do that I forgot to show you is you need to go to the Spigot dependency and just remove the API part. And then we also want to add another tag here, which is classifier, and then we want to do remapped Mojang. So this will use the remapped Mojang, NMS stuff provided by Spigot. Yeah, that was a bad explanation, but I do have videos that actually explain this step by step. So the idea is that we will spawn a NPC using NMS and packets, right? So we need a way to get the person who is viewing this replay so that we can only show it for them, right? So what we should do probably is just pass in the replay itself. So replay. And so from that replay, we can get the person who's viewing the replay. So we could do player, the player is equal to replay dot get viewer. And then from that, we can get the craft player thing from craft bucket. And then we're just going to cast player into a craft player like this. So this is going from bucket to craft bucket. And then we want to go to NMS now. So this is going to be a server player. Server player is equal to craft bucket, or craft player rather, dot get handle. And then just import server player from NMS. So this will be the person that we send the package to show them the NPC just for them. So now let's go and create that NPC. So we're going to make a new server player. We'll call it NPC is equal to new server player. And then now we're going to need a few things. We're going to need a Minecraft server, a server level, and a game profile. So we can get the first two just from the person who's viewing it. So we'll do Minecraft server. Server is equal to server player dot get server. And then we could do server level. Level is equal to server player dot get level, or rather server level dot get level. There we go. So now we can pass these in. So server and then level. And then now we're going to need a game profile, which is just the profile that we're going to make up for this NPC. So we can actually just instantiate this ourselves. So game profile is equal to new game profile from NMS. So we're going to make up a UUID, so UUID.randomID, UUID, and then we can give the NPC a string name. And for this, we could just go back up here, and we can see that we're already storing the player name if it's a player entity that we're spawning. So we just pass that right in right there, like that. And then now we just pass in our game profile. So what this should do is create a new server player. Let's also set their initial position. So we'll do npc.setPOS, and now it's going to ask for an XYZ, so we could do location.getX, location.getY, and then location.getZ, which is all stored above when we create the recordable. And then now after that, we want to use NMS, the NMS packet sending utility to send the player info update packet in the client bound add player packet. So this is how you just spawn a NPC as I showed in previous videos. So we're going to do server game packet listener implementation PS is equal to server player dot connection. So make sure you import that type. And then with this, you can now do PS to send a packet to that person. So PS.send, and we want to send the first packet, which is the new client bound player info update packet. And just make sure that you're using this server player, the server player that we got from the person who's viewing the replay, not from this NPC that we just created, because we're trying to send packets to that viewer, right? And so we're going to be sending a client bound player info update packet to their client so that they can get information about this NPC that we're creating. So for this, we want to pass in action, so we can do action.addPlayer, and then we also want to pass in the NPC, so NPC like that. And then the other packet that we need is the add player packet. So ps.send new client bound add player packet. And then for this, we can just pass in, and we'll just pass an NPC for that. Okay, so if we did that correctly, it should now spawn a fake NPC only for the viewer of the replay in that location. So, oh yeah, so we also updated the replay method here. So we need to do that for all the recordables that we have as well, which is a little tedious, but that's fine. So we're going to pass in replay, and then now everywhere we have this method, we want to update it. So let's go to here and just add that, and then we'll go to here and we'll just add that. There we go. That fixes that issue. And then now in our replay task, we'll go back to here And instead of just printing out the thing that we're replaying, like the type, we're going to actually replay it. So we're going to do recordable dot replay and then pass in the replay like that. So now every time it comes across a recordable, it's going to print out the type just so we can verify it for debugging purposes, but it's also going to call the recordables replay method, which in the case of the spawn entity recordable, we are spawning a fake NPC for players. Okay, so we're just, recording ourselves running around, and then now let's go ahead and replay it. So slash replay, boom, boom, and look at that. We have our NPC. So it instantly spawned as soon as we started the replay because that's the first thing that happens. As soon as we start the recording, we start tracking that entity, and that also correspondingly adds the spawn entity recordable to our recording. Alright, so now let's go ahead and do the same thing for our non-player entities. We just need to figure out how to, spawn them so that they appear for players. So for this, we're going to reference the packet documentation, the packet wiki here. So we just want to find where we have information about spawning entities. So this would certainly be a client-bound packet because we're sending this to a specific person. So it's the second one here, spawn entity. So sent by the server when an entity is created. So that's pretty self-explanatory. So we have information about the entity. So the entity ID. This is a unique integer ID mostly used in the protocol to identify the entity. And then we also have the entity UUID, which is a unique identifier that is mostly used in persistence in places where the uniqueness matters more. So I was confused by the difference between these two values here, but after learning about it, this one can be pretty much just whatever you want to make it. This one doesn't matter as much, but for the entity ID, this is like a universal identifier for a entity on your Minecraft server. And for NMS, like the actual Minecraft server, anytime it spawns a new entity, it's going to generate a new entity ID from like the internal code and then use that, for referencing that entity in the future. And remember, this value has to be unique. So we can't just make up a number and just pass it into this packet when we send a spawn entity packet because we need to know for sure that's unique. So there's different ways you could sort of handle this whenever you send the spawn entity packet. One thing is you can do the approach that I did, which may be considered a little weird because there might be an easier way to do it that I'm not aware of, is I use reflection to access the NMS class that stores the thing that gives you new entity IDs. So we just access that using reflection, and then that way we have a guaranteed way of getting a entity ID that is 100% going to be unique. And it's directly from NMS. So that's the direct Minecraft code. So I just kind of wanted to explain that part because that might be a little confusing. It confused me at first, but essentially the gist of it is that whenever we want to do anything with an entity, especially with packets, we need to reference it with a unique integer ID, which is the entity ID, which is very different from the bucket entity ID. Bucket has its own bucket entity ID, which is the UUID that we've been using in our recordables, but that is completely different. Don't get them confused, okay? So, yeah, that may be a lot, may have been a little confusing, but yeah, besides the ID, we also want to pass in the type, which makes sense. We want to tell it what entity we're spawning, the location of where we're spawning it, pitch and yaw, and then we also can have the velocity, which we don't really care too much about. So yeah, let's go ahead and try this out. So the way that we're going to spawn this packet here is not going to be using NMS. We're going to be using the packet events library that we installed in the beginning of the video because it's an awesome library. It allows you to work with packets very, very easily, and it works for a bunch of different platforms. So yeah, we're just going to rely on that. So let's go ahead and start by first of all figuring out how to send the packet. So if you haven't seen the video on using packet events, I recommend watching that so you can know how what I'm doing, but it's not too hard, it's pretty self-explanatory. So what we're going to do is we want to send that spawn entity packet, right? So we're going to make a new wrapper object. So we're going to do wrapper play. It's a play packet. Its origin is the server, and then it's a spawn entity packet. And then we can call this the spawn entity packet. We're going to do new wrapper play server spawn entity. So yeah, we're going to focus on these last two here. What we're going to need is a entity ID. So like I said, this has to be a unique integer. And so I'm going to use reflection now to access that from NMS. I've identified what class stores that. You just kind of have to explore a little bit. So if you pull up entity from NMS, and you sort of look at how NMS handles spawning new entities, you'll quickly find out that it's just using this entity counter. So this is a private static final atomic integer type field. So this entity counter is an internal way that NMS obtains new entity IDs. It just grabs it from this incrementing counter here. So we just take a look at where it's used. Anytime we instantiate a new entity, it's just going to do the counter and just increment. So I think that makes a lot of sense. So because though it's part of NMS and it's private, we need to use reflection to access it. Otherwise, we would just grab it ourselves if it was public. But there might be a more proper approach to do this. But yeah, anyway, so we're gonna do class. We'll just set that type as a question mark, and then we'll just say entity class is equal to class.forName. And for this, you want to pass in the fully qualified name for the entity, the NMS entity class. So here's the package. So we could copy that right here, like that. And then now we can give it, and then now we specify the class name, which is entity. So with luck, it should give us a class reference here. So now we could do field is equal to entity class dot get declared field. And then you pass in the field that you're trying to access. And the issue here though is that even though if we look inside of here, the field is clearly named entity counter, this is because again we're using the mappings. We're using like the actual mappings that make it nice for us. It makes it easy for us. But we need to make sure that we grab the actual field of what it would be in NMS. So this gets a little complicated, and I hope I'm not confusing you too much, but there's this nice little tool here we can use to help us. It's called the NMS mapping thing. It's made by a guy named Screaming Sandals, really cool name. But this tool allows us to see all the different like mapping names for specific classes and stuff like that. So we just want to find the one that we're utilizing here, which is going to be entity. So net.minecraft.world.entity. And then now let's just find the entity class that we're using right there. And so here we have all the fields of the entity class. So we just want to find the one that we're trying to get, which is the one that returns a atomic integer. And as you can see here for Mojang mappings, we have it called entity counter, which lines up with what we saw right here. So entity counter. But you have to remember that since we're using reflection, this is going to be doing it at runtime. So it's not going to be using the nicely named fields. It's going to be using the obfuscated fields that don't make a lot of sense. So this is what we're looking for, the obfuscated one, and it's just D. So all we have to do is just go back here to this part, and we're looking for the declared field named D, just like that. And so since it's private, we want to make it accessible by doing field.setAccessible to true. And then now we could grab it. So atomic integer entity counter is equal to field.get, pass in null. And then what we can do, this is just going to return a object. So we want to cast that to the type that we're trying to obtain. We know it's an atomic integer, so we'll just cast it like this. So now we have our atomic integer, so we can do int entity ID is equal to entity counter dot increment and get, just like that. So that's the same exact way that it's being used inside NMS. So we're going to be using it on our end as well to obtain a unique entity ID that we can pass into our packet. There we go. And for this, it's just warning us because these can throw exceptions, right? If you're, trying to do reflection, you don't give it the right name or something can go wrong. So we're just going to add to the top here, throws exception. And it's complaining because in the actual parent recordable, we need to add it here as well. So I'll have a link for that NMS mappings website. It's pretty useful. So you can access it if you want to as well. So now we need to finish our packet here. So now it's asking for some more information like the UUID. It says that it's optional and nullable, but I'm just going to give it a value. So we'll say UUID.random UUID. And then now it's asking for the entity type, which is not from bucket. This is going to be from packet events. And so packet events likes to do it like this. So entity types dot, and then you have all these different types here. So we just need to figure out how to convert our bucket entity type that we've already stored here into the packet events entity type enum. So we're going to do entity type, make sure it's from packet events. So there we go, entity type. And then I could do entity types dot, and there's three different methods you could use here. You could do get by ID, and you can pass in the version and the ID, but I don't really know how to obtain an ID. If someone knows how to do that, please let me know. I'm not really sure. I couldn't find out how. But you also have get by legacy ID, and then you also have get by name. So let's do get by name. And so the way that this works is there's like an internal map inside of this class here that stores like all the different types in a map, and then it has all these names here. So I think this is pretty much it right here. You can see that it's just adding all of these types by a name. And yeah, so we can just get these names by getting our bucket one and just doing entity type dot get key. So not get name, that's deprecated. You could do get key, which is weird, but I tested it out. And then after you do get key, you can do toString. So this is something that I had to like really test out to figure out how to even do this, because I just could not figure out how to get the ID of an entity type. So I had to play around with like how can you get the actual name of the bucket entity and use that to obtain a packet events entity type. Man, it was annoying. But anyway, so I figured it out. So now we can pass in the entity type like this. And then now we can pass in the initial location of the entity, like where we want to spawn it. And again, this is also going to be a packet events location, but they have a nice and easy way of converting that location. So for that, we can use Spigot conversion util, and then you could do to bucket location, or actually this would be from bucket location. So this takes in a bucket location and then returns a packet events location, right? And then now it's going to want a head, yaw, and data. We don't really care about any of those. And then for velocity, it says it's nullable, so we're going to set it to null. We don't really care about any of this. Okay, so I know that was a lot probably, but we now have this packet wrapper here that we can send to a specific person, which is going to be the viewer of the replay. So if we did everything correctly, it should spawn a entity for that person. But we actually need to send the packet as well. So how can we do that? So to send a packet with packet events, you can use user. So user from packet events, user is equal to, and then you could do packet events dot get API dot get player manager, and then you could do get user. So here you just pass in the player, so this would be replay dot get viewer, and then that will give you the user that you can use now. So user dot send packet, and then you just pass in the packet that you want to send them, just like that. Now, since all of our recordables are going to be sending packets just like this, what I want to do is just modify this method again to pass in also a user. So user, and then now we could just take this, go to our replay task, and then up here at the top, we can just go and create a user. So we can do private user, make sure you import user from packet events and from not from somewhere else. And then you say this dot user is equal to packet events dot get API dot get player manager dot get user, and then you could do replay dot get viewer. There we go. All right, and then now whenever you replay, you can pass in a user. And we just need to modify this to accept a user. So user. Okay, make sure you import it. Okay, so I know that's a lot, but now with what I added in the spawn entity recordable, we can now hopefully spawn anything that's not a player as well. So this is going to be any type of entity like a skeleton, a cow, literally anything else besides a player. So first we're using reflection on NMS to obtain a unique entity ID, because that's what we need whenever we're working with entity packets. And then what we do is we create a new packet wrapper that will be the actual packet that we send to a specific player. So we're using this nice class here to do that. So we just pass in the entity ID. The UUID doesn't really matter. The entity type, which we converted from bucket to packet events. And then we also converted the location from bucket to packet events. And then for the last data here, we don't really care about any of that. So we just pass in dummy, just junk data right there. Finally, at the very end, we just send the packet to the user. So this user is going to be the viewer of the replay. Okay, so hopefully that makes sense. What I want to do now is just verify that we don't have anything that we broke. We need to update these methods here as well. So let me just go and compile this, make sure it compiles, and then we're going to throw it on the server to test it out. All right, I'm on the server now, and you might notice that even if you reload, the entity is still here, the fake NPC that we created. This is just because we haven't created a way to like despawn them for the player, because you have to send them a despawn packet. So one way to fix that is easily just to reload or rejoin the server, because then you just get the actual representation of the world. But let me go and test this out now to see if it works. We're gonna need an actual entity to help test this. Let's find out. Let's get like a cow. Cows are cool, man. I love me some cows. Let's make it like a little wall so we can't escape. Or, oh, we can just throw them in here. Perfect. So we're going to make a camera. So create cam test. So we're going to do like this. And then we'll go down here. And then we'll select this. Oh, what the hell? That was weird. This. Okay. Alright. So I think he should be in the zone technically. He's kind of like on the border of it. But that should count, I believe. So let's go ahead and create that camera. Now we're going to start recording it. So let me go ahead and open the console to verify there's no exceptions while we do this. So start recording. Boom. And okay, looks good so far. And yeah, it's tracking him. So now we're gonna go ahead and stop recording. All right, cool. And now let's go ahead and just like smack him around so he moves. Let's go ahead and replay that. Boom, boom. And look at that. We have the cow. So that is pretty awesome. So now we can spawn any type of entity that's not a player and a player using just NMS and also packets. So Hopefully you find that as cool as I do. So now what we can do is make it so that these entities that we have actually move around, because not only do we have the spawn entity packet, we have the location change packet and the despawn entity packet. So if we want to do that though, we kind of have a challenge, which is how do we track entities across the entire replay? So what I mean by that is, we just spawned a entity using the spawn entity packet, but how can we reference that same exact entity, even though it's a fake entity, in a different recordable when we replay it? So let's go to our code real quick. So the way that we can do that is, if you just remember here in our spawn entity recordable, we're already keeping track of a bucket entity ID. So we're already using this to identify entities across recordables, but we need also a way to identify entities across replay as well. So what we could do here is take our bucket entity ID and also track it along with our entity ID. So this right here. So since we now have the knowledge that every single entity in Minecraft also has a entity ID integer that's unique, we can use this value in any recordable that we replay to reference a specific entity that exists on the server. So all we have to do is, if we just go to replay, we can go ahead and make a new collection here. So private hash map, and the key of this is going to be the bucket identifier, because that's how we sort of keep track of it in the recordings. So what we could do is have each unique bucket identifier also correspond to a specific entity that we've spawned on the server. Yeah, so that would be the key. So that's a UUID for the bucket identifier. And then the value would be an integer, which is how we reference these entities that are actually on the server in our packets. So we could call this spawned entities is equal to new hash map. So every single time we spawn a new entity, we add it to the hash map here, so that in future recordables, like the location change recordable, we just do spawn entities.get, pass in the bucket UUID, and then it gives us the actual entity ID, so we know what entity to change the location for. So now we could go back to spawn entity recordable, and now wherever we spawn entities, like right here, after we send the packet, we can also do replay.get spawn entities.add, or put rather, and then now we just put the bucket entity ID, and then now we also put the entity ID. So that'll be for non-player entities. And then for this one, it's kind of similar. We're not using packet events, but it's kind of the same concept. We can do replay.get spawn entities.put bucket entity ID, and then now we just need the actual integer for the entity ID that's on the server, and we can get that from the NPC. So get ID. So straight from NMS, there we go. All right, so now that we have a way of tracking our entities across the entire replay throughout the recordables, now we can work on our location change recordable. So what we need to do is figure out how to send a packet that will move our fake entity, that will make it appear like it's moving for the player who's viewing the replay. So for this, you have the update entity position packet. This is for if the entity is moving less than 8 blocks. If an entity moves more than 8 blocks, you can use the teleport entity packet. And then you also have the update entity position and rotation packet, which combines both the position change and the rotation of the entity. And then you also have just the rotation as well. So we're going to use this one, the update entity position and rotation. So let's figure out how to make the wrapper for that. So we'll do move packet is equal to new wrapper play. It's a play packet. It's from the server, and this is going to be a entity position packet. The bad thing about it is that the names often don't really align with the names on the wiki. Even though the wiki is like what everybody uses to know what package they should be using. It would be nice if these wrappers had similar names, but a lot of the time the names are different. So you kind of have conflicting options here. You have like wrapper place server entity movement. You also have wrapper place server rotation. You have relative move. So if we just look at movement, for example, this is just asking for an entity ID. That doesn't really seem like the right one. You have also relative move, but then you also have relative move and rotation. So if you're just looking at this for the first time, it's probably going to be this one, because we saw that it combines less than 8 block movement and rotation. So tab to complete, and this seems about right. So it's asking for the entity ID, the movement that we want to do, so the delta XYZ, which is the change in their position, the float yaw, the float pitch, which is going to be for the rotation of the player, or the entity in general, and then if they're on the ground or not. So for the first one, for the entity ID, for this we would simply use our get spawn entities map. So get spawn entities.get, and then pass in the bucket entity ID, and that should return the actual integer for the entity ID. And then now we can pass in the delta x, which is the change in x from the previous location. Now for this location change recordable here, we're only currently tracking their new location. So this is where like you have to kind of decide, do you want to add another field to this that tracks their previous location and then also tracks their new location? Or you could do what I did, and I actually just ended up using the wrapper play server teleport entity or entity teleport. The only difference, so literally the only difference between this one and the other one is that it's supposed to be used for more than 8 blocks, but it works fine for short movement as well. So I haven't seen really a difference at all. So I'm just going to use this one. It's actually easier to use it as well. And that way we also don't have to track the old location as well. So we can do replay.getSpawnEntities.get bucket entity ID. And then now for the location, you could do Spigot conversion util from bucket location, and then now it's asking for if it's on the ground or not, and I'll just say false. That, I mean, to me, it doesn't really change anything, so that's pretty good. Let me just make this more readable for us. There we go. Okay, so now we have a remove packet, so now we could just do user.send packet move packet. So if we did everything correctly, what it should do is take our entity that we spawned previously and move it to the new location every single tick. So let's go ahead and throw this on the server and see what happens. Okay, we're going to start recording now, and we need to make sure that we remember how we move the player around. So we're here, and then we're going to look left, we're going to look right, we're going to look straight, and then we're going to start moving. We'll just go in like a little circle here. And our head's going to go up, our head's going to go down, middle. Okay, we got enough movement, so now we can stop recording. And now let's go ahead and take a look at how that will look. So we'll do replay. And look at that. He's immediately moving. So he is turning his body. He's now doing the circle. But something that you'll notice right away is that the head is not moving. It does move up and down, but it does not move from left to right. Other than that, it works perfectly. That is pretty awesome. Like when I first figured this out on stream, if you were there, this was huge. Like just to be able to record player movements, like look how smooth it was. It was so smooth how it worked. Just being able to do that just proves that everything that we're doing so far is working almost perfectly. So we just have to keep improving it to add more features and make it just, better. So why is the head not moving? It's moving up and down, but not left to right. This is because packets are weird. There's actually a separate packet for head movement that is left to right. So if we look at the wiki again, let me pull it up. There's actually a separate packet, we just have to find it, called, I think it's this one, set head rotation. So changes the direction the entity's head is facing. While sending the entity look packet, changes the vertical rotation of the head. Sending this packet appears to be necessary to rotate the head horizontally. So we're not using the entity look packet, but the teleport packet sort of encapsulates that to already handle the vertical rotation. So I don't know why it doesn't also handle the horizontal rotation of the head. So all we have to do to fix this is just send this packet as well. It's just weird that you have to even do that. So let's just go back to the code and figure that out. So we'll just add another packet here, the head look packet. I'll do new wrapper play server head entity head look, and for this is asking for the entity ID, so replay.getSpawnEntity. And then now we need the head yaw, and the yaw is something that's stored in the location, so we could just do location.get yaw. This is just a rotation sort of value that we could use, and that's it. So now we could just send the packet, so user.sendPacket head look packet. There we go. So now let's go ahead and retry this out, and it should encompass now all movement of entities. All right, now I'm going to start recording. So start recording. Boom. All right, so now we're going to go right here, go in the middle, look up, look left, look right, look down, turn around, spin around. Now we're going to run around. We can even jump around. Whee! Okay, now we're going to stop recording. Now let's try replaying it. Look at that. Okay. Up, left, right, down, spin around, run around. And look, I can even jump around. Guys, is that not awesome? Like, come on. That is really cool. I love that so much. Alright, so we're making great progress so far. We've now been able to spawn entities and also change their location. So now it would be nice to have a way of despawning entities so we can just finish the other recordable that we have so far. It's actually not that hard, we just have to send a despawn entity packet. So we'll go back here to despawn entity recordable, and now we're going to do wrapper play server destroy entities. And then we'll do destroy entities. This is going to be new destroy entities, destroy entities. There we go. And so now you just pass in either one entity that you want to destroy or a list of entities. So that's pretty simple. So we could just do replay.get spawned entities.get bucket entity ID. And then so now we could just simply do user.sendPacket destroy entities. But something that we cannot forget is that this ID, right, represents the actual entity ID of an entity that's on the server right now. So since we are destroying it or removing it from the server, I think it also makes sense to remove it from our hash map. That's especially useful because what could happen is you spawn an entity, the entity runs out of the zone, so it's despawned, and then it runs back in, so you get a new spawn. And so whenever a new spawn happens, you get assigned an entirely new ID. So it would make sense to replace that ID with a new ID. So removing it allows you to do that. So we could do replay.get spawn entities .remove bucket entity ID. So that will move the entities every time a despawn entity recordable is, reached. Another thing that would be nice to add is just removing all of the entities no matter what, whenever the end of the recording is reached, because if a entity never leaves the camera zone during the entire recording, then a despawn entity recordable will never be created for them, right? So when a replay is finished, we still want to remove that entity because we don't want it to just linger there. So we should probably do some cleanup is what I'm trying to say. So let's go back to our replay service. And here we have stop replay. So in this, we'll just add the logic for that. So what we'll do is despawn all the active entities. And as you know, all of the active entities are going to be stored in that hash map. So we could do replay.get spawn entities .for each. And we could say that's going to be a key value pair. So UUID and entity ID. And then for each of these, we want to just send that despawn packet. So just copy this code here, like that. So destroy entities, and then just pass in just replace this with the entity ID. And then we can replace user with just packet events.get API.get player manager.get user player, or replay.get viewer. There we go. So yeah, anytime we stop a replay, whenever this is called, it will get all of the spawn entities that we have not already removed, and then just remove them by sending a despawn packet. And we don't actually have to remove them from the hash map because after this, we're removing the entire replay from memory, so it'll do that for us. But I guess if you want to be more proper, we could still do it. So replay.get spawn entities.clear. Something else that I want to do is add another method that will help us out. So public void stop all replays. So this will just do replays.for each. So for each replay that we have, we just want to do this .stop replay, and then we could do this .replays.clear. This is useful for our onDisable method in our main plugin class, so that anytime our plugin is reloaded or it stops or something like that, it cleans up all of our replays and despawns all of those entities for us. Because if we don't do this, every time I reload the server, all of the NPCs will still be there. They'll be stuck there. So having this here is going to be very nice. So we could do replay service dot stop all recordings. There we go. And I'll just move this to the top. I think that's a good place for it. I don't think we need to do anything else. So I think it's good to just throw this on the server now and test it out. So hopefully now whenever we reload or an entity leaves a zone, it should despawn them for us. All right, let's do this again. So I'm going to start recording. We are now in the zone. So let me just run around a little bit, and then we're going to hop out, and boom, this is where it should despawn us. Then now we're going to run back in. Now it should spawn us again. Okay, and then we're going to jump out again and jump back in. Now let's stop recording. Okay, now let's go and try this out. So we're going to do /replay. Boom, boom. Okay, he's running around. He's going to jump out. Look at that, seamless. He's about to jump back in. Oh, and got a bunch of exceptions. Okay, so it almost worked. Now we just need to figure out why it's doing that. So let me go down and figure it out. Okay, so after a while of digging, it actually did take me a while to figure out. The reason that it's not working and it's giving us these null exceptions is because, we're doing everything correctly, but it looks like the tick was being counted multiple times. It's just going up by 2s instead of by 1s, and so it was skipping the part where it was respawning the entity, and so that's why it was getting a null exception. Because if you don't respawn the entity, the recordables that come after won't be able to grab anything, and then so when you try changing the location, for example, there's nothing to change it for. So Hopefully that makes sense. But the issue is because we're using finally here, which will just make it so that it runs no matter what. Like this code inside of here runs no matter what. But I did not know that this return here would affect that. So even though we're returning here, which I thought would just return out the entire method and skip the finally, it actually returns and then it still runs the finally afterwards. Maybe that sounds obvious, but I did not know that would do that. I thought this would override the finally and just return the entire method, but it doesn't. So the solution to this would just to be take out this, and now it won't count by twos every time the take recordables is null. So it'll just count by one every single time because the finally is there. All right. So let me go ahead and throw this on the server again so I can show you guys that it's working. All right, now I'm going to start recording. I'm going to run around a little bit and then jump out of the zone. I'm watching the console, of course, to make sure it's actually detecting that. So I'm back in the zone now. Now I'm back out of the zone. Now I'm back in the zone again. All right, just running around, getting some data. All right, now we can stop it. Let's go ahead and take a look at, now let's go ahead and replay it to see if it works or not. So we're going to do /replay. Click this, click the recording. Okay, so far so good. He's running around. He jumped out of the zone. Now he's back in the zone. No exceptions. So as he jumps out, it despawns that entity and removes it from the spawned entities list that we're tracking the entities with. And then as they jump back in the zone, if they do, it will make a whole new entity for that person, and then it will keep track of the new ID so that any location change recordables that you come across can be used on that entity instead. So hopefully that makes sense. Hopefully that whole idea of tracking entities and their IDs makes sense. If any of that is confusing, then just make sure you consult the source code to, just stare at it a little bit and see if you can understand it, because it's very important that you understand that part. Now, one thing I noticed is that at the very end, we get a null exception. And if I had to guess, it's because we're probably despawning the entity. And then there's a location change recordable right after that, because that's the type here. So that just has to do with the ordering of our recordables, and we can fix that in the future. I'm not too worried about that. I think now we should focus on an important part, which is setting up the MongoDB database so that we can store all of the data persistently. Because at this point we have done the hard part, which is setting up the core functionality for recording and replaying stuff, which is, I'm very proud of this. This is awesome. Pat yourself on the back if you got this far. But I think now we need to do another really important part, which is set up the database so that we can store everything, because it gets really annoying to have to create the camera every single time and do everything all over again. If we can figure out how to store everything, we don't have to repeat those steps every single time, and we can test this a lot faster if we run into any bugs in the future, okay? Alright, so if you've never used MongoDB before, just like a high level overview of it, it's a type of database called NoSQL database. So probably the database that you've heard of already is a MySQL database, which is just a type of database that's an SQL database. And these are like the most popular databases out there. But there's also an alternative solution to that, which is a NoSQL database that stores data a little differently in a more unstructured manner, where you don't have to conform to this strict schema that SQL databases have to do. So in a SQL database, for example, you have these tables, and these tables, the data in the tables have to fit that table schema every single time you insert data and update data and all that fun stuff. But with MongoDB, for example, you have a little more freedom. You can just put data in the collections, which is just a table, and you don't have all these strict rules for how it's structured. Like even like two different pieces of data in the same collection can be different in terms of what they contain. So just at a high level, you have more flexibility with how you can store your data and work with your data in MongoDB than you can with an SQL database. And so you may be wondering, anyway, what's the reason that I just decided to do MongoDB instead of SQL databases? Because I do have a lot of experience with SQL databases, so why would I choose this? The main reason was because the way that we're storing our recordables, if we just go back here real quick, we have this abstract class here, and then we have all these different recordables that inherit from that abstract class, right? So when you store something like that in a SQL database where you have like these polymorphic types that inherit from a parent type, storing that gets a little complicated, and it's definitely possible. It's definitely possible for sure. It's just, it gets tricky, and I didn't want to have to deal with all that, because if you just use MongoDB, for example, it's just kind of automatic. You don't have to worry about how to properly structure it and have everything, and how to have everything relate to one another, and like stuff like that you'd have to worry about otherwise. So to summarize, I'm doing MongoDB because I tried to do SQL and it was a lot of work, but when I switched to MongoDB, it was a lot less work. Okay, we still have to do a little bit of setup and stuff like that, but It's just easier. So hopefully that explanation wasn't too bad. If you want to know more about MongoDB, just make sure you check out some videos about that. I have a few in the series already. They probably need to be updated a little bit, but I think the most recent one is a good video. But yeah, it's a great option, and that's what we're going to go with. So now I want to show you this, which is MongoDB Atlas. This is a free, and I want to say it again, free service that you can use yourself for having just a database. It's just hosted by MongoDB. They give you a free database that you can use, and then you can connect your applications to it to store data for free, So I'm not sponsored by them. I wish I was, but yeah, you can sign up, just, click try for free. You can sign up using your Google account. Easy peasy lemon squeezy. So once you have signed in, you're going to get the option at some point to create a cluster, and it's pretty easy. I'm not going to do that right now on screen just because I've already done it. And if you want to see it step by step, then just watch my other video in the series on how to do that. But yeah, it is pretty simple. If you know how to use a computer, you just go through the process of creating a free cluster and just make sure it's the free option. And then after that, you'll get to this screen or something similar to it. So here's your cluster, and then you can, browse the collections within the cluster if you want to. So it'll take you to the database. And so these are all the individual databases within your cluster. For you, it'll be empty if you just created it. So you can just create a new one. So what you want to do is click create database, and then you want to choose a database name. So for us, since we're doing a Minecraft plugin, called security camera, I think it makes sense just to call this security cam. You can call it whatever you want though. And then now we need to give it a default collection. So this is just a table, in other words. So just a collection of data, right? So what are we storing? So the most basic thing that we're going to store is recordings, right? And then we don't really care about any additional preferences. So we're going to click create, and it's going to create a new database in our cluster that we can now use. And so now we have this recordings collection, and then we could add more collections to it in the future. So yeah, that's pretty much all you need to get that part set up. You just need the database for the most part. And so now we just have to worry about how to actually connect to it within our Minecraft plugin, within our Java application, okay? So for that, you would go here. This is the documentation specifically for Java. So MongoDB has a bunch of drivers or libraries that you can use with pretty much any major language, which is awesome. But since we're using Java, obviously we're going to focus on this one. So we're going to focus on the Java Sync one. This is like the default one that you would use. There's also the reactive streams one, but we don't really care about that one. Okay, so we're going to click this, and this is going to give you a ton of information. It's honestly a lot. It's kind of overwhelming, but you can read through all of this. It teaches you how to, connect to your application using MongoDB. It teaches you all the information about how to even work with MongoDB. It's a lot of information, so I do recommend reading it if you have the time, if you want to, but you don't necessarily have to. I'm going to guide you through the parts that we need for this specific plugin, okay? So what we care about though is connecting to the MongoDB database. So you can click this, for example, and this gives you, for example, some good information about the connection string, the actual code for how to do it. This is a great sample piece of code here. All that fun stuff. So I'm going to have a link for this in the description below. Make sure you check it out. I highly recommend you even bookmark it, okay? So what we've done so far, though, is we've installed the dependency in our pom.xml. If you can remember, we just have the MongoDB Java driver, which is version 5.1.0 at the time of recording, so that's pretty good. So now all we have to do is write the code that actually connects to the database, okay? So let's go back to MongoDB Atlas, and what we want to do is go to database access. Now you want to go to add new database user, so click that, and now we want to create a new user and password that we can use to connect to our database. So this is something that you should definitely keep secret somewhere. I don't recommend storing it directly in your plugin's code if you're going to, especially if you're going to distribute this or even store it on GitHub. Don't do that, okay? This is just, I'm going to be storing it where you guys can see it, just right in front of your eyes, but obviously it's not going to work by the time you actually try this out. So yeah, the point is don't ever show people your username and password for your database. I'm only doing this just to show you guys how it works, okay? Yeah, we're going to use the authentication method password. So we're just going to choose a username and a password. So we're going to call it YT tutorial, or we'll just call it tutorial. How about that? Tutorial, and then password, you can auto-generate one if you want to. You could also copy it just like that. So let me just go and copy this and put it somewhere safe real quick. All right, so that's saved now, so we can scroll down, and we just want to make sure that we enable admin privileges, so we can do add built-in role and do Atlas admin, or if you want more fine-grained control, you could select something else like read and write to any database. Both of these will probably work, honestly. We definitely want to be able to write though, so definitely the top two, not the bottom one. And yeah, that should be it. So we can click add user now. and now the user has been added. So it's actually deploying the changes and doing all that stuff. So just give that a second before you actually do anything. But okay, so now go back to database, and now you can click connect, and then this will help you basically teach you how to connect to it. So just click drivers and then make sure it's Java, and then we're going to do the latest version. And then now it gives you an example of the connection string that you can use to connect to your database. You can actually get a full code example too, which is nice. But yeah, so you just want to copy this string here, and then whenever we use it, just replace username and with your username and then password the password. You know, pretty self-explanatory here. So yeah, just copy that. I'm going to store it here as well. And let's go ahead and replace it. There we go. So that should be good. Just make sure that there's a colon in between the username and the password. Sometimes you may miss that. All right, so let's make a new package here specifically for database stuff. And then we're going to make a new Java class. We'll call it the Mongo service. There we go. And so inside of this, we're going to have one thing, the Mongo client, private final Mongo client. There we go. And then in this constructor here, we can just do all of the code we need to initialize the service and set up the Mongo client. The Mongo client is what other parts of your application is going to use to connect to your database and stuff like that, okay? So first of all, we want to store our string, so we can actually do that up here. Like I said before, do not store your string as plain text inside of your application. That's a very bad idea. And if you even try doing that and you store it on GitHub, GitHub will send you an email and like protect you. They'll notice that you did that and try and stop you, because that's a very bad idea. So private final string connection, or just call it URI. That's what you usually call it, URI. And then we can come back here and just take this and we'll just put it here. There we go. So now we can do server API. Server API is equal to server API dot builder dot version, and we want the version to be just version 1. That should be good. And then we can go ahead and build that. Okay, and then now we want the Mongo client settings. Settings is equal to Mongo client settings dot builder. And then now we have some settings here. So one of them is going to be the UUID representation. This is important, I found out, because we in Minecraft like to use UUIDs a lot, right? So this is just you telling MongoDB how you want it to be handled. So we can do UUID representation. You can look up how all these other things work, but we just want to do the standard one, so it'll just handle it in a standard way. So that will fix any issues that you might have with UUIDs if you don't have that set. And then after that, we can do apply connection string, and then we'll do new connection string, and then pass in our URI. There we go. And then after that, we can do server API, and then build. And then in the future, if you have any more settings that you want to add, you just add it to this. Easy peasy lemon squeezy. Now after that, you can go ahead and create your Mongo client. So Mongo client is equal to Mongo clients, plural, dot create. And then you pass in the settings. There we go. And then now, since this is private, we just want to use this to make a way to access our database. So what I like to do is just do public Mongo database, and we can say get database. Since our entire application is using the same database everywhere, I think it makes sense just to have a single method for doing that. So return Mongo client.get database and just pass in the database name, which we know to be security-cam when we created it a second ago in MongoDB Atlas, okay? All right, so this should be all the basic stuff that you need to just be able to connect to the database. We're gonna have to add some more stuff to it in just a minute here, but that's a good start. So now let's go to our main plugin class here, and let's go ahead and create an instance of this class that we created. So we can do private Mongo service, and we're gonna add a getter for that so we can get it anywhere that we need it. This dot Mongo service is equal to new Mongo service. So now the goal will be to figure out how to store something into the database. And let's go ahead and start with cameras, since that's the first thing that we have to do in our plugin. You can read the documentation on the website to figure out how to actually store stuff into the database and interact with it. We're going to try and structure it as nicely as we can to keep everything separate and, you know, more organized. So we're going to create a new package here called DAO, which stands for Document Access Object. So every entity that we're storing into the database in a collection will be referenced with their data access object. So we're going to create a new one inside of here called the camera DAO. So the camera DAO will be the class that you use whenever you want to get cameras from the database, store cameras in the database, update cameras, delete cameras, anything like that. This is how you directly interface with the database with this specific class here, okay? And then we'll build on top of it with our service layer. So the camera DAO is going to need a way to talk to the database directly, and this is going to be via the Mongo collection. So for this, you need to give it a type, and then you want to tell it what entity this is like for. So this is the Mongo collection for the camera entity. And we're going to call this just collection, that's fine. And then now in the constructor, we can initialize this if you want to. Instead of passing it in, what we'll do is just do it like this for now. So this dot collection is equal to security camera dot get security cam dot get Mongo service dot get database, the method that we just created. And then from the database, you can get the collection. So the collection will be just named cameras. And then now you can provide a class reference to the class that this will be storing, so camera.class. So with the magic of the MongoDB Java driver, it should now know whenever we use this collection here that it's going to be referencing the database collection cameras, and it's also going to be working with camera objects. Like this is how you connect the Java side of things to the MongoDB side of things, in other words, okay? So now here we can write methods that will query the database directly. One of the most basic ones you can do is insert, so that you can insert new cameras into the database. So we can do, for example, public void insert camera. This will be the camera that we're trying to insert into the database. Then now we can do collection dot insert, and you have all these methods here that you can utilize. We can just do insert one, and then now it's asking for a camera because that's the type that we specified up here, and we just pass in camera like that. It will take all of the data within the camera class or within the object that we pass in it and convert that into BSON, which is a special form of JSON, text, and store that into the database. So it should be able to convert the UUID, the string, the location, all that stuff. I'll tell you more about that in a second, but it should be able to convert all of that and store into the database. And then what it will do is also update the ID, right? So what we need to do is change this part. So instead of a UUID ID, we want to change this to a object ID from BSON, because in MongoDB, the IDs are stored as object IDs. So now, like I was saying before, whenever you insert, if everything goes correctly, it will insert it, and then it will automatically set the ID field for you. So you don't even need to return it because it's a reference variable, it's just an object. So whenever you insert it, it'll automatically modify the field to add the new ID. So if this doesn't throw an exception, you'll just have the ID wherever you called this on the same object. So every single DAO that we have is going to have a few methods in common. This is pretty much common with any application that works with the MongoDB database. And so what people usually do is create a common interface that all of our DAOs will inherit from. So you can call it, for example, iDAO for DAO interface. And then now in this, you can define all the methods that they should have, just any shared methods. So I'll just copy and paste this. Boom. So now every single of our DAOs is going to have, let me just add this for the generic type and just import list. So now every single DAO that extends this interface here will have an insert method, a find by ID method, a find all method, an update method, and a delete method. So yeah, that just creates a little bit of structure as well. And it also makes sure that every single DAO has all the basic stuff that a service would need to work with the database, okay? So if we go back to the camera DAO now, we just go ahead and do implements iDAO, and we just do the type here, which is camera. And now it's complaining because we need to implement all those methods that we just told it about. Let's just add this so it fits everything else. So for find by ID, we can do return collection.find, and then you could put in like the query for how you want to find it. So we could do like filters.equal. So we're saying we want to find documents that satisfy this equals condition here, and then we'll do underscore ID, and then pass in ID like that, and then after that you can do first. So all this is saying is that we're going to find the first document that matches the ID field for the ID that you passed in, okay? So for find all, you can do collection.find.into, and you could do new array list. So this will take all of the cameras and then put it into an array list for you to use. You don't really want to do this if the collection has a lot of data in it, like hundreds of thousands of documents or even millions of documents, but there won't be that many cameras in a collection, so I think it's fine to do this. Now for update, we're not really going to be updating our cameras at all, but I'll just show you how to do this part anyway. So var updates is equal to updates.combine, And then here in this thingy here, you can provide a list of fields that you want to update. So if we just go to camera real quick, if for some reason we want to update the name field on our camera, we can just do something like this: updates.set name, which is the field name, and then entity.get name. So what this will do is take the new value for name from this one that you pass in and just update the field on the document, the name field on the document. And then you can just add as many fields that you want to update to this as you see fit. And then now you just specify which one you want to update. So we can do collection.update1, and then we could do filters.equal again. So we're just checking it by, so we're just matching by the ID like before. Then we do entity.get ID, and then we pass in the updates that we're trying to apply to that entity that we match to. So this is specifying the updates that we want to do, and this is just telling it apply that update to any documents that match that ID. And since IDs are unique fields, obviously this will only apply to one of them or none of them if none are found with that ID, okay? Oof, okay. And then now we have delete, so delete's another one, so we could do collection.delete1. And yet again, we just need to tell it which one we're trying to delete, and so we'll just match it by its ID. Alright, so this gives us the basics that we need to work with the database for cameras. So now we can instantiate this camera DAO and start using it within our service. I'm actually going to make a quick change to this real quick. Instead of just calling it like statically like this, we're just going to pass it into the constructor. So Mongo service. So then we could do, instead of like this, we just do Mongo service .get database .get collection. I just find that to be cleaner, because then now we can go to our security cam main class here, and then right after we do the Mongo service or initialize it, we can now initialize the DAO as well. Let me just add that up here, camera DAO. And then right under the Mongo service, when we initialize it, we can do this .camera DAO is equal to new camera DAO, and then we just pass in the Mongo service. I think it makes sense like that in the situation because it like directly relies on it. I don't know, it just makes sense to me. So I'm just gonna pass it in, and then yeah, they're like connected very tightly. So, but yeah, now that we have that DAO, we can start using it in our service. So if we go back to the camera service, we can get it here. So we could pass it in the constructor like we did just like 2 seconds ago, or you could just grab it statically like the other times we've been doing it. I think what I'm going to do is pass it in. I just prefer that here as well. So do private final camera DAO, and then now we could do like that. Okay. And then now we can go back to security cam, and then we just pass in the camera DAO into that. There we go. So now we know, so now just by looking at this, you see that we have the Mongo service, the camera DAO relies on the Mongo service, and then the camera service relies on the camera DAO service. And then you can call them in order, because if you call it out of order, it's going to give you exceptions because, it hasn't been initialized yet. So I feel like that just feels better to me. So now in the camera service, instead of relying on this list here of cameras that are stored in memory, we can get rid of that and replace it with calls to the camera DAO so that we can store it in the database. So let's go ahead and do that. Let's get rid of this now. So now we should just have the hash map of cameras that are being currently created. So we just got to fix all these errors now. So the first one's actually really easy now. So we can get rid of all of this, and we can just do camera DAO.find by ID, and then pass in the ID. So here it's asking for a object ID, because that's just the data type that MongoDB likes to use. So if you want to, you could change this to object ID. So that cleaned the service up a little bit. Let camera DAO worry about how to actually grab it from the database. Let it worry about that implementation, and the service can just focus on just doing the grabbing. Just call this really easily. And nothing has really changed from the service's perspective. It'll just return null if it can't find it, but if it can find it, it'll give the actual camera object for you to work with. All right, so here we have get cameras for a player, so we can do return camera DAO.find all. And then for this one, we're getting all cameras that have a specific owner. So we would go back to our DAO and add a specific method for that. So public list camera find all by owner ID, I believe. Let me see. Yeah, owner UUID or owner ID. So we pass in the UUID of the owner. So I think we can take this, we can borrow this from find all. So we could do filters.equal, and we want to make sure that the owner field matches a specific value. So owner and owner like that. So what this should do is give you all camera documents from the camera's collection that has the same owner that for the one that was passed in, okay, and give it to you as an array list. So now we can go back to our camera service, and we can call camera.DAO.findAll by owner ID player.getUniqueID, like that. So now we have the cameras.add one being called, so we can replace that with camera.DAO.insert and pass in camera. And we need to fix some of these places here. So here where we're calling find by ID, we're trying to pass in a string, but it's asking for a object ID. It really depends on how you want to design it. You could have just asked for a string and then did it inside of the service, but yeah, I think I'll do that. So I'll go back here and then I'll change this object ID to a string, because a string is easier to work with outside of this service. And then inside the service, you could simply wrap that. So new object ID string. So now the benefit of that is you don't have to change any of the places where this was called before, where it just wanted a string. All right, we're making good progress. I like what we have here so far. We should be able to interact with the database now, except that we're missing one thing. If we go back to our camera class here, we see that we have these types here like string. That's pretty simple. A database can support that. A UUID, that's pretty simple. We already set that in the settings pretty much. It should be able to handle UUID. But we have a location here, which is a object or a class specific to bucket. Now, MongoDB has no idea what the hell bucket is, right? Obviously. So it's not going to know how to translate this location object from bucket into BSON or JSON text, or however it wants to store it into the database, okay? That is complicated. So what we need to do is make something called a codec, which in MongoDB, if you look at the documentation, is just a way to tell MongoDB how to convert an object or a class that it's not familiar with to something that it is familiar with. So if we just go back to our database package and make a new package called codecs, we can go ahead and make a new Java class. We can call it location codec. So this will implement codec from MongoDB, or BSON rather, which is also from MongoDB that we imported. And then we could do location from bucket. And then we can import these methods here, or implement these methods rather. So we have decode, encode, and get encoder class. So for this one, get encoder class, we're just telling it what class this is like connected to, same as we did in the when we grab the collection. So return location.class from bucket. And then now for decode and encode, this is kind of how it sounds. This is telling it how to convert it from a Java object into BSON, so that MongoDB will know how to store it into the database. And then for decode, it does the opposite direction. How can we take it from BSON that is stored into the database and convert it into an actual Java object? I'm just going to rename this to writer, but we can do a writer.start document. So that's just telling it that we're starting a document. And then now we can tell it every single field that we want to store in that document. A document, again, is just a piece of data in a collection in a database, okay? So what information do we need to store about a location persistently so that later on we can decode it and grab it and it'll be the same thing? So a location is going to have an XYZ, it's going to have a world, it's going to have a pitch, and a yaw. That's all the information that we need to store, okay? So let's start with the world. So we could do writer.write. And then you have all these different, methods here. We just want to tell it the data type. So this will be a string. So write string. Now we can give the field name. So this will be stored as a world. And then we can do location.get world.get name. And then we can add everything else. So we could do writer.write double for the XYZ value. So double x location.get x. Now we're done writing all the fields for the document. So now we can end that. So writer.end write end document. So assuming you're familiar with JSON, this will be just an opening curly bracket, a closing curly bracket, and then each of the fields, and then all their values right after that. Pretty simple stuff. So now we can do decode. So we're going to start by doing document. Document is equal to new document codec from BSON. Import that from BSON as well. And we can do codec, or decode rather, pass in the BSON reader and the decoder context. And now we can start to read each of the values one by one. So we could do world is equal to bucket.get world. And for this, you can pass the world name. So we're trying to grab it from the document that we stored, right? So we could do document.get string world. So just like below, we wrote the string. Now we're getting the string. Very similar to how you do with a bucket config file, by the way. So now we just do the same thing for the XYZ. So double x is equal to document.get double x. So for pitch and yaw, we want that as a float. So after we get the double, we can call float value to convert that to a float value, okay? And then after that, once we have all of those fields collected one by one, we can now reconstruct a location, a bucket location out of that. So return location, world, x, y, z, yaw, and then pitch. And then we need new, obviously. There we go. Looking at it now, it's not really that complicated, but this was pretty tricky to figure out. But once you know how to do this, it's pretty awesome because that means that you can store any type of data, for the most part, in a database, especially if it's not too complex, at least. Pretty cool if you ask me, because that's definitely a challenge with other types of databases. How do you convert Java objects into actual database, like stuff you can store in a database? So now we need to register our codecs that we have created. In the future, we'll add more, but right now we just have one of them. So we need to go back to our Mongo service, and at the top we'll just do codec registry. Codec registry is equal to codec registries plural dot from registries, and then inside of this you can go ahead and do Mongo client settings dot get default codec registry, and then after this you could do codec registries again plural dot from codecs, and for this you just provide a list of codecs. So these are all your custom codecs that you just created. So we could do new location codec, and then in the future when we have more, you just do comma and then add whatever ones that you have, okay? And then now down here in our Mongo client settings, we can go ahead and register that by doing .codec registry and pass in our codec registry. So this will register our location codec, just tell it MongoDB that it exists and where to find it. One other thing that we need to add to this configuration that we just added is a POJO configuration. So that stands for plain old Java object. So what this means is that if you just scroll in here on the camera DAO, we have insert, and for insert we pass in a camera, and then we just pass in the camera object directly into insert one, okay? So the question here will be, how does MongoDB know how to translate your custom Java object into actual BSON? And the answer is it does not by default. So we need to add a configuration option that will tell it to convert plain old Java objects into BSON automatically. It will try to do its best to do that. So basically, if we look at camera here, if we just take a look at these data types, we know object ID is supported. That's directly from BSON. String is supported. A UUID should be supported. And then location, we just added a codec for. So this entire camera class should be able to be translated, to and from BSON. We just have to add the configuration option for that. So we'll go back to the MongoDB service, and we could say codec registries, plural, dot from providers, and then inside of here you do POJO codec provider dot builder, and then you could set it to automatic to true. So that should make it so that we don't have to do any configuration, or as little as possible. And let's just go and make this a little more readable like that. And now the only thing that's left to do is just kind of test it out. We're going to find out real quick if it's even working or not, because with MongoDB, if you did something wrong, if you haven't configured something correctly, it's going to throw an exception for you, and you'll see. So let's go ahead and throw this on the server and test it out. So I'll be right back. Alright, so I've just reloaded the server, and you can see right away that it's working so far because it has successfully connected to the server. So that's just the MongoDB server it's connected to. So that's a great sign because we are now connected. And so if we just go ahead and make a new camera here, so create cam test, let's go ahead and set corner 1 and corner 2. This should be the test right here. So if this works, then we know we configured everything correctly, and boom, it worked. Because if you check the console now, no exceptions, and that's a great sign. So now what we can do to really determine if this works is we can go straight to MongoDB Atlas and check the database to see if the data is there. Alright, so I'm in the Spigot cluster that I have. I'm just going to go to collections, and then we want to go to our database, which for me is security-cam, and then you can see that it automatically created a cameras collection for us, and that's pretty normal. So anytime that you try inserting to a collection that doesn't already exist, it'll just create it for you. So before you even click that though, you have information about the database, which is pretty useful. So you have a cameras collection and has one document within it. The logical data size is 255 bytes, which is very, very small, or that's probably bits actually. That's very, very small. Yeah, pretty cool information. So if we click cameras now, we can now view the document. So this is our first camera that we've created in our database. Really cool if you ask me. Let me just zoom in here a little bit. Alright, so we have corner 1 here, and if we expand it, boom, we have all of the data that we told it in the codec to add for a location object in our program. Same thing for corner 2. So now whenever we grab a camera, if we call the find method in our DAO, our camera DAO, it should be able to take this piece on here and automatically convert it back to a location. So we'll figure that out next, but this is just Awesome. This is very exciting. If you've never done this before, if this is your first time working with this kind of stuff, then this is a huge accomplishment in my opinion. And you can also see that it created the ID automatically for you. So, and then we have the name here. So pretty cool. So let's continue testing this. We'll do /start recording, and it should be able to, there we go. We have our camera. So we have our test camera. This is pulled directly from the database, and we can verify that by making a second camera, test2. Let's go ahead and set that one up real quick. Boom, create it. Now if we do /start recording, we now have 2 cameras. So very cool stuff. And now if I also reload the server, all of this information is stored persistently, of course, on MongoDB Atlas. So we can go ahead and start recording again, and we still have the cameras there. So that saves us a lot of time when we're testing this out. Huge accomplishment. So let's go ahead and just, start recording. So we'll start recording on camera 1. Okay, we are now recording. We can run around same as before. Easy peasy. Let's jump out. All right, now we'll stop recording. Okay, so it's stopped and saved. Now we can do /replay. Here's our cameras again. And if we click our camera, we have our recording. So this recording here is not persistent, of course, because we have not done that part yet. We have not figured out how to store recordings yet. So, but if we click it, it's able to replay it still. So awesome. This is getting really fun in my opinion. So now obviously that's the next step. We need to figure out how to store recordings and also how to store recordables. So let's go ahead and figure that out. All right, so now for recording, it's a little bit tricky because we kind of have to make a decision here. So the primary issue is because we have these fields here that will definitely need to be stored persistently, but we also have fields here that do not need to be stored persistently. These are just going to be in memory while we are actively recording. So yeah, we just don't really need those to be stored into the database, so those fields can be separate. So there's different ways you can approach this problem. You could create a DTO, a data transfer object, so that you have a separate recording class that essentially copies all the information but only has the stuff that you would need to store into the database, and then you just convert between the two. So whenever you're working with database stuff, you just keep it as a DTO, but whenever you need the actual recording, you convert it to a recording object, and that's one way to do it. Another way is to create another class called, like, for example, active recording, and then you just have a recording inside of that active recording object along with these fields here, so that active recording is stored in memory while recording is stored primarily or exclusively in the database. So yeah, that's the approach I'm going to do. So what I'll do is just go to data and make a new Java class called active recording. And so inside of this is going to be data as well. And then what we want to do is do private recording. So for now, we'll just take these 3. We don't want to touch this one yet. We'll go over that one in a minute because we have to rethink how we're going to store recordables. So I'll take these 3 Control X, and then replace it right here. And then now we could just take all of this that we had previously in the constructor and move it into a constructor here. So we could do code, generate, constructor. And for this constructor, I think we'll just need recording. Okay, and then we'll do this. And then now for this, it's asking for the recording, so just recording. And then now we could also move some of these methods here that are only necessary for active recordings, so when you're actually recording something. So stop recording is a good example of that pretty much. Yeah, so let's go ahead and take, and also these ones here. So let's just take these ones first and add them here, because those deal with these 3 that we have here. And then now we can go back to recording, and we'll just take the entire stop recording method like that and just have it like here. And then now we'll just change it from this dot in time to this dot recording dot get or set in time, and then just pass in like this. Same thing for intick. We'll just take that and then do recording dot set intick like that. All right, so hopefully this makes sense. Again, an active recording is, I'll just write it down, a recording that is being recorded right now. And then a recording now is data from a recording done in the past stored persistently. All right, cool. So I think that should be it for now. I don't think we need to change anything else. So now we don't need this list here because that's going to be, replaced with the database. We're going to be grabbing recordings not from memory, but from the database. So just delete that entire thing. And then this one is going to be for recordings that are currently being recorded. So we can change this from recording to active recording. So it's a list of active recordings. And then now we just need to change all of these methods here that work with that data. So yeah, so get player active recording. We just want to change it from recording to active recording. And then now we could do get recording. And then for start recording, we're going to create a new recording just like always, but we're then going to wrap that in active recording. So active recording is equal to new active recording. And honestly, we could take this a step further and just take this constructor and also replace that inside of here. So this is really just a shell, like a vehicle for, containing data. So yeah, let me just take this, go here, replace it like this, boom. So this is now going to be responsible for creating the recording. I think that makes a little sense. Just put inside of there just put inside of there. So now we could do this start recording is equal to new recording. And then we could just pass in the owner and the camera. So there we go. And if you want to, you could choose to take this part and just move it to the active recording as well. That's really just a design choice. I kind of like it how it is, honestly. Yeah. Anyway, so now we can go back to the recording service, and instead of creating our recording ourselves, we only have to worry about creating the active recording and then pass in the same data we would pass in previously. So player and then camera, and then now we just pass in active recording into active recordings. Pretty simple. And then now for stop recording, we want to change that up a bit as well. So we're going to change it from recording to active recording, and then we can get rid of this. So this is where we would normally store into the database because we have stopped the recording, right? So we need to replace this with a recording DAO and call insert on that DAO. So let's go back to our database package, go to DAO, and do new Java class recording DAO. There we go. So now we'll do implements, DAO, and the data type for this will be the recording, not active recording, but recording, because recording is specifically for storing stuff into the database. And now we can implement all these methods here that we'll need, and then we'll name the collection recordings. And then we'll do recording again dot class. All right. So now inside of insert, we can do collection dot insert one entity. Let's also verify that we have an ID, and it looks like we do not. So we have a UUID. So we just need to change this from a UUID to an object ID, like we did with the camera class. And then we could get rid of this. We don't need this anymore because the DAO and MongoDB will automatically generate this ID for us when we create a recording. So for update, this one's a pretty important one. Again, we have to specify the exact updates we want to make every time we call this. So updates.combine, and then we could do updates.set, and we could set a specific field. So if we go to recording again, we have these fields here, right? And we have to think about whenever update is called, this is pretty much only going to be ever called at the end of the recording because that's when we update the end tick and the end time. So off the top of my head, that should be the only fields that we would need to update ever. So let's go ahead and set that. So we'll start with end time, and then we'll do entity.get end time, and then updates, and we'll add another one. So updates.set end tick, entity.get end tick, collection.update one, filters.eq ID, entity.getID, and then updates, like that. So now I've implemented all the basic methods that we'll need for the recording DAO. So let's go ahead and make sure that we can create it in our main plugin class here. So right under the camera DAO, we'll make this dot recording DAO, recording. Oh yeah, we have to add the field for it. So now we can go back here and do new recording DAO, pass in the Mongo service like that. So now back in the recording service, we'll just add our recording DAO. We'll instantiate that in the constructor. Or not instantiate, but pass it in through the constructor. And we can just do recording DAO like that. All right, so now in our recording service, we can go ahead and use the DAO. So we can do recording DAO.insert recording. There we go. And let's just change this from recording to active recording so there's no conflict here. So rename like that. And then now we could do get recording. So we're getting the recording from the active recording and then inserting it. And then we can remove this active recording from the active recordings list. And yeah, that should be it right there. So we have get recordings for camera. So this method was using the original recordings list, but we no longer have that list. So this would be a database thing that we need to do. We need to query the database for this specific information here. So let's go back to our recording DAO and we'll add one for that. So we'll do public list of recordings. This is going to be get camera recordings. So we're going to pass in a object ID, which is going to be the camera ID. And so based on that camera ID, we want to get every recording that matches that ID. So inside of recording, we already have a reference to camera. But what we need to do is actually change this so that recording doesn't store camera directly, it stores the ID to camera. So let's go ahead and change that now. So do private object ID, camera ID. And then we'll just take this camera field here, remove it, and we'll add it to our active recording. So our active recording will keep track of the actual camera just because it'll be easier to access it. We don't have to grab it every single time from the database. So we'll do this dot camera is equal to camera. And then now back into the recording constructor, instead of doing this dot camera is equal to camera, we could do this dot camera ID is equal to camera dot get ID. The reason I did this again is because since I'm storing a recording now in the MongoDB database, it doesn't make sense to store the whole camera object. We just want to store its ID because that's all we need to keep track of if we're storing something persistently. So now here in this active recording, this is where we can keep track of the camera in an object state so that we can easily grab it every single time, okay? Hopefully that is not too confusing. But anyways, back into the recording DAO, we can go ahead and do return collection dot find, and we just want to give it some filters here. So filters dot EQ, and we're going to match it by its camera ID field that we just added. So by the camera ID, camera ID. So that should give us every single document that matches that filter. But what's also nice is if we can sort it. So we can actually sort it by some criteria. So we could do sorts plural dot descending, and then we could tell it what field we want to sort it by. So start time. So what this will do is get every single recording and then sort it by its start time descending. So the highest start time, the higher the number, it'll be first. So if it's descending, whatever the highest start time in the database is for a recording, that one will be first, okay? So that's all that's doing here. And then we could do into new array list. There we go. Cool. So now we can go back to our recording service and just replace that inside of here. So we could do this dot recording DAO dot get camera recordings camera dot get ID. And we also have find by ID, which is completely replaced by the DAO already. So we could just do this dot recording DAO dot find by ID, and we could do new object ID like that. Really easy, right? So that's awesome. So now what I want to do just to make this easy for us is just compile this, and we're going to get some errors. So it'll just show us directly where those errors are happening. All right, cool. So inside of our track location task, we have some issues here. So active recording, we'll refactor all of this to active recording 2. We'll change this type here to active recording. So now we can get the camera still. That's working now. We just changed the data type of that. And now the next complaint inside of here is that whenever we called add a recordable, it's asking for a recording, not an active recording. So we should actually change that. So instead of passing in the recording, we're going to pass in the active recording. And then inside of here, we can go ahead and do recording is equal to active recording dot get recording. And now all that still works as before. So back here, now we have no issues, it looks like, except that the constructor needs to be modified. So whenever we call a new track location task, we want to not pass in the recording. We want to, of course, pass in the active recording. So since we're inside of the active recording class, we just pass in this. Boom, easy peasy. And we want to do the same thing for the camera entity tracker task. We want to change it from recording to active recording. And then we'll just rename all the names of that. And then down here, looks like there's no issues, so that's all good to go still. So we just go back to here and do the same thing with the constructor. So here we're calling get player active recording. It's going to return an active recording, but we're storing it as a recording, so that's an easy fix. Active recording. Okie dokie, so it compiles now successfully. We have fixed all the errors that are that have popped up after making those changes. So let's continue working on this to make sure that we can store recordings into the database. Let's go back to our recording class. And something that you might notice here is that we're storing a player type for the owner field. And player is provided by bucket, obviously, so it's not going to be able to translate that. And we could create a codec for it if we want to, or we could just make it easy and just store the UUID, which we already do for the camera class. So I think that's a good approach, because it's not really that hard to take a UUID and translate it into a player. So we're going to change the type from UUID from player to UID, and then we could go down here and where we pass in owner, we could do owner.getUniqueID. So the next part of this will be to figure out how to store recordables. So we're not going to be storing it in memory anymore, so we need to think about how you would store recordables in the database. The first step is to actually just delete this entire field here, and that will break everything that uses that, which is actually helpful because then you know exactly what you need to change in the future to make this work with the new changes. Hopefully that makes sense. But let's also go back to our recording service, and this is the method specifically that will no longer work because we no longer have the recordables map. So we need to modify this chunk here to make sure that it stores the recordables persistently in the database. So currently, if we look at the recordables class, we only store the tick as the field. So we should also make an ID for that. So we could do private object ID from bson ID. And if you look up how you can do a one-to-many relationship in MongoDB, you have a few different options. If you want to, you could store directly in your recording class. If I pull that back up, recording, you could store a list inside of your recording class of just all of the, items in the one-to-many relationship. You could do that and it will automatically translate that into bson whenever you store the recording object. But the main issue with that is we're going to have a lot of recordables, right? So this is going to be, hundreds or thousands of recordables, if not larger, if the recording is long. So it doesn't really make sense in terms of efficiency or storage efficiency to store the recordables in a list on each of the recordings. A different approach would be to make sure that every single recordable that we have is able to also reference the recording that it's tied to. So we could do private object ID recording ID. So then it's a pretty simple query to get all of the recordables for a recording. You simply query by its recording ID. So let's start by making our recordable DAO. So we'll go to DAO, new Java class, recordable DAO. For update and delete, I'm just going to leave them empty because we're not really ever going to be using these methods, but if we ever do want to use them, we can, obviously add some implementation for them. What I do, however, want to do is make a new method, public list of recordables, find by recording ID. So we're going to pass in the object ID, recording ID. So we're going to do return collection find. And the idea behind this method here is we need a way to get all of the recordables that a recording has because we got rid of that hash map, right? So we no longer have a way to get all of that information. So yeah, we just need a list of all the recordables every recording. And then what we could do after that is, sort it into its individual ticks that we had before. And then we could process it like we did before, okay? So we could do return collection dot find, and then we could do filters dot equals recording ID, because we know that a recordable has a recording ID field, so we're going to match based on that field. So recording ID, recording ID. So we could do sorts dot ascending because the ticks count up instead of down. So we could do sort dot ascending, and then we could just say tick. So that's the field that we're sorting by. So on a recordable, we have tick, obviously. So all of the recordables that came first will be in the beginning of the list, and then after that we could do it into new array list, same as before. So here we can make some changes. So we could start by doing recordable dot set recording ID. This is very important because we need a way to associate a recordable with a specific recording, as we just saw. So recordable dot set recording ID, active recording dot get recording dot get ID, and then we'll go ahead and take all of this and replace it with the recording DAO or recordable DAO. We don't have that yet, so let's go ahead and add that at the top. So private final recordable DAO, that's going to be passed in. So now down here we could do recordable DAO dot insert recordable. So every time you add a recording, it's just going to, get the recording, set the recording ID on that recordable, and then add the recordable to the database. Now let's go back to our security cam main class and just pass in a recordable DAO. So we need to add that as well. So getter private. Okay, we're making progress here. So we're going to have to make changes to how these recordables are now grabbed later on when we do the replay. So if we go to our replay service, or actually our replay task, you can see that we have issues because we no longer have that recordables map. So let's go to our replay class. And inside of here, we're going to make a new field, new collection. So we'll do private. So we're going to do private queue. It's going to be a list of recordables. And we can call it the recordable queue is equal to new linked list. Linked list is an implementation for a queue in Java. And if you don't know what a queue is, I highly recommend you learn about collections and data structures, because a queue is just, it's a pretty simple one. It's just like in real life, if you're in a line, whoever's at the front of the line will come out first, and then whoever is at the back of the line is going to be last. Okay, that basic principle at a high level. What we're going to do is sort it so that the first list that we grab from this queue should be tick 0, and then so on. So every list after that will be the next tick that we can grab. I think this implementation makes a little more sense if it's already sorted in that way. The only downside is that we have a burden now. Whenever we load all those recordables from the database, we have to make sure that we sort them correctly into the queue, so that, yeah, so we just have to make sure it's sorted, because of course, because the whole idea of a queue is that it's in order, so we need to make sure that we insort everything in order as well. So again, the first tick, all of the recordables that happen in the first tick will go first into the queue, and then the next tick will have all the next lists and so on, okay? So what we should do now is go back to our replay service and make it so that it can load all of those things and put them into the queue. So here's the method where we load the replay. So let's also load the data for the replay, which is the recordables. So I'll just do it in between here. Recordables list. And then now we're going to need the recording downside of here. So let's go ahead and add that at the top. So private final recordable DAO. Pass that in through the constructor. And then now we can do recordable DAO dot find by recording ID. And then the recording ID is gotten from there. And then now, so there should be a list of all the recordables sorted ascending by the tick, right? But we still have to take all of those recordables and then sort them into lists, because we still need a way to group them together. Now for this, I'm just going to copy some code, because it's going to be, a lot of crap that I have to type out. So let me go ahead and do that. I'm going to be honest, this part is completely AI generated. It's kind of tricky, and I didn't want to spend too much time figuring it out. So just let, ChatGPT do its thing. Basically, yeah, it's just going to sort our list of recordables into a list of recordables grouped by their tick, just like we had similar to that hash map. So now with that list of recordables, we can then do group for each, and we could do replay dot get recordables queue dot add, or actually we could do : add, which will just add the current list to that queue. So yeah, now whenever we call replay recording, it's going to get the recording, create a new replay out of it, get all of the recordables tied to that recording and add it to the replay, so that whenever we use the replay, we now have a recordables queue that we can access for every single tick of the recording. Okay, so now in our replay task, we can change some of this here. So instead of doing replay.getRecording.getRecordables map, we could do replay.getRecordableQueue.poll. So this will get the next list from the queue, which should just be the next tick. So it's very important though that you make sure that whatever this does, and it'll add a empty list for a tick that doesn't have any recordables, if that ever happens, because if you don't, it'll skip time. Basically, we want to make sure that every single iteration of this replay task lines up with a tick that we have in our recordables queue. Okay, so yeah, now we have a list of tick recordables, and this part we shouldn't have to change anything. So one more change that we have to make before we can actually test this out is we need to figure out how we can store the subtypes for recordable. Now, the thing is, these recordables here all inherit from the parent recordable, right? So MongoDB doesn't really have a way to automatically distinguish between the three different types of recordables, because if you think about it, if everything is a recordable and we store these recordables in a collection, that's fine. Like like I told you before, the data in a collection for MongoDB can differ, but when we convert it back from BSON back to Java objects, MongoDB doesn't know how to translate that BSON object into the proper Java object, because everything in the recordables collection is a recordable. How will it know which recordable to turn it into? How do you know if it's a spawn entity recordable, a location change recordable, etc.? We need to tell MongoDB how to distinguish between the different things. Okay, so luckily it has a feature for that. So to do that, we need to go to the top here under our annotations and add a new annotation, BSON discriminator. And for this, we're going to give a key value. So key is going to be called type. We're specifying the type. And then we want to say value, and we want to give it a name. So this name will uniquely identify this recordable from other recordables, okay? So we'll call it spawn entity. And then we'll just copy this and do the same thing for the other ones. So this one would be location change. And then this one will be despawn entity. There we go. And then finally add it for the parent class as well, the abstract class. add a bson discriminator with the key type, and then just give it a name that fits. In this case, it should just be recordable, I think, because it's an abstract and generic name for an abstract and generic class. So now we can go back to MongoDB service, our Mongo service rather, and now we just have to add it here. So that's going to be here in our codec registries, and then where we do from providers, we have this Pojo codec provider. So under builder, we want to add each of those classes. So we can do register, and we could do, for example, spawn entity recordable.class, and then we just add every single one that we have. So despawn entity recordable.class, and then we have location change. So that will tell it to look out for these 3 different types, and now we can distinguish between the 3 different types of recordables as well, so that whenever we use the recordable DAO and we try getting a recordable from the database, it can translate it properly into whatever object it is, right? Now, one more thing I want to do before we test this out is whenever we do stop recording, we are inserting the recording into the database, right? Now, this is a little bit of a flaw because we're overlooking one thing. So stop recording is going to insert the recording into the database and is going to assign it an ID at that point, right? But when we do add recordable, this is happening before stop recording is called because it's actively being recorded, right? So inside of this method, we are doing recordable.set recording ID. So if we're calling this one before this one, there will be no recording ID to grab. So this will obviously give a null exception. So what we need to do is make sure that we create the recording in the database before even stopping it. So we can do recording DAO.insert active recording.get recording, and that will just insert it into the database and assign an ID. And then right here where we stop it, instead of inserting it, we still want to update the information, right, to add the stop time and the stop tick. So we just want to, instead of doing insert, do update. So we're going to update the recording instead. So now inside of the add recordable method, we should still be able to grab the recording ID. So let's go ahead and throw this on the server now and test it out to see if there's any issues. Okay, back on the server, no exceptions when reloading. So now let's go ahead and do start recording. We still have our camera, which is awesome. So we'll do this one here. We are now going to run around. It looks like no exceptions so far, so that's a good sign still. We're just going to keep running around here. All right, now we're going to hop out, hop back in. Everything is still working. Now we're going to stop recording. No exceptions happened, so we can assume everything was probably saved to the database, which is a very good sign. But we still get these messages here, so for some reason it's still tracking us. So looks like we made a mistake somewhere. So let me go back to that'll be the recording service. So in the recording service, this will be for stop recording. So we called stop recording here, and that should have stopped the tasks that we had or canceled them. But it seems that it did not do that for some reason. So here's the issue, is because inside of recording, if we take a look at owner, we change that from a player object to a UUID. So this no longer really makes sense. We're passing in a player and trying to see if it's equal to a UUID. So we just want to do player.getUniqueID like that. So we're going to do start recording, this one here, round around a little bit. Now we'll do stop recording. And it says recording stopped and saved. You can replay with /replay. Awesome, and there were no exceptions as well, so that's another great sign. So yeah, the only thing left to do is just try replaying it first, and now we got an exception. So an exception occurred when decoding using the automatic Pojo codec. Decoding into a recording failed with the following exception. Cannot find a public constructor for recording. Please ensure the class is a public empty constructor with no arguments, or else a constructor with a bson creator annotation. And yeah, that checks out perfectly, because if we take a look at the recording class here, we have this constructor, but we do not have a no-args constructor. So that's exactly what I explained to you before. You need to make sure that when you're doing database stuff, you have a no-args constructor. So adding that should fix that particular issue. Okay, so now it actually loads the recordings. That's a great sign. The duration is definitely wrong. If you see that, it's negative, but we'll worry about that in a minute. But let's just try clicking one of these, and it's probably not going to work considering that's bad data right there. But the most recent one should be the first one. Boom. And yeah, we get an exception. Okay. So let's see if we can figure out why it's doing that. So the first one we get is decoding a recordable failed with the following exception null. A custom codec or Pojo codec may need to be explicitly configured and registered to handle this type. So a good candidate is probably the spawn entity recordable that we have. We can see that we have this data type here that we do not have a codec for, the entity type and so we need to create a codec for that so that it will be able to translate that to and from bson. So here's everything for that. I just want to make it easier by pasting it. This is for the bucket class entity type, or actually I think it's a enum, of course. So just like before, for decode, we're going to use our reader to read the value. So for encode, we're going to start a new document where we're going to write a string for entity type, and we're going to take this enum and convert it to a string by just calling .name, which is built into the enum. So then back here, when we do the decode, we can read the document, and we could read a specific field by doing bsonreader.readString entity type, which will give you the string version of the enum. But then you could use entity type.valueOf, which will convert the string name into the actual enum, and then you'll have that value now, and you can return it. So that's how that works. And then now we'll go back to our MongoDB service class. We just need to make sure that we register our codec that we just created. So that will be right here. So new entity type codec. So let's try that again. So we'll do /replay, select the camera, and then we'll do this first recording. And okay, so now we don't get an exception in the console, as you can see here. And then we get the recording is being loaded, use the controls, and then it says the replay is ended right away. So no exceptions. The only difference now is that it was not able to load the recordables, it looks like, because it just immediately finished. So we need to figure out why it did that. Let's go ahead and take a look at the database though to see what kind of data we have now. If we just go ahead and go to the top here and do refresh, it'll refresh all the data for us. And we could take a look at cameras, we could take a look at recordables, and you can see all this information about the specific recordables that we have. So for spawn entity, we have bucket entity ID, entity type, location, player name. Pretty cool, pretty cool. You have the tick, of course. So if we go to recordings, we could take a look at that as well. So we have recordings, and the issue here is actually probably not with loading the recordables. It probably has to do with the end tick and the end time not being set correctly. So the issue is pretty clear actually right away as I look at it. So we're calling update here and we're passing in the recording, but this is before we do stop recording, which is the method that actually updates the information. So it says the end tick and the end time. So that's why it's obviously not setting that data. So we just want to move this to behind, and that will fix it. All right, so since that data is bad, we need to go ahead and make a new recording here. So let's do that. So start recording, test. Okay, we'll just stop recording. All right, so that should have stopped it, and it should have saved everything. So now we'll do replay. Boom, and looks like the data is correct now. That's awesome. That's a great sign. So we'll go and click it, and there we go. Looks like it is playing the recording. Sweet. So this is great progress that we've made so far. Obviously, this is an insanely long video, but the progress that we're making is pretty good. I mean, if you coded this yourself, it's obviously going to take just as long. It's crazy. So if you're like, 6 hours in and you figured this out, that's amazing. It took me longer. But yeah, so now we are able to basically store everything persistently, which is a huge upgrade to our application. Now we don't have to redo stuff every single time, especially when we start testing our replay system. And that's pretty much what I want to do next. I want to make sure that we can start recording more stuff so that our replays are more enhanced. So we can record more actions that the player does. We can record changes to the blocks in our zone, all kinds of stuff like that. So I would say that probably the hardest parts of this are done now, because we've done the database stuff, which is pretty hard. We figured out, first of all, how to even make a recording and how to do a replay. That was really hard. Now we just need to add those extra features, then clean up and make sure that there's no bugs or exceptions, okay? So I think an easy win to start with will be to record when a player sneaks, when they hold shift and, they start twerking. I think that'll be nice to record in our recording and then replay later on. So the first thing that you would do is, just find out what packet controls that behavior. What packet do I need to send from the server to the client to show a NPC twerking? So just kind of look around, and obviously I already know what it is. It's the set entity metadata packet. So updates one or more metadata properties for an existing entity. Any properties not included in the metadata field are left unchanged. Okay, so obviously this doesn't provide much information besides, you're targeting a specific entity ID, but you also want to provide some metadata. So how do you do that? So you just click this, check it out, and you can see a bunch of information about entity metadata. If you just scroll around here, you can see that at the very top, you have a list of all the different entities that are supported by this. So if we want to look at, for example, if we look at the player entity, we can see that we have specific entity metadata that is only for players. So that's why you have these different like categories here for each entity type, because different entities have different metadata, right? So we just want to find one that sort of goes with what we're trying to do. So it'll be entity. And so inside of here, you just look around and we can see that for index 6, we have the pose option here. So for pose, we have a default pose of standing. So if we just click pose, this is a data type, we have all the different poses that are supported. And here they are. So standing, fall flying, sleeping, swimming, spin attack, sneaking, that's the one that we need, long jumping, dying, croaking, using tongue. I don't even know what the hell that's for. I mean, that's only something I do with your mother, but that's just crazy. Sitting, roaring, sniffing. That's some Joe Biden stuff right there. I don't know what that's about. Emerging and digging. So those are all the different poses that we can do. So we just need to figure out now how to pretty much call this packet within our code using packet events. And yeah, so how do we do that using packet events? Now, of course, this may be a little confusing at first because we have this, entity base class, right? And then we have all these different options here. They have numbers, so the indexes. So every entity is going to have 0 through 7. So these are all the different settings that every single entity will have for their metadata. But if you keep scrolling and you look at all the specific ones, you have higher indexes because some entities have custom metadata, right? So in the future, if you're dealing with a specific entity type, and you want to set something on it, let's say for abstract vehicle and you want to set the shaking multiplier, you would just target index 10. I mean, it's really that simple. But you would have to know ahead of time that you're dealing with an abstract vehicle before you try setting index 10, because if you set index 10 on another entity type that's not abstract vehicle, then you're targeting something else. For example, the loyalty level, if it's a thrown trident, okay? And one more thing, I want to scroll up here. So where we saw pose, when we clicked on pose, it took us here to all the different pose options here. So this is obviously an enum. But yeah, these are all the different data types that are supported for entity metadata at the time of recording. So these are all going to be automatically, in our code as well, like in the form of Java classes and enums and stuff like that. So what we want to do is go to our recordables package and make a new recordable. We're going to call this the sneak recordable. And then we need to add our annotation. So we'll just copy this from the other one like this. And then we'll just give it a custom name. So we'll call it sneak entity. And then now inside of here, what information do we want to store for this? So obviously we're going to be targeting a specific entity. So just as we do with the other ones, we want to do the bucket entity ID. There we go. And now we have to think about how we want to store whether they're sneaking or not. And this kind of plays into the way that we're going to be listening to this, because not only do you have to think about how you're going to record it specifically in terms of this data here, but you also have to think about how you're going to record it, through a listener, through a packet listener, stuff like that. So luckily there's actually a bucket listener that we can use for that. We just want to create a new Java class and we're going to call it the bucket listener. I know that's a very generic name, but this is going to encompass all of the things that we want to listen to that come straight from bucket. So inside of bucket, you have the player toggle sneak event. So this is called whenever the sneak is toggled off and on. So this is actually perfect for us to use directly. We don't have to use anything special like a packet listener because it's already built into it. So if we do event dot, you can see all the methods here, and we can see that we have is sneaking, which returns a boolean if they're sneaking or not. So whenever they press shift, this will be true. Whenever they let go, this should be false. I think that's pretty basic, right? So this means that in our sneak recordable, I think it's fine to just record a boolean, is sneaking. So now inside of here, when we, replay the recordable, we can use this boolean to determine what to set their pose to, either standing or sneaking. Hopefully that makes sense. So let's finish this part here. We need to actually do the recording now. So let's just get the player that's involved in this event first of all. So event.getPlayer. And now we want to determine if they're part of a recording at the moment, because if they're not even in a recording, there's no point in, recording their sneaking, obviously. So let's use the recording service for that. And I think since we're going to be using it a lot in this class, let's just go ahead and add it to the top. So recording service. And then in the constructor, we can either pass it in, or I could just do security camera.get security cam.get recording service like that. And then now down here, we could do active recording is equal to recording service.get player active recording, pass in player. And so this returns a active recording if a player is part of one. So we'll check to see if that's null or not. So if active recording is not equal to null, then we want to record them sneaking. So we'll do sneak recordable is equal to new sneak recordable. And now it's going to ask for the bucket entity ID. So that's going to be player.get unique ID, and then event.is sneaking. It's really that simple. And now to add the recordable to the recording, we do recording service.add recordable, active recording, and then recordable. There we go. So now we have a way of recording player sneaks. So we just need to make it so that we can replay in the replay the player sneaks as well. So that would go here. Now let's start by getting the entity that's involved in this. So var entity ID is equal to replay.getSpawnedEntities.get, and then we'll do bucket entity ID. So this is going to get the actual ID of the entity that's on the server currently for the fake NPC. And now let's figure out how we can send that packet, the metadata packet for this entity. So we can do wrapper play server. So it's a play packet coming from the server, and then the packet, as we saw, was the entity metadata packet. So that lines up perfectly. So we're going to call this the metadata packet is equal to new wrapper play server entity metadata. And so we kind of have two options here. We can pass in the entity ID, that's common, so we'll pass that in like that. And then now we need to provide either a list of metadata or a entity metadata provider. So luckily they make this pretty simple. You just kind of have to dig around to see how they, how to use it, since there's not much documentation on this right now. So we're gonna need a list, right? So a list of, what was it? Let's go ahead and verify what that was. Okay, it's entity data. So a list of entity data from packet events. There we go. And let's try adding some entity data. So entity data.add, and we could do like new entity data. And that's asking for an index and then a entity data type and then a value. So if you really take a look at this, this actually lines up perfectly with what we were looking at before on the wiki. So if we take a look at the wiki here, we see that for entity, let me just find it again. For entity, we have these different indexes here, then we have a data type, and then we have a value for that data type. So that's perfect. So in this case, the index that we want to target by looking at the documentation is index number 6. That's going to be the pose data type, and then we're going to set the pose to either standing or crouching. All right, simple enough. So index number 6. Now we need an entity data type, which is going to be built into packet events, like I said. So entity data type, and usually it's going to be plural. So entity data types dot, and now you have all these options here. So we can see right away we have entity pose. So since the data type is entity pose, we can probably do entity pose. Yes, we can. Dot, and then now we have all these options here like dying, shooting, sleeping, sniffing, standing, and then crouching is in here somewhere, or sneaking, whatever it's called. Crouching, there we go. So crouching, sweet. So now we could use this list of the entity data that we're trying to set and pass it into our metadata packet. So now we could do entity data list, just like that. And that should be it. So now we just need to send the packet. So user.sendPacket and metadata packet. Now we're missing one thing. Obviously this is going to be a toggle, right? So this is going to be true if they're sneaking currently, false if they're not sneaking. So this will be sent every time they either hold shift or let go of shift, right? So currently every single time that happens, whether or not this is true or false, it will, send the crouching metadata, right? But we want to make it so that if they're not crouching, obviously they're standing. So we want to make it be able to switch between those two options. So we could just do Control X on that, and we could do a ternary operator. We could say is sneaking. If it's true, then we'll do crouching. Otherwise, we can do entity pose dot standing. There we go. Oops. Awesome. There we go. So now it can determine, so now it can set the proper entity pose depending on if they're sneaking or not. Pretty cool, right? So hopefully that all makes sense. We're just crafting a packet to make it so that a entity changes their metadata. In this case, it'll be the pose of the entity. And this is going to be specifically the entity that is, kind of fake spawned in a replay. And then this packet will be sent to the person who's viewing the replay, and we have a user object for them. So now what we need to do is do a couple more things. We need to go to our Mongo service again and just make sure that we register our new recordable that we just added. So register sneak recordable dot class, and then we also need to register our bucket listener that we just created as well. So go to security cam, and then at the bottom here we could just add a section for listeners. Oh, we already have one, looks like it. Okay, so get server dot get plugin manager dot register events new bucket listener. All right, so now we have everything that we should need. So if this works on the first try, that's going to be pretty impressive. So I mean, yeah, there's only one way to find out. So let's go ahead and, throw this on the server and try making a new recording and sneak around in the recording and start twerking, and let's see if it can replay it to us successfully. All right, I'm back on the server now. So let's go ahead and make a new recording. So just start recording, select the first camera. Let's run around a little bit. Let's start shifting. That's pretty good. Okay. Now we could jump out of there. Let's run around outside and then jump back in. Start shifting again. And then now we'll stop the recording. Okay, let's check the console. No exceptions, that's a great sign. So now let me go ahead and replay that. Look at that, he's shifting exactly how we wanted it to. That is pretty impressive, right? So now he's gonna jump back in. Look at that. Amazing. It was really that simple just to add a new type of recordable to our application. So let's go and add another one. This one should be for sprinting. Something I want to show you is that if we like run around, it shows those little particles. That's because I'm sprinting right now. Pretty basic, but if I go and record that, let's run around a little bit. Let's take a look at how it replays. Okay, stop recording. Now we'll do /replay. Boom, boom. So you can see that he's like moving how you would move when you sprint around, which is nice, but it doesn't add the particles. I know that's a really, really small thing, but it's actually really easy to also start recording that. So if we take a look at the documentation again, so if we take a look at this metadata here again, we can take a look at the first one, and this one has an option for is sprinting. So this is a byte type, and then if you have the bit mask of 0x08, this means that the player is sprinting. So sending a metadata packet with this set will just show those particles that I just told you about. And then whenever they're done sprinting, you can do 0 because that's just the default. This is another easy win, I feel like, because in the bucket listener, there's another event for that, player toggle sprint event. And then we could basically copy all of the stuff we did up here, but make it for a sprint recordable. So we're going to make a new Java class sprint recordable. So this is going to have a bucket entity ID. This is going to have a boolean again, is sprinting. And then we could go to our sneak recordable and just copy all of the stuff that we did here, but make it work for sprinting instead. So we want to change the index from 6 to 0 because we saw that it's the first one, and then the data type was a byte. So we could change this from that to byte, and then now we change this from is sneaking to is sprinting. And then now, since the data type is a byte, we want to change this from crouching to 0x08. That's built directly into Java. You can just do it like that. And then for standing, it was just 0. Something you may have to do is cast this to a byte. I don't know if it's necessary, but I'm going to add that anyway because that's what I did originally. But yeah, hopefully you can understand what's happening here. I think it's a pretty simple concept. We're again just setting the same metadata packet, except that we're modifying a different index of the metadata so that entity is going to be sprinting or not sprinting. So before we can test this out, we've got to go back to our Mongo servers yet again and just add a new register sprint recordable.class. There we go. So now back in the bucket listener here, we can go ahead and modify this stuff here. So take all of that, and then we could change it from a sneak recordable to a sprint recordable. Sprint, and then sprint. Then now we could change this to is sprinting. And that's it. Literally all we got to do. And look at that. So you can see that it's playing the particles now. Right there. It's working. Awesome. So yeah, that was an easy win, pretty easy to add. So another one that we could do that's not too hard is the swing hand animation packet. So whenever they punch or anything like that, that's swinging the hand. So we want to make it so that whenever I punch in the recording, or an entity punches, not just me, any entity that's in the zone, that whenever the replay comes along, it replays that punch. So they can swing their hand both in the recording and the replay. Now for this one, there's no bucket listener that's going to allow us to listen for arm swings. There's not anything for that. So we have to do it via different means, which is going to be via packets. This will be a server-bound packet because whenever a player punches the air, for example, that will be sent from the client to the server so that the server knows to show that to other players on the server. So if we just scroll down to server-bound packets, and if we just take a look for a while, we can find the swing arm packet. So it's called swing arm, sent when the player's arm swings. And so it only has one piece of information, and that's just going to be what hand you swung, the main hand or the off hand. So now we just need to figure out how we can make a packet listener. So to make a new packet listener using packet events, we can right-click our listeners package and make a new Java class called and we could call this something like the packet listener, but that's a very generic name. So we definitely want to give it something that's a little more unique. We'll call it the security cam packet listener. I don't like that name either, but it'll work for now. And then we could do implements packet listener. Okay. And now we need to override the method. So code override methods, and we want to go ahead and override on packet receive, since this is a packet that we're trying to listen for that is sent from the client to the server. So the server will be receiving the packet. So we're going to do this one here. The first thing that we could do whenever the server receives a packet is get the player who sent the packet. So that's player, and then event.get player. And we can determine if that player is part of a recording. So we could do active recording is equal to, We'll do securitycam.get recording service.get player active recording, pass in the player. So if active recording is equal to null, then we're just going to go ahead and return because we don't care about anything else. So now at this point, since we know the player is part of the active recording, we can determine what type of packet it is. So we could do if event.get packet type matches packet type dot play packet, and then you have client because it's from the client, and then now you have all these different options here. Now, through all my testing, I figured out that is the animation packet that we want to look for. And it's really annoying to me that they called it the animation packet because on the documentation that literally everyone uses, it's called the swing arm packet. So maybe there's a good reason for why they did that, but I see that it's called the swing arm packet. So I think it should be called swing arm, personally. But anyway, we'll open that up, and then now we could grab information from that packet. So first we want to wrap it. So wrapper play client animation packet is equal to new wrapper play client animation, and then we just pass in the event, and that will automatically take the data from the event and wrap it into a object that we can utilize here. So we could do packet.get. We have get hand because that's the only information stored in the packet, so we can get the interaction hand, and this is probably an enum, right, or something similar, but yeah, it's an enum. But if we do .get id, this is returning an integer, right? And if we go back to the docs yet again, we can see that the hand has two options, main hand or offhand, 0 and 1. So I'm going to go ahead and safely assume that the ID represents these two values, 0 and 1. So now that we know that we can listen to the packet and then extract, certain information from it, we can go ahead and create a recordable to actually store that information. So we're going to do new Java class swing hand recordable. So this is going to be for a specific entity. And now the information that we want to store in this recordable should help us be able to know how to replay it. So the only information in that packet is the ID of what hand it is. So we could actually just store it as an integer. So private integer hand ID. So now let's go back to our security cam packet listener. So we can go to make our recordable. So the swing hand recordable is equal to new swing hand recordable. And then now we want to pass in the bucket entity ID. So we can get that from the player. And then now we need the hand ID. So we can do packet.get hand .get ID. We also have to add it though, so we'll just take this up here and do add recordable, recording, active recording, and then recordable, like that. So that's literally it. Just as a recap here, we made a new packet listener using packet events that listens for packets. We're overriding on receive packet because we want to listen to packets that are sent from the client to the server. So that's receiving. And then first we're determining what player is involved in the packet. So what player sent the packet from their client, and then see if they're in a recording currently. If they're in a recording, then listen to the animation packet and then, record that information. Now, something that we are overlooking that we're going to have to later fix is that this is actually not technically correct. So we're getting the player involved in the packet, right? And then we're checking to see if they're part of an active recording. This is not exactly true. This is checking to see, right, who owns the recording that is currently being recorded. This is not determining if they're in the camera or not. That's what we should be doing in the future. We want to determine if this is an entity part of a camera being recorded, if they're actually in the zone, not if they're the owner of the recording, okay? So that's a little bit of a flaw and an oversight, but I'm basically leaving it in here because we've already done this same method for our other listeners, and it's going to be actually not too hard to change it in the future because we just need to add another method inside of our recording service for that, okay? So hopefully you already noticed that, and if you're confused, that's why I still have it in there, okay? But this is actually not too bad because it allows us to still test the functionality of recording and replaying. That's the main thing that we care about right now, okay? So let's go back to our new, we already know what packet this is, so we could just use that packet in reverse to send it from the server to the client now. The name should be similar, so if we do something like var animation packet, we could do new wrapper play server instead of client entity animation. So this is the same packet but in the other direction from the server to the client. And now we need a entity ID and then an entity animation type. So the entity ID can be provided by grabbing it. So var entity ID is equal to replay.get spawned entities.get bucket entity ID. And we pass that in entity ID. And then now we need the entity animation type. So this is obviously going to be some sort of enum. So we could do something like entity animation type, and it gives us these suggestions here. So we have swing main arm and then swing offhand. So we want to switch between these two options here depending on what our ID is. So I'm going to take this and put this into a new variable. We'll say var entity animation. If it's equal to 0, then we know it's the main hand. So we could do entity animation type dot swing main arm rather, and then we could do entity animation type dot swing offhand. So now we could pass that in entity animation. All right, and that should be it. We just need to send it now. So user dot send packet animation packet. So this should give a entity a animation of swing main arm or swing offhand, depending on what they did, right? So let's go back to our Mongo service and register that. So register swing hand recordable.class. And now we need to register this packet listener as well. So we'll go back to our main plugin class. And we tried doing this originally. We can see that we commented it out. So we'll uncomment that part. And now we could register our new listener. We'll change the name here to security cam packet listener. And then we'll set the priority to normal. There we go. So let's throw this on the server and see if it works. Okay, back on the server. So do start recording. Same camera. Start smacking the air. I don't really know how to do the offhand thing. Let me give myself an item. Maybe I could do it that way. Put that in my offhand. Yeah, I have no idea. Maybe it needs to be a weapon. Let's try putting this weapon in my offhand. Oh my god, I have no idea. But anyway, let's just try stop recording and see if it does the main hand one. So we'll do /replay. And look at that. Boom, you can see him swinging his offhand. Perfect. Or main hand rather. Sweet. So something that you would have noticed now is that he does not have the item that he was holding. So I think that's a good next thing that we could work on is how can we show what players are holding and also what they're wearing, like in terms of armor and stuff like that, right? So this one's actually a little bit trickier than the other ones because in packets and with Minecraft there's no actual listener or packet that encompasses every single time a player's inventory changes. There's different packets that will be affected whenever something happens in the inventory, but these only happen on certain conditions and only in certain circumstances. So I could be wrong, but through all of my testing there's just not a single way to determine when a player's inventory changes. Like for example, if someone adds something to a player's inventory or they pick up something, all that kind of stuff. Like obviously there's bucket listeners that you can use for whenever a player picks up an item, and we'll work with that in a minute, but there's just not a single way to do it. So we have to think about an alternative approach. Now, first of all, what are we trying to record? We're trying to record what the player is holding and what they're wearing, right? And so it only really matters what we can visually see because, in the replay, we just want to see what they have. You could track their inventory if you want to. You can add that to the plugin that you're coding if you would like to do that, but we're only worried about what we can see on other entities. And luckily with Bucket, it's easy to grab that stuff. It's called the equipment. Every single living entity rather, has an equipment that you can grab that will give you all of their armor and then what they have in their main hand and also their offhand. So we're going to need a recordable to track their equipment, and we have to figure out how we're going to add those recordables. Like what listeners do we need to add to start recording that information? So like I said, since there's no single way to record whenever a player's inventory changes, we have to do this in a couple of ways. Now, the most easiest approach that I have thought of so far is to just make another task. It will get their current equipment and then store that. It'll make a recordable for that and then store it. So that will make sure that no matter what happens to the player's inventory, we always have a snapshot that's up to date of what they have in their, in their equipment. But doing that every single tick would be very expensive on the server's resources, right? Since we're accessing every single entity that we're tracking and then getting their equipment, all that. That could potentially be a heavy load on the server's resources. So we can make that one not as often as every tick. We can make it maybe every 5 ticks or every second rather, every 20 ticks. But another thing that we can do is if they change what they're holding, there's actually a packet for that, the held item packet. If they change what they're holding, then we can immediately grab their equipment and then store that information. That's something that we could do because the task would pick that up. If they switch what they're holding, the task, every so often would, update that. But if we want this to be precise whenever they switch items, then we can specifically grab their equipment at that point in time and add a recordable for that as well. So not only are we going to be recording player equipment every so often so that we always know what they have, but on top of that, whenever there's situations where we instantly want to know whenever a player's equipment changes, we can also make a recordable and record their equipment at that time. So that might have been a little bit confusing because I'm just explaining it without giving you examples. So I think it'll become more clear once we actually record this or start coding this part out. So what I want to do is start by listening to whenever the player switches their held item, because if we can figure that part out, we can instantly show that we are able to track their their equipment changes. And then after we figure that part out, then we'll do the task part, okay? So back in the code now, let's go to recordables and add a new recordable for that. It'll be the set equipment recordable. So here it is. We'll just leave it empty for now. Now there's no bucket listener that will be triggered whenever a player changes what they're holding, but there is the set held item server bound packet that we can use. So this is another simple packet that just has a short field type, and it just has the slot that the player has selected. So we're just going to listen to this packet, and then every time that it's received, we can go ahead and grab the equipment that the player currently has and then add a recordable for that. So that in the replay, as soon as they change what they're holding, it will reflect what they're now holding. So here in our listener, we'll just add another else. So we'll do else if event.getPacketType is equal to packetType.play.client.heldItemChange. Now we don't care about the data in the packet actually, we just want to know when they change what they're holding. So how can we get the equipment that the player has? So we could do player.getEquipment. Equipment, and this is a method available on every living entity. So with this equipment method, we can get a bunch of stuff like their armor contents, like specifically their chest plate, helmet, just all their armor, right? We can also get their main hand and their off hand, like that. So that's all the stuff that we want to record basically. So in our set equipment recordable, that's what we're going to be storing. So first of all, we're going to reference the entity that we're dealing with. So bucket entity ID, and we can store this multiple ways. I think the easiest way is that since the equipment gives you an item stack for every single thing, like for all their armor is an item stack, what they're holding is an item stack. I think it's easier if we just store an item stack for every single thing that we have here. So we could do, for example, private item stack helmet, and then for every single armor piece, we could add a item stack for that as well. That is all the stuff that will be displayed visually for a player and their equipment. So that's all the stuff that we want to store. So now we just need a codec that will be able to take a item stack and encode it as BSON and then translate it the other way around as well. So I go to codecs and make a new Java class, item stack codec, and here's the item stack codec code. I didn't want to type all that out because it's just a bunch of the same stuff pretty much. So to encode it, we're only going to be storing the type, which is just the material. We're just getting the name of the material, and then we're also going to store the amounts. So how many of that particular item. So item stack.get amount. That's all we need to be able to create a new item stack. So when we read it, we just get the material again, we get the amount, and then we can create a new item stack from that. If for some reason the type is null, meaning I can't find it, we're just going to return null for the whole thing, okay? Because we need the material no matter what to create a item stack. So pretty self-explanatory. Let's go to our Mongo servers to add that. So new item stack codec, and then we'll add one for our recordable as well. So register set equipment recordable.class. So now back here in our packet listener, we can go ahead and start recording that. So make a new set equipment recordable is equal to new set equipment recordable. Now it's asking for all of that stuff. So we'll do player.get unique ID, and then we'll just pass in all that stuff. So, and then we'll use the recording service to store that recordable. There we go. So now every time a player changes their held item, it'll send the packet, and we'll just record their equipment at that point in time so that we can store that and then reflect it in the replay. Let's write the code now to replay this. So replay.get bucket entity ID. Now the packet that we'll use for this is the wrapper play server entity equipment. So this packet will allow you to update entity's equipment, and it's going to ask for an entity ID, which you already have, and then a list of equipment. So make our list of equipment here. Now this is going to be equipment though from packet events. So list of equipment, that's going to be different from the equipment class from bucket. So just make sure you are aware of that. Equipment list, or just do equipment, is equal to new array list. And then we can do equipment.add, and we'll just add equipment for every single thing that we have. So new equipment, and we want the equipment slot. So the equipment slot is going to be the main hand, and then we could pass in main hand. But of course it's asking for a packet events item stack, not a bucket item stack. So we could use the Spigot conversion util to convert from our bucket one to the packet events one. So we'll do main hand like that. So now we have added an equipment for the main hand, and we'll just do the same thing for every single one that we have. So we have set our list of equipment now, so we'll just pass it in and then send that to the user. So user.sendPacket. So it's as easy as that. So now this packet will be recorded every time the player changes what they're holding. So in the replay, it should update what they're holding and what they're wearing every single time they do that. That's the only time that we're recording the set equipment. recordable. So if they don't change what they're holding, but they equip some armor, for example, that will not set a recordable for that. We have not recorded that stuff. We're only doing it whenever they change what they're holding, okay? So let's start by testing that out before we can add the other stuff. All right, I'm recording now, so I'm in the zone. I'm going to add something to my inventory. So this will not do anything, but if I switch my hand now, boom, that should be showing now that I'm holding a sword in the replay. Now I can switch to a diamond sword. It should show that now. And then I could go back to air. So let's take a look at what that looks like. Okay. So it doesn't look like it worked. Oh, there we go. So we got the sword now. Now we got the diamond sword. Now we got the stone sword. Now we got the air. Okay, so it is working. It just took a little bit. Sweet. So now that we know that we can record equipment changes, what we want to do is make it so that it records their equipment all the time, no matter what, because equipment can change in different ways. They can get their inventory changed by someone else if they're an admin through another plugin. They can, equip new armor. They can take armor off. They can pick stuff up, all kinds of stuff, right? So we just want to make sure that no matter what happens, we always record the latest equipment that they have. So what we're going to do for that is make a task that runs every so often that will get a snapshot of their equipment and then store it. All right, so let's go to the tasks package and make a new Java class. We'll call it the equipment track task. So this will be tied to a specific recording. So private final recording. Actually, this would be a active recording, right? So active recording, and then we could change this to active recording. There we go. So every time we start recording, we're just going to make a new task like we do with the other stuff. So we really want to do this the same way pretty much that we're doing the track location task. So we're going to get all of our recordable entities, the stuff that we're currently tracking, and then we want to do synchronize so that we're not messing anything up. And then for each of the recordable entities, we want to just go through each of them, right? For each recordable entity, and we want to get their current equipment. Let's make sure that it actually exists on the server because we don't want to get a null exception. So entity, if it's not equal to null, then we can go ahead and grab their equipment. But first of all, we need to make sure that's a living entity because equipment is only for living entities. So like, it wouldn't work for an arrow, obviously, because arrows don't have, equipment. That doesn't make any sense. It would be stuff like players, skeletons, anything that can wear stuff. And then while we're at it, let's do and living entity dot get equipment is not equal to null. So let's just go ahead and steal this, the set equipment recordable, take this and then paste it here, and then we'll just change player to living entity. So no matter what type of living entity it is, we're just going to track their equipment. There we go. So securitycam.get recording service.add recordable, recording, and then recordable. So now let's go back to our recording class, our active recording class, and actually start this task whenever we create it. So I'm going to make a new bucket task up top, bucket task, track equipment task. And then I'll do this dot track equipment task is equal to bucket dot get scheduler dot run task timer security cam dot get security cam new track equipment track task, pass in this for the active recording, and then also the delay, which is 0, and then the period, this is up to you. You can like sort of fine tune it to whatever you think is best, but I'm going to do it to every second. So that's going to be every 20 ticks we go in and update the equipment for a specific entity, which I think is fine, really. So it's going to be like a slight delay, really, but every second is a lot. Like every second we're getting the current equipment and storing that. So in our replay, it won't be like totally precise, but every second is still really, really precise in my opinion. So that's going to be everything that we need for this to work, I think. So now no matter what we do, whether they switch hands or they equip some armor or whatever, it should always have their latest equipment shown on the entity, okay? So let's go ahead and try this out. Okay, we're going to start recording. Now I'm going to give myself some armor and stuff. So boom, boom. What am I doing? Let's give myself some armor. Okay, so let's put this stuff on. So I should be updating as I'm doing this every second. Let's also give myself some stuff that we can hold, just random stuff. So we should be wearing some armor now, holding chicken. Now we're holding a cookie. Now we're holding air. We can put this in our offhand as well. So now we should be holding a cookie in our offhand and a piece of chicken in our main hand. We can also take off some of our armor. Let's get naked. And now we should be running around like a madman naked with raw chicken. I love to do that on a Saturday. And yeah, so that should be it for that. So now let's stop recording and let's replay it to see if it works. Okay. There we go. I'm putting the armor on. Sweet. Now I should be able to hold these items in a second. Got our chicken. Got our chicken. Got our chicken. Got our cookie. Nice. Sweet. Got our cookie in our offhand now. Oh, there we go. Got our chicken. Now we're going to take off our clothes. Look at that. Freaking amazing. I don't know about you guys, but I think that's really, really cool. Very happy with the result that we have so far. Now, if you want more precision in certain circumstances, like whenever they put their armor on, then you just need to find a way to listen to whenever their armor changes, and then record set equipment right then and there, just like we're doing for the switch held item packet, okay? Another one that I think we should do is the entity hurt animation. So whenever you hit a entity, it glows red for a second and all that. I think it'd be nice to have that recorded in our plugin. So for that one, it's pretty easy. We just listen to the bucket event for the damage events. So whenever entity takes damage, we record that, and then we can replay it later on using packets. Okay, so let's go back to our code now. And I think now is actually a good time to fix this method that we're doing here. So we're doing get player active recording. Instead of that, like I said before, we want to make it so that we get the active recording for any entity if they're being tracked currently by a recording, not just whoever owns the recording. Because someone who owns a recording doesn't necessarily mean that they're in the actual camera at the time when we call this. So I think it's nice if we make another method similar to this one, where instead of going through all the active recordings and looking for the owner, we look for the tracked entities. So I think we should go through this and do recording.getRecording.is entity being tracked. I think we have a method for that. Let me pull it up here. So in active recording, we have, is entity being tracked. So we want to call this one not on the recording, but on the active recording, like this. Okay, and then now we just pass in the entity that we're trying to check. So in this case, it wouldn't be a player, it'd be an entity. So entity, import entity, not from NMS, but from bucket. And then we could do entity.get unique ID. Okay, so now we have the get player active recording, but we want to call this get entity in recording. So this will return a active recording if the entity is actually in a recording, okay? So let's go back to our bucket listener now, and let's change this here. So we do get entity in recording, and this happens to pass in a player, but it can be any entity. In this case, we're dealing with player toggle sneak, so it's fine to pass in a player because that's only 4 players. We'll do the same thing here for this one. All right, cool. So now we can come here and we could do active recording. Recording is equal to recording service dot get entity in recording event dot get entity. So now we could do if recording is not equal to null, and now we would make our recordable for that. So let's go ahead and create the actual class for it. So new Java class entity hurt recordable. So for this one, we don't really need to store any information except for the entity that was hurt. So now we are detecting if an entity is damaged, and then if they are, then we make a recordable for that and add it. We just need to make sure that we go ahead and add that to our Mongo service. So first let's register the recordable itself. So entity hurt recordable. There we go. All right, cool. Now inside of here, we need to figure out what packet we can use to replay that animation. And here we go, we have the hurt animation. So plays a bobbing animation for the entity receiving damage. You pass in the entity ID and then a yaw, the direction the damage is coming from in relation to the entity. We don't really care about that, but yeah, this should do it for us, I think. So let's go ahead and try this out. So for the L, we don't really care about that, so I'm just going to do like a random value like 90F. And we'll just see what that looks like. And we'll do user.sendPacket, damage packet. Alright, so let's go ahead and test it out to see if this actually works or not. So I'm going to go to test it out on the cow. So what I'm going to do is create a new camera, create cam cow, and I'm just going to make sure that I get him in an actual zone here. So we'll try that, and then we'll try this, and that should make him inside of it. Okay, so we'll create that camera, and now we'll do we'll start recording it. So start recording cow. We'll walk in this. It is tracking the cow. I'm checking the console as I do this. Now we're going to hit the cow. Boom. Oh, boom. There we go. So I've hit the cow. He's going to run around like crazy because he's angry. Going to hit him again. All right, now let's stop recording. Okay. So a little bit of lag there. That's probably because we can make our tasks a little more efficient. But for now, let's not worry about that. Let's try replaying it. Boom. Boom. So here we go. We've got the cow. We've got myself. And boom. There we go. So it does replay the hurt animation when I hit him. So that works exactly how we want it to. Perfect. So we're actually making really good progress here. We're almost done recording anything that has to do with entities. After this, we're going to do some block stuff. We're going to like track block changes and whatnot. But one of the last things I want to do for entities specifically is whenever they pick up items. So whenever you pick up an item, let me just show you. Let's just get ourselves an item here. So let's drop it on the ground. And watch what happens when I walk up to it. It gets like teleported or vacuumed into my body essentially. So it looks weird, but it has like an animation, right? There's also a bucket event that is triggered whenever you pick up an item, right? So what we really care about is how to replay that packet back to, someone who's watching this happen. And there is a packet for that. So what we want to do for this, I think, is create a new bucket listener that whenever someone picks up an item, it records that, and then we're going to use the packet that's sent from the client to the server, or sorry, from the server to the client to replay that inside of the replay, okay? All right, cool. So we have the entity pickup item event. So from this, we can get information about the entity involved, the item that was picked up, the remaining items on the ground. Okay, that's pretty good. So let's go to make a recordable now since we know what information we could store. So we'll call it item pickup recordable. So here it is, but we should actually make the item drop recordable first because we need to actually have an entity to pick up to be able to, show this. And the way that you have an entity to pick up is by having one that's dropped, right? So we're going to make another recordable called the item drop recordable. So here it is, and then we're going to go to our bucket listener, and we'll add another event handler for that. So on item drop. There we go. So from this, we can get information about the item that was dropped, the item that dropped it. Yeah, pretty basic. So let's go to our recordable now and start figuring out what we want to store inside of that. So this item drop recordable is going to be a little trickier compared to the ones that we've done so far, because it's not really obvious on how you can simulate an item being dropped. There's no packet directly for item dropping, okay, but there is one for picking up items, so that's why it's a little trickier. So I think it's helpful to start by figuring out how to replay it, and then as we do that, we'll also specify the information needed for the replay. So with the research I did, making this plugin, I figured out that the way that you can simulate dropping an item is by spawning an entity, just like you would for spawning a player or an NPC in just any kind of NPC, like a cow, for example, right? You do the same thing for items, because whenever you drop something from your inventory to the world, that just spawns a new entity that is shown up on the ground. So that's how you would simulate that. So what we can do is just take the code that we use when spawning entities and just borrow it to spawn items as well to drop it. So we will basically just take all of this, go back to item drop, paste it, and let's just change it around a little bit. So we're going to need all of this to be able to create an entity ID. We definitely don't need this part because we're going to be having the same entity type for everything that we drop. It's just going to be item. So spawn entity packet, wrapper, place, server, spawn entity, entity ID, UUID. We're going to need the entity type. So this is going to be entity types.item, like I just said. And now we're going to need a location, and we could pretty much just grab that from the bucket listener, because on this listener here you can do event.getItemDrop.getLocation. So that will give you the location of where the entity basically is being dropped from. So we'll just store that in the recordable. So private location, and then down here we can now do Spigot conversion utils dot from bucket location, and then we don't really care about these last three things. We're going to keep it just how it is. So we're going to also need to store the bucket entity ID that represents the entity that we're sort of simulating or replaying. So just like we do with spawn entity recordable, we store the bucket entity ID of the thing that we're trying to spawn a fake NPC for. So we want to store that as well for the item that we're trying to, respawn using packets. So we'll add a thing for that. So private UUID bucket entity ID. So this will be the item entity. So all this is saying now is that whenever we replay this item drop recordable, we spawn a new entity that will represent this bucket entity ID that we had, and we're going to store it in our spawn entities map that we have to know which entity is representing that entity that we have in our recordables, okay? So same exact concept as spawn entity recordable, except that we're doing it specifically for items. And you may be wondering, why don't we just, in that case, use the spawn entity recordable? What's different between this recordable and the spawn entity recordable is that we actually need to add another packet to this after we spawn the entity that will tell it what item stack it's going to represent. Because if you think about it, if I spawn an item entity on the floor, like, what is it going to look like? We haven't told it what item stack material type to even look like. So we need to specify that information, and we could do that with the entity metadata packet that we've already used before. So if I just pull up the documentation again, if we go to entity metadata, all we have to do is just find the one specifically for items. So here it is, and it only has one index for 8, and it says the type is slot. And if you take a look for slot, if you just keep digging into the documentation, it says slot is an item stack in an inventory or container. So yeah, like I said, this is just you telling in the entity metadata what item stack this item should appear as. So that's how we're going to specify that. So if I just go back to my code now, and I go to the sprint recordable where we're using metadata, we'll just take this and just steal it for our entity drop recordable, paste it here. We're going to change the type to item stack, and then we're going to change this to the actual item stack, right? So we're going to need to store that as well. So private item stack, and then we'll pass it in. And now I'm going to just take this thing. We don't really need a list anymore. And I could just do list.of and pass that in. And I'll just rearrange it like that. So what this will do is spawn the entity, then send a second packet to set the metadata of the entity. So that's telling it what item stack to represent it as. And that's pretty much it. So hopefully it'll work. We just need to go to our bucket lister now and actually create the recordable for that. Okay, so here we go. We're creating the recordable. So it's using the unique ID of the entity for the item drop. It's getting the location of the item drop and then also the item stack represented by the item drop. Now we could do recording service .add recordable recording item drop recordable. But there's one thing that we cannot forget is that, again, this is not only doing a item drop recordable, it's also spawning a entity. So we need to make sure that we start tracking that entity that we just spawned. So I could do recording.add entity if not already being tracked. And I could just pass in the recordable entity for that. So new recordable entity. So I'll get the unique ID. So events.get item drop get unique ID. And then now we want the bucket entity type. So it'll be entity type from bucket dot dropped item. It won't be item, it'll be dropped item. There is a slight difference. Okay, so if we did everything correctly, that should be all we have to do. So there's only one thing left to do, which is to test this out. We just need to register our thing now. So inside of here, we can do register item drop recordable. There we go. All right, let's try it out. Alright, so the issue is that first of all I was using the entity drop item event, and for some reason it didn't like that, so I changed it from that to the player drop item event, and it works perfectly now. I think that makes sense anyway. We only really want to track this for players. But after trying it again, now we have a different problem. It says error processing recordable from the replay task. Bucket inventory item stack cannot be cast to packet events item stack. So right here we're using a bucket item stack, so that's correct. And then down here we're passing in that item stack without converting it. Okay, so that's the problem, it looks like. So we just need to take this and do spigot conversion util dot from bucket item stack, pass that in, and that should hopefully fix that issue. Alright, so I'm gonna go ahead and replay that. Test, boom. So I'm gonna try dropping some grass here in a second. There we go. Works perfectly. Awesome. And you saw them like despawn a little bit. That's actually correct, because when you drop multiple of the same item, they will group together, see? So it's like despawning and respawning as a group. So That's why when you drop a bunch of items in a recording and then some of them disappear, it's because it's mimicking that behavior of the other ones are despawning and then grouping into the main one. So just in case you notice that. Anyway, so that's perfect. I'm glad that works now. So now we just have to make it so that you can pick up those dropped items if you want to. So this one's a lot easier because there's a packet directly for item pickup, and it's just an animation that shoots the item into your body as we saw. So let's go ahead and do that one now. So we're going to need to store two things. So private UUID, we're going to store the person who dropped the item, but you also want to store the item itself. We're going to rename this though, dropper bucket entity ID, and then we'll do item bucket entity ID. Okay, so with that information, we could do this. Dropper entity ID is equal to replay.get spawn entities.get dropper bucket entity ID. Item entity ID is equal to replay.get spawn entities.get item bucket entity ID. And then now we could do wrapper play server collect item. I don't know why it's called that, not pickup item. Packet is equal to new wrapper play server collect item. So it's going to ask for the collected entity ID. So that's going to be the item entity ID. It's going to ask for the collector entity ID. That's going to be the dropper entity ID for us. Or I don't know why I just named it dropper. I just noticed that. Hopefully you guys picked up on that. So this is going to be the, I guess we'll call it collector. Collector entity bucket entity ID. Okay, so now we could do that. And it's also asking for the pickup item count, which I don't really think is necessary, so I'm just going to set it to 1. All right, so now we could do user.sendPacket, packet. Awesome. All right, so now let's go ahead and register this in our Mongo service. And then in the bucket listener, we can go ahead and finish this part as well. So we need the collector bucket entity ID. That's going to be from event.getEntity.get unique ID. And then we need the ID of the item, so event.get item.get unique ID. And then we could change this from player to get entity. So let's go ahead and test it out now. Look at that. It's working perfectly. So cool. Okay, so now we have item drops and item pickups. We're now recording that as well. And I think that's the last thing regarding entities that I want to do for this. Now, of course, there's a billion other things that you could also add recordables for, but I think that's a good starting base so you can see how to add a bunch of different recordable types. Now you should be able to take that knowledge and also add your own custom recordable types. What I want to do now is figure out how to record block changes. So basically, not only do we want to record the entities that are in our camera, we also want to record the state of the world that's in our camera, okay? So what I'm thinking is, what we want to do is take a snapshot of the world as it is at the time of when you start the recording. That way, when we do the replay, we can change the world to look like as it was when the recording actually happened. Because I don't think it makes sense to replay a bunch of entities doing stuff in a world that doesn't match the world they were actually in at the time. So here's the game plan. Let me repeat it. So the game plan is to take a snapshot of the world at the time of recording, at the very beginning before we even do anything. And then after that, we're going to record every single block change. So that'll be block breaking and block placing. And then when we replay the recording, we want to change the world to look like how it was at the beginning, and then also show every single block place and also every block break, okay? And then at the very end of the replay, we want to change the world back to how it actually looks like. So how the fuck do we do that? How the hell do we change a world to look like something is not? And the answer is, my friends, packets. You can do everything with packets. So we're going to send a block change packet to the player to tell them that the blocks are changing to a specific other block, but they're actually not. It looks like it's going to be changing, but it's not actually going to be changing. So it's kind of crazy. When I first figured this out, I thought it was mind-blowing, but yeah. So yeah, we can change reality basically for what a player sees, not only with entities, but also with the world itself. The first step will be to get a snapshot of the world whenever we start recording. So let's go to our recording class. And here we just want to store every single block in the camera region. So I'm going to do private list. And I'm actually going to store a list of materials because one, materials can be translated easily into strings. And also we don't really care about any of the other information inside of the block class. We only really care about what the block is. It's a material, and so let's just store the materials. So we'll do original blocks is equal to new array list. And then now, when we start the recording, by instantiating it, we want to set the original blocks based on the camera that the recording is tied to. So the active recording is what stores the actual camera object. So I'm going to go ahead and do that in that class. So I'll close everything else. Let's find active recording. So inside of active recording, we instantiate recording. So right after right after we do camera as well, we can do this.recording.set original blocks, and then we could make a new method instead of camera, so this.camera dot like get original blocks or something like that. So let's go ahead and go to camera, and here it is. I don't think there's really a point in me pasting or typing all that out. So it's just literally going to go through every single coordinate in that camera region one by one and add the materials to that list and then return it. So yeah, pretty simple overall. So now back here we could do get materials in region, and that will be the original blocks of the recording. So now when we replay the recording, we can set the world to look like how it looked like when we actually did the recording. So here, after we create the replay, we're going to go ahead and make a method called place original blocks. So let's add that method here. So private void place original blocks. We're going to pass in the recording because that's going to have all the original blocks stored. Then we're also going to pass in the player viewer. That's the person that we want to send the package to that will show them what the world should look like. And so we're going to borrow some code from here. We're going to take all this and then put it inside of here. And then we want to sort of refactor it so that it fits this current use case. So let's start by getting our list of original blocks. Material original blocks is equal to recording to get original blocks. Then we'll have our corners as well. So var corner 1 is equal to, I'm going to change this one to active recording because then we could grab the actual camera involved. So active recording dot get camera dot get corner 1 var corner 2 is equal to active recording dot get camera dot get corner 2. So the reason that I copied this is because this is looping through all of the coordinates of the region in a particular way, in a particular order. So I just want to make sure that it loops in the same order because everything in the list here that we have in the original blocks list is stored in that particular order. So if we were to access it in the same order that we placed it, then we won't have any issues. So we're going to have a variable index is equal to 0. This will keep track of the current index of the original blocks list. Now we're going to get the material. So material is equal to original blocks dot get index. And then we want to use a packet to show the block changing to this material. So this would obviously be a client-bound packet, and we want to find one for block changes. So it should be this packet here, the block entity data packet. Sets the block entity associated with the block at the given location. So by a location, we can set the type and also add other data if we want to as well. So let's see if we can figure that out using packet events. So the packet that we're going to need is the wrapper play server block change, and then we're going to do block change packet is equal to new wrapper play server block change. Now we're going to need a block position and then an integer block ID. Okay, so let's start with the position. This is asking for a vector 3i. We can create one by doing vector 3i position is equal to new vector 3i, and then just pass in the xyz. So we can do xyz, which is from the nested loops that we have here. Now for the block ID, we need to get a wrapped block state. So var wrapped block state is equal to wrapped block state dot get default state, and then into that you can pass in a state type, or you can do a client version and then the state type. And there might be a better way of doing this, but the way I figured out how to get a state type is by doing this. So var state type is equal to state types dot get by name, and then you can pass in a name, and the name is going to be started with Minecraft colon, and then you could do material dot name dot to lowercase. Now I'm pretty damn certain that there's a way better way of doing this. This is kind of a hacky way of doing it, but I literally cannot find out how to get the ID of the state, because there's another method you could do is state types dot get by ID. I just don't know how to find that ID. Okay, I don't know what to do. So if you know how to do it, please let me know. I'm very curious on how you can get that information. Basically, we just want to take this material here and get it in a wrapped block state so that we can provide the ID to our block change packet. Okay. Anyway, so this is how I found out how to do it. So we have a state type now, and we could pass that into this here, and then with that wrapped block state, we can do wrapped block state dot get global ID. Yeah. So that's how I'm gonna do it. Let me know if you know a better way of doing it. Okay. So now we just need to send that to the viewer of the replay. So we can do packet events dot get API dot get player manager dot get user, and we're going to pass in our player, or actually that's called viewer, send packet, block change packet. There we go. And then at the very end here, we just want to increment our index. So every single iteration of this nested for loops that we have here. We're just going through every single coordinate. We also want to increment the index because this index is how we grab stuff from our original blocks list here. So just as a little recap here, what we are doing is we're storing all of the original blocks that were there when we started the recording, and then later on when we place these original blocks, we're going to get the list and then just go through all of the coordinates of the list in the same way that we stored it and just place each block one by one using a packet. So the world to the viewer of this replay should look differently if the world was changed after the recording. So what we also need to do now though is get the actual blocks at this location. So a very similar method. So instead of place original blocks, we're going to place actual blocks, because at the end of the replay we need to show the player what the world actually looks like in reality. Again, this is sending packets, so it's giving the player a fake view of the world. So we need to make sure that we can reset it so they can see what's actually present on their in the Minecraft server. So we can get rid of this here, and we're going to do block is equal to world.getBlock at, and then we just pass in the x, y, z. So this will get the actual block at this xyz coordinate, and then from that we can get a wrapped block state pretty easily. So actual block state is equal to Spigot conversion util dot from bucket block data block dot get block data. So that will give the block state, and then we could just go ahead and use it actual block state. We still want the position though, so let's keep that in there. But yeah, that will do the same exact thing. We don't really need the index anymore as well. That's not necessary. Boom, boom. So this is just looping through every single coordinate in the camera region and then just getting the actual block at that coordinate. And then it sends the player a packet to show them what the world actually looks like, the actual material in that place, in that block. So we can get rid of this as well. So let's call this one we stop the replay. So let's scroll up here. So stop replay. Let's call it right at the bottom here. Place actual blocks. Active recording. And I have no idea why I changed this to an active recording. It does need to be a recording because there is no active recording. It's from a replay. So recording, and then from that we could just do recording, and then we need to just grab the camera at this point. So var camera is equal to camera DAO. We don't have a camera DAO, right? So let's add it to this. So private final camera DAO, like that, pass it in. And then now down here we could do camera DAO dot find by ID recording dot get camera ID, and then now we could use it directly. So camera, we don't need this. Okay, so that fixes that. So now we can scroll up here and we can place the actual blocks by passing in replay dot get recording and then pass in the replay dot get viewer. There we go. Same thing here as well. So replay.get recording, replay.get viewer. So now that should fully work. There's only one thing left to do, which is test it out and also update this constructor here. So camera DAO. All right, so I'll see you on the server in 2 seconds. All right, I'm on the server now. So before I start recording, I'm just going to make some modifications to the world so that we know that it's working properly. So I'm going to put a little wiener right there. And then, yeah, let's start recording now. Let's make sure we open the console as well so we can verify there's no errors. Okay, so no errors so far. So we can just run around this thing. Okay, and then let's go ahead and stop recording. Alright, recording is stopped and saved. So now let's go ahead and remove this. And then let's replay it. And look at that. It instantly placed all the blocks. He's running on top of it, as you would expect. Looks amazing. Freaking perfect. I can go on top of it. The crazy thing is that those blocks aren't even there. It shows you that they're there, but they're not actually there on the server. Because again, we're using packets. So that's where that just blows my mind, honestly. It's so cool to me. Really, really cool stuff, and I hope you like it as well. So yeah, we found a way to make it so that we can make our replay show the world as if it was at the time of recording, and then at the end we actually revert the world back to its actual state. Pretty freaking cool stuff. So now what we have to do is fill in the gaps and make it so that you can place blocks and break blocks as well. So let's make recordables for that and figure that whole part out. So we're going to make a block place recordable, and we're going to make a block break recordable. And then also we can make bucket listeners for that. We don't have to rely on packets for this because, as you should hopefully know, there are bucket listeners that will do all of that for us. So public void on block place event. Now, lucky for us, the logic that we have to use inside the replay is the exact same as we do it in the replay service whenever we place the original blocks. So we just take all of this here. Let's go back to our block place recordable, paste that, and we just have to change some of this. So location.getBlockX, location.getBlockY, and location.getBlockZ. And then now the viewer will be, we can get rid of this actually, just do user.sendPacket. And yeah, everything else should be the same. So it's the same thing. We're just calling the wrapper play server block change packet and sending that to the user. And let's go ahead and update our Mongo service as well. So register block place recordable.class and register block break recordable.class. And then for the block break recordable, since you're breaking a block that's turning it into error, all we have to do is store the location. So let's do that. Here we go. And then now we can just take this, where is it? Block place. Let's take all this yet again and just put it inside of here and just change the material to always be air. So we'll do the state type will be state types dot air. So sending the same packet but setting it always to air for block break, which I think makes sense, right? Now it's easy in the bucket listener. We just pass in the event.getBlock.getType and then event.getBlock.getLocation. And then we can do recording service dot add a recordable, recording recordable. And then we'll copy this, paste it on block break. So that should be it. That should be all we have to do. Let's go ahead and test it out to see if it works. All right, I'm on the server now, so let's go ahead and go in creative. Let's give myself this block. Let's start recording. Boom. Let's start by just breaking this block here, breaking this one. Let's go and place some more. Jump on top, break them. That should be a good test, I think. All right, now we'll stop recording. So when I start the replay now, it should get rid of all these blocks I placed and show me exactly what I just did. Look at that. It's working perfectly. Sweet. So now we can track not only what happens to entities and what they do, we can also track block changes to the world. So I don't know about you guys, but I think that's pretty freaking awesome. So this is pretty much all I want to record in the plugin. I think this is a lot of information to get you started for if you want to add more stuff. I gave you a ton of examples at this point. So now what I want to do is just make this plugin better. The first thing that we can do is make it so that you can pause the replay, you can restart it, and you can end it if you want to. So we're going to add some controls basically. So let's try doing that now. I'm going to start by adding these items here. So these items will allow you to control the playback of the replay inside of your inventory hotbar. So we have the restart button, the play button, the pause button, and the done button. What I also think we should add is a boss bar so that you know where the replay is at in terms of its playback. So just like a YouTube video, there's a progress bar. We're going to have the same exact thing. So at the top here, let's go ahead and store a private, the boss bar. And this is going to be from net.kiori.adventure.bossbar. This is from the adventure library. So when we create the replay, we're going to also create the boss bar. So this dot boss bar is equal to boss bar dot boss bar, and then now we can give it a name. So component dot text, and we'll say replay progress, and then we need to give it the initial progress, which is just 0. It starts at the beginning. And then we could give it a color. So boss bar, we'll say color green, and then boss bar overlay. So the overlay is just like what type of boss bar it is. If you do a notched boss bar, that's like 6 segments, 10 segments, 12 segments, 20 segments, or you can just have a generalized progress bar that takes a float value 0 through 1. So that's what we're going to do. And then every time we update the boss bar, we just give it the corresponding like float for that out of 1, 0 to 1. So now we need to do 2 things. We need to make it so that it updates the boss bar, but also we need to make it so that these controls actually do stuff, right? Let's start with the boss bar because that's easier. So we're going to go to our replay task for that. And then right before we get the tick recordables, let's just also update the boss bar as well. So update boss bar, and we can say replay.getBossBar.progress. So the progress is just, we could do some simple math here. So we could get the current tick and divide it by the amount of total ticks, right? So that would be something like current tick divided by replay.getRecording dot get duration, get tick duration, and we just have to cast this to a float. There we go. So divide the current tick by the total amount of ticks in the entire replay or recording, and that will give you the current progress that we have for this replay here. So that should update automatically now, which is nice. And while we're here, let's also make it so that we can control the playback. So what we're going to do is add a variable private boolean pause, and this is going to be true by default. And so pause will control whether or not we're going to increment the current tick or not. So at the very top here, we're going to say if it's paused, then we're going to just return, so it does not run any of the code. It's just going to keep looping until the pause becomes false. So this is a way of preventing it from continuing, pretty much. And then at the bottom here, we can add some basic controls that will help us with that. So we can start with public void restart. So we could say this stop pause is equal to true because we're starting at the beginning. And then we could do current tick is equal to 0 to reset it back to the start. And then we could do public void play. So this is going to just unpause it, of course. And then we could do public void pause. So do this dot pause is equal to false. Now the replay is where this task is stored. So this is where we're going to actually call these controls here. So inside of here, we can add some more controls or more methods. So we could do public void restart replay. And we could do viewer dot send message restarted replay, press play to start. And then we could do replay task dot restart. And we can't call it just because of how we're calling, how we're storing our task here. So I'm going to make a slight change. What I'm going to do is instead of storing the bucket task, we're going to restore the actual replay task class itself. And then down here, we could take this entire thing, move it onto a new line, and do new replay task, pass in this. You also want to go here and change this to replay task, and then just run it directly on top of that, because replay task is now a bucket runnable, so it can just be called directly. And then you could also get rid of this as well. So that will still make the replay task and then schedule it just as before, except that we're storing the replay tasks directly so that we can now call the method within it. So restart like that. Here's the same thing for play and pause, just sending a message telling them what's going on and then actually calling the control on the task. Now there's no cancel as well, so all we have to do to fix that is go to our replay task and change it from a runnable to a bucket runnable. And then make it extend it, not implement it. And now back here, we can call cancel, just same as before. Also, after you create the boss bar, you want to do one more thing. You want to do securitycam.get adventure for the adventure library. And then you want to do player, pass in the viewer of the replay, and do show boss bar, and then pass in the boss bar. That will actually make it appear to that player. Let's also go down here real quick and do viewer.getInventory.clear inventory, so that's just so that all the items are removed when we're done, doing the replay, okay? So now that we have these methods in the replay class, we need to actually call them somewhere. So we're going to go ahead and do that within a listener. So we're going to create a new listener for this actually. So new Java class, we're going to call it the replay listener. So anything inside of here deals with replays, of course. And then we're going to listen for whenever they right click the items in their hotbar, right? So public void on right click player interact event. So we're going to get the action by doing event.getAction is equal to action.rightclick air, or event.getAction is equal to action.rightclick block. And then now that we know that they're doing that action, let's make sure that they're actually doing a replay currently. So we'll do player is equal to e.getPlayer. And then we could do replay is equal to replay service.getReplay for player, pass in the replay. If this is null, then we're going to return. Otherwise, we're going to get the item that they clicked on, event.getItem.getType. If it's the first one, so this is going to correspond to the items that we added at the top here. So this is going to be a repeater, a green banner, a yellow banner, and a lime banner. So we'll just add a case for each of those options. So for play and pause, I think I'll just make it simple. Just call play replay, and then replay.pause replay. For the stop one, we're going to call the replay service because we already have a method inside of that for stopping it. That calls some extra logic that we want to handle. So we can do replay service dot stop replay, pass in the replay, easy peasy. Now for restart, we also want to add some extra logic on top of that one. So let's go back to the replay service and add another method for that. So we'll do public void restart replay, pass in the replay that we want to restart. First things first, let's reset the world. So we'll do place original blocks, replay.getRecording, replay.getViewer. This is because if you're restarting the replay, we want to make sure it looks like how it looked like when we started the replay from the beginning. So obviously we want to replace those original blocks again in case they were changed. We also want to make sure that we remove any entities that were spawned in case they were not already despawned. So we could do this piece of code here, just despawn everything. And then after that, we can finally just call our restart replay method here, which will tell the task that we want to restart and just, So now back in the listener, we can do replay service dot restart replay, pass in replay. Now we'll go back to the security cam main class. Let's register our new listener. So get server dot get plugin manager, register events, new replay listener, pass in the replay service, and then this. All right, cool. So that should be, I think, it. I don't think we're missing anything. So I think with these basic additions that we just added, we should now be able to control the playback of our replay. Okay, so let's try it out. Okay, back on the server, I'm going to do /replay now. Select it, and look at that. So we have our progress bar at the top. We have our control, so restart, play, pause, and done. Let's just try playing now. And okay, it is playing. It doesn't look like the boss bar is being updated. There are no exceptions though. So, okay, that's not good. That is because I got these two things backwards, and hopefully you notice that. So if I'm playing, the pause should be false. And then if I'm pausing, the pause should be obviously true. So that was a silly mistake. And then also in the replay listener, let's go ahead and add one more thing. At the very end here, inside of the if statement, let's do e.setCancel to true so they don't place their items down whenever they are using the controls. Alright, so I'm going to do /replay. Select it, boom. So we got everything still. We're going to go to play. So it is playing now. You can see the progress is updating, which is really cool. We can pause, and he freezes. And also the progress bar freezes, so that's working still. Pretty cool. We can continue now. Pause again, continue, pause again. Wow, that's pretty awesome. Let's try also restarting it. So boom, looks like it did restart it. So boom. Oh, we got an exception now. So one thing that we also want to do when we restart the replay is re-queue all of the recordables. So we have to load them again and then just add it to the queue again. So I'm actually just gonna, so what I'm gonna do is take this code and move it into a method so that I can reuse it easily. So take all of this and go like that. And we'll do public void load recordables. We're going to pass in the replay that we're trying to load it for. Paste that. And then now we'll do Reocrding. Reocrding is equal to replay.getReocrding. So it's going to get all the recordables, sort it just like it did before, and then add it to the replay. So now we could just call that load recordables, pass in the replay, copy that, and then just add it down here as well. We also want to make sure that before we do this, the current queue is reset because we're just, going to be reloading everything. So let's go ahead and do that. We'll just do replay.get recordable queue.clear. So now every time we restart, it'll clear everything, reset everything, but also reload all the recordables and add them back to the queue so they can be loaded again. Okay, we're going to replay. Take this, boom, play it. Nice. Pause it, restart it, play it again, and look at that. Perfect. Boom. 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 It's so seamless. It works perfectly. And then now we can also test the done one. So boom. Look at that. It resets the world. Everything's finished. Pretty freaking awesome. One thing that we forgot is just to get rid of the replay bar, the boss bar. So let's go ahead and add that as well. So for that, we can go to replay and then go to end replay. And right up here, we could just do securitycam.get pass in the viewer. And then we could do hide boss bar, and then this dot boss bar is equal to null. We could also send a message if we want to. So we could say viewer dot send message replay ended. There we go. Okay, so I've identified something that we should probably change. In our active recording class, we have this recordable entities queue that we're using to track the entities that we're currently tracking. But we use this recordable entity class that has a bucket entity ID and an entity type. But I just now realized, like tons of hours into this, that we don't even use the entity type at all. This is something I added probably when I was first making this, and I thought I was going to need it, but I didn't. So there's no reason to have this, and therefore there's no reason to even have the entire recordable entity class. We could just directly store the UUID instead. So let's go ahead and make that change. So we're going to change the queue from a queue of recordable entities to a queue of UUIDs, like that. So now we could totally delete the recordable entity class. See ya. That's nice. That's kind of satisfying to remove stuff like that. And then now we just need to change everywhere we have that. So instead of passing in a recordable entity, we're going to pass in a bucket entity ID. So now here in the onItemDrop events handler, for example, we can change it from doing a new recordable entity to directly just passing in the unique ID of the entity, just like that. And let's just go ahead and compile this so that we can automatically get the errors that will show us where all the broken files are. All right, so that's all done being refactored. So let's go ahead and test it out just to make sure we didn't break everything. Okay, it's working perfectly. You saw him disappear for a second and then come back in with a different skin. That's just because he left the zone and then we had to respawn a new entity when he re-entered the zone. So at this point, I think I'm happy with the state of this plugin in terms of like recording everything that we want to record and then figuring out the logic for replaying stuff. I just want to make a few changes to make this a little more efficient. So the first thing that we could do is if we go to the recording service, if we see inside of the add a recordable method here, every time we add a recordable to an active recording, we're instantly setting the recording ID and adding it to the database like right away. Now, recordables are going to be recorded every single tick, potentially, right? Or even multiple times per tick. That's a lot of data to be inserting every single tick, which is 1/20th of a second. So it'd be way more efficient if we store these in memory, not all at once, but in a buffer. So the way that a buffer would work is we store a certain number of recordables until it reaches a certain like threshold, and then once it reaches that threshold, we then bulk insert all of them into the database all at once. That way we don't have to insert everything as soon as we get it and create a bottleneck for our database because we're just inserting everything like so fast and all the time, and that's just a lot of data to be inserting. So yeah, a buffer of some sort would make this a lot more efficient in my opinion. So inside of active recording, we're going to add a new collection here that will represent the buffer that stores our recordables temporarily. So let's do it here. We're going to do private queue of recordables, and we're going to call this the recordables buffer. That's going to be equal to a new concurrent linked queue. And I'm doing another concurrent collection here because this recordables buffer will be accessed in many parts of the application for many different tasks as well. Because think about it, where am I adding recordables to my application? I'm calling this method in a lot of different places. If we hold Control and click, you can see all the different places that I'm calling this in like 3 different tasks, and the listeners as well. So because of that, we want to avoid the same issue we had earlier with concurrency exceptions, and we're just going to make it so that we use a concurrent linked queue. So now back in the recording service, instead of inserting it right away, we're going to get rid of that, and we're just going to do recording, or active recording rather, dot get recordables buffer, and then just add it. So we're going to add the recordable to that. And now, like I said before, a buffer is something that holds a bunch of things until it reaches a certain threshold. So like maybe, for example, 20 recordables. So we want to see if the buffer should be flushed. And flushed just means that it should be all bulk inserted into the database, right? And the data should be removed from the buffer. So I'll go up to the top now, and what I'll do is make a constant private final, we'll do like an integer max recordables is equal to, and we'll set it to like 100 maybe. Actually, we'll do 1,000. So now we can scroll back down here. So now we can do something like if active recording dot get recordables buffer dot size. If the size of it is greater than or equal to the max recordables constant, then we want to go ahead and flush recordables. So this is going to, like I said, remove all the recordables from the queue and then insert them into the database. Okay, so let's make a method for that. So we'll do public void flush recordables. We're going to pass in the active recording for that. Now we have to be very careful how we do this right here, okay? We need to make sure that this is not susceptible to concurrent modification exceptions, or just making sure that the data is correct. So basically the problem that we have here is that we have a queue, right? And this queue can be accessed and always modified at any point in time, right? So since the purpose of this method here will be to flush the current recordables in the queue, what we should do is take a copy of the current contents of that queue, copy it into another queue, and then flush it. The reason we have to take a copy is because if we just directly loop through the contents of the queue, for example, and just remove them one by one, that would be an issue because while I'm doing that, something else could be adding more stuff to the queue. So obviously that would not be correct. So let me just show you what I mean. I'll try explaining it even more, okay? So let's just start off by making this an asynchronous operation because this is something with the database, so we don't have to do this on the main server thread. So we're going to do bucket get scheduler run task asynchronously. We're going to pass in the main plugin instance. Then we're going to do a new lambda here. Let's open that up. So now we want to copy the buffer into a new list and clear after. So we want to do queue. I'm going to say recordables. We're going to call it buffer copy. And what we're going to do is synchronize again. Synchronize this. We're going to say buffer data, or buffer copy rather, is equal to new linked list. And we're going to copy the data from the current recording.get recordables buffer. And then we could do recording.get recordables buffer, get recordables buffer dot clear. I'll explain this in a second, but after this, what we want to do is figure out how to bulk insert all of the values in this recordable queue here into the database. So let's first convert it into a list. So a list of recordables list to flush is equal to new array list, and we could just pass in the buffer copy collection. It will automatically translate it for us. And then now that we have a list of data, we can easily insert that to the database by doing recordable DAO.insert mini. We don't have a function for that, but we'll add one in a second. Insert mini list to flush, and that should be it for now. So let's go back to recordable DAO and add that. So we're going to add a insert mini function here. So public void insert mini, pass in a list of recordables, and we want to do return collection insert mini recordables. It's really that easy. Oh yeah, and we don't need return. We just want to do that. Okay, and now we can see that that method is working. So let me explain this now. So what this is doing, it's obviously spawning a new asynchronous task to run all the stuff here because this can take a second. So we're making a new queue here that will hold all of the data that we're copying from the recordables buffer. So this part here, the synchronized, is making it so that only this asynchronous thread can access the recordables buffer at this point in time while we're copying it from the recordables buffer into the buffer copy and clearing it. Because if we don't synchronize and for some reason another thread is doing something while we're copying it, then obviously that would like sort of corrupt the data, right? To put it as simply as possible, we want to make sure that while we're copying the data from the buffer to the new buffer, the data is not modified by something else. That's exactly why we have to do it like this. So now after it's done copying it and it clears the buffer, we can release the synchronization, and then all the other threads and tasks can do whatever it usually wants to do with the buffer. It can add new stuff, it can do whatever it wants. So now we're taking the data that we just copied from the original recordables buffer and putting it into a list, and then inserting all the recordables into the database all at once. So hopefully that makes sense. I know it's a little confusing for the first time if you're looking at it for the first time, but yeah, that's exactly what it does, okay? One other thing that we need to do though is make sure that only one flush can happen at a time. So kind of similar to how we have to synchronize this part so no other threads can modify the buffer while we're doing stuff here, we have to also make sure that we're not calling this method multiple times. And you may be wondering, why would it call it multiple times? You know, we have it just here in this one place. The reason is because we're adding so many recordables every 1/20th of a second, and it's just happening so fast that this can be called once, and then again so fast that if the first invocation of this method passes this condition here and it goes ahead and starts flushing, while it's flushing this data, another call of this method here could activate and pass the condition because it hasn't been flushed yet, and then start flushing again. So what we want to do is create another lock mechanism so it can only flush if it's not already flushing. It kind of sounds like I'm designing a toilet right now with the way I'm talking. So it's not too hard to achieve this. We'll go back to active recording and we add another variable under this one. We'll call it private volatile boolean is flushing. And I'm going to be completely open and honest with you. I don't exactly know why we have to use volatile, but with the research I've done, volatile is when you know that a variable can be accessible through multiple threads and modified by multiple threads. So it's usually a good idea to use that. I don't know if we have to in this case, but I'm just going to add it there because that's what was recommended to me when I was working on this. So now with this variable, this will obviously control whether or not the buffer is currently being flushed or not. So we just need to make sure that we can set this variable in a way where it does not create issues. So if we scroll down, we can add some methods here for that. So we're going to make a public synchronized boolean try start flushing. So inside of this, we're going to say if it's not currently flushing, so is flushing, then what we want to do is is flushing is equal to true, and then return true. Otherwise, return false. So the code inside of this is pretty simple, right? It's just saying if it's not flushing, then start flushing, and then return true if it is actually flushing now. Otherwise, just return false. So the reason that we have this here is just like before, we just want to make sure that while one thread is working on this code here, another thread doesn't come in between and start changing it, because that can create inconsistent results and, concurrent modification exceptions and whatnot. What we can do is go back to a recording service here, and right here where it passes the first condition to check to see if there's enough recordables to flush, we can also add another one, and that says active recording.try start flushing. So if this returns true, this means that it wasn't currently flushing and we are now flushing. So it's going to return true so that it indicates that you can continue and actually start flushing. You have now achieved a lock on this method here so that you're the only thread that can call this method here at the moment. And we're going to go ahead and add another method, public void end flushing. We're going to do is flushing is equal to false. And then we could call this one at the bottom here. So active recording.end flushing. Okay, so with all this code here, even though it's a little tricky to understand, in my opinion, we should now be able to store recordables temporarily in a buffer, and then every so often it will flush those recordables into the database whenever it reaches a certain point. And that will make everything a little more efficient because we don't have to insert every recordable right away. Something that we should not forget though is at the end of the recording, let's say it doesn't reach the threshold and there's still leftover recordables that need to be pushed into the database. If we leave it how it is, it's not going to handle that. It's just only going to flush only when it reaches the threshold, right? So we should add something and stop recording so that at the very end, if it's done recording, just make sure we get rid of everything else that we have that wasn't already flushed. So I'll do that right in between here. So in between stopping the recording and updating the recording, we're going to go ahead and do flush recordables, pass in the active recording, and there we go. All right, so let's go ahead and test it out now to see if it works. All right, I'm on the server now, so I'm going to start recording. Camera 1. I'm going to run around a little bit. And we'll know if it's working or not if there's no exceptions. Beep, 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 beep. All right, now we're going to stop recording. Okay, now we're going to replay it. Here we go. There's my character. So there were no exceptions during running that, so we did everything correctly, which is a great sign. So now that we made the recording process a little more efficient in terms of the database operations, we could also do the same exact thing for the replay system. So currently when we replay something, we're grabbing all of the recordables for the recording directly from the database all at once, and we're storing that in memory. Now think about if the recording gets pretty big, that's a lot of data to be storing in memory, right? So we definitely probably shouldn't be doing that. We should probably do another sort of buffer where we only load a certain amount of recordables, and then just before we run out, we'll load some more. And we have to do it in a way where it's smooth and it doesn't, get choppy, because just like a YouTube video, we don't want it to buffer, right? So this is going to be another complicated little thing that we have to add, but let's go ahead and try it out. So we already have this recordable queue here that holds all of the recordables that we want to replay. All we want to do is change this from just a regular queue linked list to a concurrent queue, because just like before, this is going to be modified in multiple places, so we want to avoid any possible issues. Let's also add another lock variable like we did with your recording. So private volatile boolean loading data. And this is going to be false by default. And then down here we can create some methods for that. So we have try load data, and then we have done loading data, same exact concept as before. So the way that this one works is you're going to call try load data so you can see if you're able to load data or not. If it's currently loading data, then return false, meaning that you're not able to load data. Otherwise, set this to true, so you're locking it, and then return true, telling you that you're able to start loading data yourself. And then we have this one for, setting it to false when we're done. So let's start with this method here. We want to start changing this one up a little bit. So at the very top, let's go ahead and check to see, make sure we are not already loading more data. So we're going to do if replay try load data. If this returns false, this means we cannot load more data, so let's just return. Otherwise, we can start loading more data. So currently, we're just getting all of the recordables part of a recording by its ID, right? So we want to modify this one to only get the recordables from a recording within a certain tick range. Because the idea is, right, we're not loading everything all at once. We only want to load stuff within a certain number of ticks. So let's just imagine if we're at tick 0, then we would load maybe the first 100 recordables, for example, right? Or 1,000 maybe. We have to figure out a way to actually do that. So I think when we call load recordables, we should pass in the current tick so that we know what data to load. And then now up here where we call it for the first time, we'll just do 0 because this is where we're actually just starting it, right? Same thing for here as well. So if the current tick is where we should start loading recordables, we need to figure out the end tick. So what is the highest tick that we want to stop getting recordables for? So we'll do something like long end tick is equal to current tick plus 100. So if the current tick is 0, then we'll get the next 100 ticks, or 100 recordables rather. But let's just say that we're at the end of our recording, or replay rather, and let's say that we're at tick number 45 and there's only 50 total ticks. Then we need to add a way to cap that. So we could say if end tick is greater than .getRecording.get tick duration. If it's greater than that, then we want to go ahead and cap it at end tick is equal to replay.getRecording.get tick duration. So now we don't really want to clear the queue here because the whole purpose of this will be to load more recordables than what we have currently. So we're adding to the current queue. So let's get rid of this and we'll put it somewhere else later on. But now we want to modify this method here so that it's not giving us every single recordable. It's only giving us the recordables in the current tick to end tick range. So we'll go here and we'll say long start tick, long end tick. And let's just change the method name as well. So find by recording ID and tick between. And then now in our filters, it's pretty easy to sort by that criteria. So we just add more filters. So filters dot greater than or equal to tick, start tick, filters dot less than equal to tick, end tick. So all this will do is still get all the recordables with the recording ID of the one that you passed in, but also get every single recordable that has a tick that's greater than or equal to start tick, and then also less than or equal to end tick. So now we can go back to our replay service and call that method. So this would be current tick and end tick. There we go. Now we just have a conflict between this local variable here and this parameter. So I'm going to change this one to start tick. Just like that. Now what I want to do is just take all of this here, every single piece of code, to try, put it inside of a try, and then add a finally. And then the finally will release the lock by doing replay dot set done loading data. Because since we're achieving a lock here using that boolean that we have, if for some reason this fails and we had this inside of here, then this would never be called and the lock would always be there, meaning that we can never load new data. So I think it makes sense to take all of that, put it inside of a try, and then add a finally, so that even if this fails for some weird reason, we can still release the lock so that something in the future can just try again, basically. We also have this for loop here that loops through all the different ticks that we need to group together for our recordables. So we just need to change this from the tick duration to the actual end tick, because that can differ. So let's get rid of that and just do that end tick. There we go. Also right here, instead of doing 0, set that to start tick, and that's just because we are not starting at the beginning and trying to load every recordable. We're loading only starting at the start tick. So just make sure you change that value right there, and that will fix any issues you have. So now in the replay task, this is where we can actually call this method to load more recordables, because currently we're just calling it in the replay recording method and the restart replay method, which is just when you initially load recordables, like the first 100, but we also want to call it when we run out, or when we're about to run out inside of this task here, because this is where we control the current tick. So this is where we can see when we need to start loading more. So we'll make an if statement and say something like replay.get recordable queue.size, and we want to see when it drops below a certain number, like maybe 100. When it drops below 100, we want to start loading more if we can. So we want to get where we have to start. So that'd be next tick is equal to current tick plus the replay.get recordable queue dot size. So this will take whatever the current tick is, get however much data we have left in the queue, add it together, so that gives us the next tick that we need to load data for, or start loading data for. So we could do replay service dot load recordables, pass in the replay, pass in the next tick, and what that should do is automatically load more recordables onto the queue for us. We can add another if statement under this that says something like replay.getRecordables queue.size, or just, how about this, if it's empty, then if it's empty, this means that we have no recordables in the queue, but it is unpaused. So what this can mean is that it's currently loading recordables, meaning that it's maybe buffering. So let's just add an output for that. We'll say buffering, question mark. We want to have it so that it never reaches this point, of course, because we want to load them in a way that is smooth so that it never actually runs out. But if it does, we want to print that message out so we know what's happening, and then also just return, because we don't want to run any of this code here until we actually have recordables to process. So with a big change like this, there's a lot that could go wrong, but I think there's only one thing left to do, which is just to compile it and throw it on the server and just see what happens. Okay, let's try it out. So let me go ahead and replay a recording here. This one, this one. All right, and boom. See if it works. Okay. Looks like by the console I was able to load more stuff. Wow, it's working perfectly. No exceptions or anything. Sweet, it worked on the first try. I'm actually really surprised by that. So that's freaking awesome. So yeah, I think that's a good stopping point for making the replay stuff a little more efficient. So now we're not loading every single recordable all at once. Every time we do a replay, we only load the data. We only load a little bit of the data, and then every so often we start loading more data just as we need it before it runs out, okay? I don't know about you guys, but I think that's freaking awesome. And I think this is pretty much where I want to stop, guys. So if you've watched through this entire tutorial, leave a comment below telling me that you did. I don't believe you, to be honest, but do it anyway, because this is an insanely long video. And if you actually did watch it, I appreciate you a lot. I really, really appreciate you. I put a lot of work into this. It took many, many, many days of recording just for hours and hours and hours and hours. And the editing took a long time as well. So thank you so much, everybody. Just thank you anyway for watching my videos at all. I really appreciate all of you guys. And you can expect more videos from me now. Just leave suggestions, join the Discord, leave suggestions, and I will try my best to do some of them, okay? But yeah, anyways, this was making a replay plugin. Hopefully you found this very interesting. I don't know about you guys, but I learned a lot about how to do packets along the way, how to do a little bit of NMS stuff with, spawning entities. Now I feel a lot more confident whenever I need to make a plugin that uses packets, because we learned how to use many different types of packets. So I think learning a new packet shouldn't be all that hard. Hopefully you found that informative, but also the MongoDB stuff I thought was pretty cool. I learned a lot about that along the way as well. How to make sure that we can store polymorphic types in a MongoDB database, how to make codecs and stuff like that. That was really cool to figure out. I just really hope you guys who actually watched this tutorial learned something from it. That would make me happy if you did learn something from it. And yeah, hopefully you can make your plugins even better now. If you guys want to see more advanced series like this where I just show you how to make an entire plugin, then let me know. This was hell to make, but if you guys want to see more, I will do it. So just let me know as well. And yeah, I think that's all I got. Just make sure you check the description for all the source code and everything like that. And yeah, consider becoming a member if you want to. That's just an easy, cheap way to support me. You can become a member on my YouTube channel, or you can click the Buy Me a Coffee link below if you want to. All of that is optional, just if you feel like it. And thank you again for watching my videos. I do appreciate you. And that's it. So thanks for watching, everybody. Peace. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace. Meow, 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 meow.